anytime when somebody says AI is crap. So there will be no delving into anything in this talk. Now I've titled my talk AppSec Rules Agile. Who knows what AppSec is? Okay. It stands for Application Security. So if security is not your bag, if you don't think it's agile, you don't have to stay here. I've instructed, I have a good relationship with security, they haven't locked the door. Honest, you can escape. Now in my LinkedIn profile, I titled myself as an AppSec snooper and an agile fundamentalist. And I thought, I'll bring those together for a nice little talk. Now, AppSec, I have had some experience. I've run application security program for the UK's premier tax collection agency, HMRC. I haven't shaved my beard off, so that's why I don't quite look like my avatar. But despite my young-looking exterior, I have got quite a lot of years of experience. I started out as a developer. I've sort of worked with a lot of different places, big, some small, some agile, some less so. And then I sort of pivoted into application security because I essentially kept finding fun stuff. It all started when I found a commented out line in a configuration file that meant that a payload wasn't encrypted, which meant that I could inject my own commands into an interaction. Now, don't worry, it won't get technical. I want to talk about why security, application security specifically, is actually an agile thing to do. And also, it's not something that you can only use in like modern pipelines. It applies to legacy as well as it does to anything. And the way you do it makes a lot of sense. Now, let's start this talk with Harry. Harry is my son. He loves jigsaws. He starts school in September. And this was a photo from his play and stay, which happened yesterday, which gave me a bit of a problem because I needed to come down here to Cornwall, but I wanted to do it. Now, I had a look at the trains, and yes, 4 changes to come down from the northwest of England with 10 minutes stops. I don't know, I don't quite trust the British rail network to get me here on time. I know that in Japan, you get a personal letter of apology if the train is a minute late. I was in Holland the other day and they told me that they consider the German rail system so inefficient. And I was thinking, if the German rail system is inefficient, have they come over here? I don't know. Anyway, I promised AppSec and Agile. And what does my journey down here in my car, where I hoped that the clutch wouldn't give out because the other day it stopped working and I could only change gear when I switched it off. What has that got to do with Agile? Well, maybe it's a good metaphor. Sometimes you have to look at how things work, how are things going before you can sort of really continue. Now, it's about a year ago that we had that McKinsey article. For those who don't know, the McKinsey consultancy published an article about measuring developer productivity. It was widely rubbished as being something ridiculous. There were articles and rebuttals by Kent Beck, Dave Farley, did a good one. My personal favorite is Dan North's, which if you get a chance, read it because I quite liked it. The thing that triggered me about it was that it had this lovely little image where it describes development as something where there's an inner loop where you code and build and test, and then have an outer loop where you deploy and have meetings and integrate, and oh, we need to stick security in there somewhere. And what got me was that they were sort of saying you have to maximize the inner loop, get people to write code as quickly as possible and minimize the outer loop. And I thought, well, surely that's not right. I mean, do you really want to only consider sort of security and compliance right at the end of at the end of your process? Security is more than an afterthought. I mean, who here, show of hands, has had to deal with a pen test that was done 2 weeks before you released your software? Okay, that is normal. Now let's be realistic. Who here had to deal with a pen test that was done 2 weeks after you released your software and then found lots of things, and then you kind of go, oh, well, we maybe have to accept this as a risk for now, and I know we've found lots of wrong, but let's have our fingers crossed and nothing will happen. Now, when I started my sort of journey as a developer, this is the picture I've had of security. Somebody who lives in their ivory tower, hoards all the secret information, and occasionally comes down with decrees on why you can't do something and why you don't get to release this time, because in their security assessment that helpfully happens 2 weeks before release, they found some issues. And the old ivory tower analogy. Now, it also works the other way around. This is something that has happened to me very recently, where I was in a meeting and the head of security was told, right, we now need an assessment about security about this for this particular project. And he was screaming, well, why did nobody tell me about it? When we work in silos, as we still often do, I know we're at an Agile conference, I know that, but we have to be realistic. Sometimes Agile is this, the Agile Scrum fall. And to make things worse for security is, like we discussed, is somewhere over here. And it doesn't help that usually developers and security sort of just think of each other as the enemy. I mean, I've had plenty of time when I wanted to do something and then security said no, because this particular piece of software is not on our approved list and we would have to do an assessment. And in order to do that assessment, you can raise a ticket and we will get back to you in 6 months' time, we promise, unless there's something else. And conversely, I've also seen the other side where security kind of looks at what developers try to do and sort of, don't they understand? Can't they realize that what they're building is just a bit idiotic? We have policies and procedures for a reason. Somewhere hidden on a Confluence page that nobody ever reads because you can't find anything in Confluence. So that brings me to this little thing. I did say at the beginning that I'm an Agile fundamentalist. And what I mean by that is not somebody who will stuff Scrum down your throat or who will insist that you have all the ceremonies and meetings or tries to sell you an Agile certificate. No, I call myself a fundamentalist because to be honest, I came to this manifesto late in my journey. I was so used to working with Word documents that describe the high-level design and then writing another Word document that is the low-level design and then having endless meetings about it that I accepted it as normal. And it was only after I started working for the premier UK's tax collection agency where I found actually there's another way. We had a project which on the outside looked very, very unappealing. It was take this bit of software out of a data center, lift it, and shift it into the cloud. You think, this is a death's doornail job, isn't it? Nobody would want to do that. And funnily enough, I stuck around 6 years, because not only did we lift it and shift it, we also improved it, we ran it, and this was the project where I found that single commented outline where this caused the whole thing to be insecure. I later found a lot more interesting things, and it gave me that application security career. But the one thing that really impressed me is that when we started this lifting and shifting exercise, we were working out of an office in a cafe. It wasn't an office, it was a co-working space. We had sticky notes. And it was a real joy to sort of say, okay, well, we'll move stuff. We were doing really quick stuff every other week. We sort of moved something else. And that kind of made me read the Agile Software Development Manifesto in a slightly different light. One of the biggest things for me, my favorite thing, is that individuals and interactions over processes and tools. So I'm thinking maybe security and development, application security, can do something similar. The first one, I think I'll just steal verbatim. Individuals and interactions over processes and tools sounds like a good thing to do, even when it comes to security. Now, typically when we talk about application security, we talk about supply chain issues. This is the ship that crashed into the bridge and that shuts down entry and exit into the port. Now, when you think about things like the who's heard of the Log4Shell vulnerability? Yes, there are some Christmases ruined, weren't there? Bit of background, a very popular library that was used was found to have a vulnerability that if you put in an input, it can cause a remote code execution vulnerability. And because it was an open source library that was used in lots and lots and lots of places, suddenly everyone in security needed to check, are we affected by it? And then they said, thank God we're not. And then they discovered, have we checked our instance of Jira? Ooh, have we checked the whole supply chain was affected, which is why one little thing can cause a massive, massive problem. Now, the issue with supply chain vulnerabilities is that I think at the moment there are about 86 new CVEs, which is short for common vulnerabilities and exposures, which get raised when there's vulnerabilities, get raised every day. And you can see that it's trending upwards. This is from a guy called Jerry Gamblin, who keeps track of all this and runs lots of little stats tools to show us how bad it is. What some of you might not know is that at the moment, the National Vulnerability Database that is being run was underfunded for a couple of months and wasn't actually doing anything. So there are about 13,000 vulnerabilities that haven't yet been classified, which means that typically tools don't pick them up if they haven't been classified, because you need to say this vulnerability is this particular score, this vulnerability affects this particular library. If you don't classify it properly, then you don't know where it is. Now let's be honest. Which organization doesn't do this? Which organization doesn't do, all right, we have 5,000 vulnerabilities. We have no way of going through that all because we have so much to do. And we need to release this really, really quickly. Can't we just please, for this one time, disable the pipeline? Which then inevitably happens because somebody accepts the risk. And then you push that critical update out, and then you promise, really, we'll switch it back on, which obviously never happens. And this here, this sort of 5,000 known vulnerabilities in 230 projects. This is from a recent gig, and this is not a big project. It is amazing how many vulnerabilities, how many different dependencies we all got in our software. And obviously, no talk shall go without AI. We have got some vendors that promise us to solve everything by, I have to admit, I used a large language model to make up these quotes, but I think they were quite good, weren't they? Unleash the power of AI, proactive, intelligent, and comprehensive cybersecurity solutions. It says nothing, but still. There is a habit in cybersecurity to have processes and tools over individuals and interactions. So you throw money at a problem so that you can tick a box. Anyway, I want to go back to these vulnerabilities. And a lot of the time, the tools build on something called the CVSS score, which is a nice little mouthful of the Common Vulnerability Scoring System, SCORE. Because who doesn't love an acronym that contains the thing? Anyway, ATM, here we come. My biggest bugbear with the CVSS scores is that they make it sound like it is a continuous score where 0 is the least amount of risk and 10 is the biggest amount of risk. But a while back, I did a bit of an analysis on a project that I was working on and sort of said, well, what are the actual scores? How are they distributed? And I found that down in the low end, there's relatively little. And it was very sort of heavily weighted towards the upper end of the score. And a lot of the time, you kind of end up having things where vulnerability scores get added into policies that says, if you have a vulnerability with a score of 8 or higher, then we'll break the pipeline and you can't build. That's how some of the tool works. Now, the interesting thing is I picked 8 for a reason, because obviously it covers quite a bit. But the interesting thing is that there's a massive graph at 7.5. This is actually to do with how the way the CVSS scoring system works. But basically, unless you get something like remote code execution, which means that you send something and it's very easy for them to execute something on your server, you won't get over 7.5. And there's a huge amount of vulnerabilities that range from being able to kill your server, from eating all its resources, from things that can effectively deny you the use of the infrastructure, that is just classed as 7.5. And if you've got one of those policies that say, yeah, everything on the rate is, we'll accept the risk for it, then are you really secure? What I did do, I looked at a lot of the actual security reports, and I found that the ones in blue, I could see how they could be exploited theoretically. The ones in red were like, well, just reading the report makes me think the context of this vulnerability means that it's never exploitable in the system that you're in. Now, this slide is a very well-known meme. If anybody's ever worked with Node.js, it will make absolute sense. Although, to be fair, it's also quite true if you work in the Java ecosystem. I've done some analysis where there was a simple service, pulled in a couple of dependencies, and before you know it, you had 300 jar files that have been brought in, because a dependency brings in another dependency, brings in another dependency, and all of those dependencies can contain vulnerabilities. So it's no surprise that sort of looking through them all can be quite a problem. The other issue that we've got is that we've got an issue of scale. When we look at systems, we usually have lots of different microservices talking to each other. Now, in the interest to protect the innocent, or clients, as I like to call them as well, this is intentionally sort of zoomed out so you can't really see what's going on. But this is the interaction between different microservices at the Premier tax collection agency. So you can see how many parts talk to each other. And if you sort of say, oh, well, we'll just have a policy of you fix any vulnerability within 48 hours, and we have 300 dependencies, and in these 300 dependencies, we've got tons and tons of vulnerabilities, that's gonna be a massive amount of work. And I don't think you can do that by simply saying, oh, we have a tool and we block our build, and it is hard work. But I took a book out of Agile. This brings us back to the subject of the talk. In this particular thing, I ended up actually having a look at all the vulnerabilities, because when I looked at vulnerabilities to say, are they exploitable or not, I found it was a bit of a mishmash. And it didn't matter about how low the score was. There are vulnerabilities that are classed at 5, which are called regular expression denial of service attacks. But if you've got one of them right, you can kill your service with one request. Nice. So I ended up going back to basics and saying, right, I'm not going to buy a big, massive tool. I'm going to use what I've got. I'm going to put it into spreadsheets. And yes, spreadsheets. It took me 25 years of being a software developer, then doing a bit of security, to realize how brilliant spreadsheets are, particularly pivot tables. It's amazing. You have a list of vulnerabilities in services. You have a pivot table and it tells you, oh, look, this one's got 300, this only got 2, this one's got this. And the amount of raw data that you can process by just stuffing them into a simple spreadsheet is amazing. And once I started sort of going, oh, well, a little basic tool can do something, then I built something else. I used a bit of bash, a bit of JQ to mash things together very quickly. And I had myself a vulnerability curation pipeline where I looked at each and every one of the things. But the key to it really was that you start small. You don't go out to tender for a big security tool. You sort of try to sort of see what information can you get to yourself. And then you iterate. And then at the end, you might well decide that actually I need that big tool in order to help me manage the vulnerabilities. So the next thing that I'd like to do, by the way, I forgot to add this at the beginning. If somebody has any questions, shout them out or leave them to the end. I don't mind. Either way works for me. Interrupt me, distract me. Yes. So my next bit is that the second sort of principle of the Agile Software Manifesto says working software over comprehensive documentation. So I thought, how can I bastardize this? And I thought, secure software over security checklists. Unfortunately, a lot of time, when we look at the way that security works, we end up in a scenario where we go, oh, this regulator tells us we have to tick all these boxes, so we best make sure that we've got some evidence to tick all these boxes. And you do, or you get a pen test report that tells you, yes, you have 2 medium and 1 minor risk. Who's had those before? Whose pen test looks like that? Anybody? Yes, most people. I had one of them, and then I actually had a look and say, ooh, what can I do? And found that I found endpoints that weren't properly protected, which meant that I could look up somebody else's data. And that was after the pen test company had completed their thing. Problem is that pen testing companies often have, you know, the budget is you have 10 services to test, you've got 10 days to do it, and you come in cold. You have got no idea what the technology stack is. You have got no idea what the users are doing. And you just sort of, a lot of the time it ends up people going, oh, I'll just press a few buttons and see what happens. Or more likely, I'll just run Metasploit on it and the automated scanner will tell me what it finds. Or yes, yet another HTTP header that you haven't set. The number of vulnerabilities that get raised by pen testing companies related to HTTP headers that some scanner somewhere says is frustrating, especially when it is an HTTP header that is vulnerability in a browser, but you've given them an API endpoint to test. Just saying. I'm not saying that pen testing companies are bad. There are some really good ones. But the idea that you can get a tick of we've completed a yearly pen test can give you any assurance that you've got secure software is a bit of a myth, I'm sorry to say. Now, at the keynote, David was talking about a snake that eats itself. That's my snake that eats itself. Well, two of them really. This is a picture that I've used to illustrate what I think is a really good way of working together, where security and development teams must not live in isolation. They must talk to each other, because you sometimes hear tropes like, oh, security is everyone's responsibility. What does that mean? It's nobody's responsibility. I don't want to have development teams where every single developer is a security expert, because then they just go and work as security experts. But somehow you also don't want the security team living in that ivory tower and only coming down at the end. So it needs constant collaboration. And I've listed some of them here. The application security team, if you've got one. If you don't, then you probably want to look at somebody that takes on the mantle. Are typically the ones that will understand the system and understand how to read those vulnerability reports, put the two together and say, this is what could be a vulnerability. This you can ignore. My favorite task when working as an application security lead was to listen to somebody say, is this a security problem? And me saying, no, you don't need to bother. It's fine. Nothing gave me more pleasure than to make life simple for developers and saying, no, you're overthinking it. It's fine. This comes under sort of the advice and being able to communicate it. Right, next bit. But I need to prove it to the regulator. Screams the head of security 3 days before the project concludes. Those security frameworks that regulated industry like fintech or government or anything to do with money, or the amount of regulations that we've got and that we have to comply in our industry is quite a lot. And it always will be quite a lot. And I think I'm pretty sure it was last year at this conference when Marcel said that there's about 200 new pieces of regulation that come out every year. So the landscape is changing. The kind of regulations that you do, you can't just go and say, oh, I've done this, tick, and I don't need to do anything anymore for the next 5 years. So in this particular instance, we've recently started, in my job, started sort of looking at the regulations and finding, oh, we haven't got this documented, we haven't got this documented, we haven't got this documented, and we need to do this, and we need to do the next thing, and we need to please the regulator. When our regulation specialist came in and said, actually, you know what? Regulators actually really like Agile and DevOps, and they want to make sure that the spirit of regulation is being met. A lot of the time you can negotiate with regulators. And if you show that you're looking at what is the most pressing thing, then you don't necessarily get hit with the fine and the enforcement action and the thing. Obviously, don't quote me on that. This is not legal advice. Although you can read those books, particularly Investments Unlimited, I really like. This is a story about a company that gets hit with the enforcement action and then how they use DevOps and Agile practices in order to dig them out of that hole. And boy, is the hole very deep. I guess what I'm trying to say is that auditors are your friends. And the benefit of having auditors as your friend is that there are two types of auditors. There are internal auditors, there are external auditors. And they both are interested in seeing you succeed. And they both are full of good ideas of what the kind of things is that we need to look at. One of my first things that I did when I started a new role recently was to become friends with the people that look after all the regulation, to find out what are the important things, where can we push. I'm currently working in a Middle Eastern market where cloud is something that you occasionally see in the sky, not necessarily in public. Well, I don't know where I'm going with this metaphor. But the point is that, again, please don't quote me on this, Kuwaiti regulation says you can't use cloud, but a lot of Kuwaiti regulators will tell you, please do use cloud, particularly the ones in Northern Europe, because we really like GDPR, and that's good for people rather than the stuff that we've got in country. So there are a lot of conversations to be had before you go and sort of interpret that regulation yourself and then go, oh, we need to think of the worst case scenario and we can't ever store anything in the cloud, for example. And these make real big differences on how you do security, how you design your systems. It's collaboration. Auditors are your friend, remember that. The next piece of advice that I want to give, the sort of third piece of Agile, is customer collaboration over contract negotiation. If you've ever worked in a place where everything was decided by, but this is not in the contract, you know how bad this is. And it's the same in security. It's about working together. It's about finding what is the biggest fire that you need to put out. You know, should we add the WAF, a web application firewall, or should we document our policy to make a tick box with the auditor? Should we implement identity and access management, or should we just write it down that we haven't got one? It is always, and again, I'm sorry for using a really cliched thing, as everything in IT, so in AppSec, it depends. You need to make a judgment call. You need to talk to people to find out what the really important things are. You need to collaborate, be agile about it. Just recently, I've had a chat with my head of security, and there was something where, because we're sort of starting up and there's not a lot of process in place, he said, I don't have time to work on creating policies. There are just too many fires. But think about it. Policies, actually, when you think about it, are not something bad when you approach it the right way. Instead of saying collaboration over policies, maybe you should say collaboration on policies. And the way that I like to think about it is to say, if you write down what does good look like, and that's not a reference to me, that's a reference to that really nice bridge, which is my new favorite image for the paved road. You know, the Netflix paved road, the golden path, the guardrails. I was sitting in, this was in DevOps Days Amsterdam, and I was sitting in the cafe, and you had this view, and I thought, this must be where some Netflix engineer thought of the paved road, because you have like multiple guardrails, and if you go over them, you end up in the drink. The point that I'm trying to make is that when you think about sort of writing stuff down, what does good look like? You're kind of saying, this is what I expect people to do. And if I write it down, then it's much easier to give somebody a printout and, well, not a printout, obviously, a link to Confluence so they'll never find it. Repeating jokes, excellent. But by writing it down and defining what you think good looks like, people can actually read it and go, oh, okay, we'll try and do that. Rather than having to go and fight the fires yourselves, actually sort of having a little think of what good looks like. And that doesn't mean we prioritize policies and documents over actually doing the thing, but it's something to sort of think about. Security is a team sport, as I've said before. It is something that the security team can't do on its own. Now, I used rugby as an analogy. I don't mean Scrum. Personally, I don't like it, but it has its place. The last bit in my journey through the Agile Manifesto from an AppSec point of view is this idea of responding to change. I can't remember what the fourth point is. But anyway, what I'm trying to say is that instead of striving for perfect security, you really want to have the ability to respond to change. At the end of it, as a security person, you're here to help enable the business to create value. You're not here to create a secure system. You're here to help to make it as good as possible. Sometimes you do feel like that you're sitting in that cafe where everything's on fire around you. But you've got to start somewhere. You've got to invest your energy wisely. So to sort of come to the end of my little presentation, I do think that application security loves the Agile Manifesto because it makes sense on so many levels. You know, you don't want to be fixed on saying security is all about buying the right tools. Tools are just that. They're tools. They help you to do a job. Fundamentally, any software engineering, I've bastardized the 80-20 rule here. Software engineering is 80% social and 20% technical. The amount of time that we spend talking about problems far outweighs the amount of time we sit in front of the keyboard, which is also why all this Gen AI will replace programmers is bollocks. I do really like the basic principles about using Agile, and you can extend that. And that's why I think it makes sense to do it for application security. So I'd like to end with a call to arms, people over process, and yeah, maybe, I mean, you just need good identity and access management. But no. I hope you've enjoyed this little journey through my sort of experience with application security, how I found that using Agile principles actually makes a lot of sense and makes a lot of things easier. If you've got any questions, please ask them now or find me at your leisure. Yes?
One thing I noticed is you talked quite a few times about a security team.
Yes.
As opposed to, say, a security person working in each team.
Right. So the question is, the questions just for so that everybody can hear, I mentioned a lot of time a security team rather than a security person in every team. And when you think about it, it is a question of scale. When you have, say you have 100 teams, do you really have the money to hire 100 security people, one for each team? It's kind of like the same thing as with DBAs. You need some sort of DBA knowledge, but is it really scalable to say that you have to have a DBA sat in every team? Now, so you can do two things, and I think they complement each other. You can have people that specialize a bit in security. Say, if you have a security champion program, so that there is one security champion in every team. Security champions, unfortunately, are quite a hard thing to get right because it usually starts out with everybody's enthusiastic, you have 3 meetings, and then you cancel 2, and then you cancel another one, and before you know it, you've spent 6 months without any sort of thing on a security champion. Security champions need actively people to sort of push out stuff. It's not something that sort of can sustain itself. If it works, it's a thing of beauty because you do want to, cliche alert, shift security left. You want that knowledge to be embedded. The reason I say security team, because I think there are some things that make sense to sort of deal with centrally. You want somebody to curate some of the vulnerabilities. If your organization has got a set of guardrails around your tech stack, then it becomes easier, I think, for a central team to work out what is the most secure way to do things. But yeah, I mean, if you're only a small organization and you've got 2 teams, then it may well be that you want to sit 2 security people in your 2 teams. Question is one of sort of, you know, can you hire for that role? Because I do think it does need a bit more than somebody who's just interested in security, because it becomes keeping up with all the vulnerabilities that come out, all the different tooling, all the different techniques, becomes quite a full-time job. Does that answer your question?
Yes. It's just that, there's something talking about getting security to be in that person, as opposed to something being outside.
Yeah.
Having a security.
Yeah. Yes. It would be. If money is no object, you stick a security person, a DBA person, a lawyer, a regulator, all this. At some point, you're going to have to compartmentalize in order to sort of...
and one more question.
Yes.
In one of your slides, I think you said auditors love Agile, they like Agile.
Yes.
What is it about Agile they like?
It's a realization that software isn't a static thing. It changes, and that it has to change. Now, one of the books that I mentioned goes into it a bit more. I think it's the Beyond Agile Auditing. But it is something that I've been hearing again and again. I think was it last year, this year, at what used to be called the Enterprise, or what's it called, the DevOps Enterprise Summit. One of the things was the auditors are coming. And there were lots of talks from people who sort of like, yes, we do really want to do those DevOps systems, because manually inspecting documentation and proving that things work or don't doesn't scale. And auditors don't want to be sort of sat there and say, right, service number 558, are you doing this? Are you doing the next thing? Which is why you want to have tooling around it that sort of proves to you, as part of your delivery pipeline, I can say, this happened, this happened, this happened. And that's why I think it becomes a lot more important to do that. And I think that's been recognized in the auditing community.
Thank you very much, Gerald.
So today I'm going to try and tell you a little bit about building software projects from my time over quite a number of years doing that. I'm currently working for Pleo, which is a very nice expensing software system. If anybody needs any expensing software, please talk to me afterwards. And before that, I worked at ThoughtWorks for quite a long time. So quite a lot of this material and experience, I do need to give some recognition to that experience. So let's get started. I guess what I'm trying to do here is summarize a lot of different things. So there's no kind of really depth of detail to it, but I'm trying to bring together all of the things that kind of like float around in my head about software delivery in general. And so I kind of like tried to bring that together in some form of structure. And this is what I've come up with as a kind of like model. And this is kind of like how I see the world of software when I'm thinking about it. On the right, left, your left, my left, are the three, what I take to be the three core parts of any kind of like software decision making or team. And I keep coming across this like time and time again whenever I sort of think about how the way teams work or how the way decisions are made. These three elements kind of like all come together, which is around like the delivery of the software, the tech part obviously, and also product. We can't forget product. And I've put customer in the middle just so we don't forget about them. They're always quite important. I should mention that I'm an engineer, so this is a little bit biased towards engineering. But I guess part of the point is to think about all of the disciplines that are involved together holistically and kind of like work out how we, in whatever discipline or silo we might be in, relate to those other ones. So that's what I'm kind of trying to do. There are kind of like four core categories that we're going to go through. We're going to talk about people a little bit. They're super important. We don't really get very far without people. We're going to talk a bit about some of the practices. I'm going to pull out a few that I particularly think are relevant. There's obviously many of them. We're going to hear a lot about them in some of the other talks today and tomorrow. So you'll get plenty of other opportunities for that kind of thing. And I'm going to talk a little bit about products and platforms. Less so about these two, but they're kind of like related. And like platforms is a really big word. Like has anybody not heard the word platform used in context of any kind of like software organization or delivery? So I'm just going to talk a little bit about platforms and maybe a little bit about the relationship between platforms and products. Okay. People. Oh, sorry. Yeah. Before we talk about people, what do I mean by like product and delivery and engineering? And this is just kind of like a high level how I kind of like see these things working together. So product is very much about like why are we building the thing? So I'm talking about software products here, right? Like and maybe almost all products these days are kind of edging towards being software products, right? So certainly software products are quite important. So understanding the product, like why are we building it, who are we building it for, and what's the value proposition, and kind of like how we design it is obviously the kind of like one of the core ingredients that we need. Delivery sounds pretty familiar to everybody. Like, does everybody kind of like think about that? Like, we might talk about delivery managers or iteration managers or whatever. So delivery is about, I think, about the mechanics of how we make things roll along, like who's involved, how much does it cost, tracking all of that kind of stuff, navigating our way through. And then engineering, obviously, we need engineering. That's the core of actually making the thing. I tend to include all sort of disciplines in engineering, so like kind of like customer experience design and user design and front end and back end. It's all kind of infrastructure. It's all kind of like part of the same thing to me. So this triptych or three things of the three things that go together, I think there's an interesting thing about here, which is that no matter what scale of organization you are, even if you're sort of like one or two people making something or like a massive organization, then you kind of need these three elements whenever you're sort of deciding what to do or trying to like build a thing. And if you don't have them in balance, then you can get like shifted a little bit in the wrong direction with your product. And this is, I saw this the other day and I thought it was a really interesting article from Gregor Hopi. And he's done this thing where he's like, if you look at your organization and look at the relationship between the CIO, so that's basically like IT, and the rest of the board, like who they report to, you can kind of like reverse engineer the sort of emphasis that organization puts on IT. And so it's kind of interesting. If you're sort of reporting to the CFO, then it's likely that your organization is going to see IT as a kind of cost center. Whereas if it's the CEO, and that's quite an interesting one, right? Like the CEO directly has the CIO reporting to them. So they're having a much more kind of intimate connection with what's going on in the IT world and seeing it more as kind of an enabler. So this is a really great article he's got up on LinkedIn. But I guess what I'm trying to say there is that you can see how this sort of relationship between these three things goes from right at the small scale within a small team or with one person even just working on their own through to the shape of an entire organization. Okay, so we're going to go quickly now. Roughly, we've got a bit of time, so we'll try and go through the 4 kinds of categories. So people. I wanted to start with people because it's a kind of like classic thing. Like pretty much everybody, I would say, these days recognizes that most of the hard problems are not so much about engineering. We kind of have solutions to a lot of engineering problems, right? But who here thinks that people is an easy problem to solve in their organization and getting people to work together and organize them, right? So I think there's been a talk this morning, like a workshop this morning about psychological safety, which is a really good thing. So I hope people got to see that. So I'm not going to talk in too much detail about that because I'm not an expert, but I do think it's important to think about a few things about people. I keep that in mind whenever we're like leading teams or trying to get teams to do things or building software. Oh, yeah, what's this? I forgot about this, of course. AI, right? Like, what about AI? I'm not going to say a lot about AI, but I'm going to, like, one thing I think that I've sort of noticed, the one observation I've had is that, AI is already in our teams, right? Like, we've got, who's using ChatGPT or like, whatever it's called, the Git thing that helps you with programming. Yeah, Git Autopilot, right? So we're already starting to interact with these kind of things on a daily basis. And I guess my observation was that humans, we're quite good at anthropomorphizing things, right? We'll talk to like trees and stones and all kinds of things, right? So to me, anything that even starts vaguely resembling a human starts already feeling quite human. I find myself like saying thanks to like autopilot or whatever, and kind of like, hey, would you mind doing this for me? And kind of starting already to treat it like a kind of human. So I guess maybe my observation is that perhaps we'll start seeing like AIs as being kind of more and more part of our teams, and kind of like maybe they're not the most senior like engineers or whatever in our teams, but they might start more and more participating. So I'm going to leave it there. AI is a big topic, but I think it's coming. Okay, people. Who has ever been like scared at work? And I mean like scared like actually quite fearful because of some consequence of something or something that somebody said or whatever, or felt uncomfortable. Yes, me too. I've had it. Yeah, that's almost everybody, right? Like I love this quote. This is one I'm on a mission to try and get quotes from the film Dune into talks, and this is the first one. So, I think this is what I always think of when I think about fear. So, it really does like freeze us, right? A bit of fear is healthy. I'm a little bit nervous for doing the talk, so that's a good sort of like energy for talking. But in a work situation, it's a killer, right? It stifles our creativity, and we kind of like freeze. And it's certainly, if it starts getting to be at the team level, then it can be a really bad situation. And the kinds of things that can do that are sort of like overwork and too much pressure and all this kind of stuff, or generally like bad psychological safety in the team. So I think the reason I put this there is because I think a lot of the kind of practices that we think of as being like kind of modern practices, to me, they're about reducing levels of anxiety and fear and like kind of like automation and testing and all of that stuff. To me, it's about seeing if we can be as happy as we can be doing our job and making our products. And therefore, we're going to be the most creative and most productive. I'm not going to talk about this too much, but I think like what I'm trying to do here is pull out a few kind of like key sort of references and whatever. So I don't know, like probably a lot of these will be familiar to people, but just in case they're here, and this is a good place to look. And I think when we're talking about our kind of like hierarchy of needs and this idea of, well, we need to feel like we're not about to die at any point. That's a starting point. And then we've got a kind of like general psychological safety. And then it gets a bit more involved. Like if we're working on our own, it can be sometimes quite rewarding. But actually when we're working as a team, that can really kind of like amplify those feelings. So I don't know if everybody's like, I find like if I'm in a team and we've had a big success at building something and it's delighted the customer and the other day our product owner was sort of dancing a jig or whatever. So it's kind of like that kind of like thing. It's quite a rewarding activity. So the more you work as a team to get that, the happier you are and the more productive you are. And then is everybody familiar with this thing? This is more of an individual thing on the left, like the autonomy, mastery, and purpose comes from this Daniel Pink's thing. That's referenced quite a lot. And so that's about like, as an individual, what do we need? And I think this is important in terms of thinking about the individuals within the team and what they need to thrive and grow in their careers and be happy. If your team members are not happy, then you're not going to get good work, basically. So individuals, they have their own things, and then individuals work together in teams, and then we have sometimes more than one team, and as we get bigger and bigger and bigger, we have like lots of teams, and how do we kind of organize them around work? And I think one of the things here is about the scale of teams. Kind of like teams are like a unit, right? So you can have like a small team, you can have a big team, but there are sort of limits. Like you don't really want to have a team with 30 people in it. That's probably too big. And a team with like 2 people in it, is that really a team? Maybe it's sort of edging on the edge of not being a team and a bit hard to get those kinds of feelings that we saw before about being in a team and the satisfaction of belonging in a team. So I would tend to think that it's a good idea to have a kind of unit size which you're comfortable with, like maybe like a small team and a large team, and work out what that is for you, and then kind of fit it to the work. So a small team might have 1 or 2 things that they want to focus on. And here we're trying to talk about kind of like ownership of things, whatever it is, like scale of work. So sometimes you might find like you can make that work quite well. So one team owns either a bunch of small things, and that's kind of, so rather than having like each of those people own one of those things, like try and form them together in a team. Or you might find you've got like a massive thing, which is quite hard, probably should be broken down anyway. But the trick is not to make a team of like, whatever that is, like 20 people, just one big team, to like break down the team. And I've seen this like in practice in a lot of things. It seems to be like fairly common knowledge these days about how to build teams. And often we talk about kind of like bounded context, and this is a bit Conway's law type thing. But essentially it's kind of, this is the sort of principle of like, don't try and fragment people too much and try and like match them to the work. And don't break the rule of like breaking the team as a unit itself. And then what happens? Then, like, so this isn't relevant to like all organizations. So what we said before is kind of relevant to like pretty much any organization. Most people, unless you're like a one-person shop, you're going to have some kind of like teams, and you maybe like 1 or 2 teams of small teams. But there are places where you have kind of like 20, 30, 40 teams. I've been in those things. And then things get pretty complicated. But as it happens, there's kind of like a reasonably well-known now sort of solution space to this. So like, I don't know how many people have heard of team topologies. Exactly. It's already kind of like pretty well known, right? So I'm not going to like explain what team topologies is, but essentially it's about finding like the good boundaries between those teams and effective ways of like interactions with them, which is a little bit like platforms, which I'll talk about at the end. So it's kind of about encapsulating and understanding the relationships and making it flow easily. Okay, so we're going to do a quick survey of some practices, which I think are particularly relevant. It's a little bit biased. There's the things that I really like, so there's not every practice in the world here, but some interesting ones. So we're going to start with product. I'm not a product person, and there's a lot of talks here actually about products, so that's great. There's going to be some awesome detailed product practices. But I've worked with quite a lot of product people in my role as a sort of like lead engineer, and the product to me, like in the three things, that's always the person who's really excited to say, but what about the customer, and where's the value in what we're doing here? Why do you want to go away and build that crazy tech thing that doesn't have any value? And something I keep coming back to is like, so this is a little bit about, okay, we've got this idea of what we want to build, or maybe we're looking at a quite complex organization with a lot of people and a lot of systems, and we're trying to work out what the hell is going on and how to organize the teams around it. And for me, it always comes back to, if you can think about who are the people, what is it that they're doing in the organization, and what do they need from the systems to help them do that thing. So that's kind of like the people and the activities they're doing. And these people don't necessarily have to be your customers. Some of them are your customers, but some of them are also your like operations people or your support people or your engineers even, right? So when we're thinking about how we design systems and group teams around those systems, that's kind of like the basis of what we're sort of looking at. This is a little bit like a kind of like service design blueprint kind of thing, but you don't necessarily need to be that formal about it. I've done this kind of exercise in a sort of less formal way, but just thinking about these kinds of levels. And this always sort of like helps me come unstuck from like the chaos of hearing loads of different perspectives and loads of different views. And somewhere in the middle, you know, there's this user journeys are a little bit more specific, right? So user journeys are quite specifically, if I'm interacting with a particular system and I'm going from screen to screen, what am I doing? So sometimes that's helpful, but sometimes you have to like jump across systems and so forth. So it's sort of a bit optional. What else am I going to say about product? Okay, so this is this other part of it. So I put this under product. It could go somewhere else, but I think it's kind of related to the way we design things. And what we're really talking about here is domain-driven design. Everybody knows domain-driven design now, right? Yeah, everybody uses domain-driven design in their thinking all the time. And I've just, again, let's not talk about domain-driven design. I'm just kind of like pointing it out. So to me, these two things at the bottom, the three things that are on there are the most important things. So first, it's about bounded context. This is about trying to like encapsulate things into smaller domains so that you can make sense of them, fit them in your head, as one of my colleagues would say. The two, well, maybe even the most important thing is this ubiquitous language. And so the ubiquitous language is about the way we talk about the systems and the domain, and trying to match that as closely to the domain of whatever the customer is working in. So that, remember, that customer could be like a tech person or your real customers or whatever. And getting, I mean, okay, so we all know like naming is the hardest problem in computer science, right? So it's always difficult and it always causes confusion, right? Who has not been confused by some kind of naming somewhere in their organization when somebody referred to one thing as A and another, the same thing as B in a different part. So ubiquitous language, and this kind of concept of bounded context is fundamental to a lot of thinking. And some of the examples, for example, there's data mesh. Everybody heard of data mesh now? Yeah, it's starting to get more well, yeah, these two, obviously. And so data mesh is kind of, in some ways, an application of domain-driven design to data, and thinking about this idea of data products, also relating a little bit to this idea of products, which we'll talk about again in a minute. And so we can kind of think of this bounded context as being an encapsulated capability, maybe, it's a little bit of a loose word, for in our sort of systems thing. And there's basically things that owns a bunch of stuff. Like maybe let's say orders or something in an e-commerce environment. And what we're looking for really is a kind of like clean way to interact with that thing. And so generally what you can do is you can perform actions on the thing. So you can ask it, create me an order. And these days, generally what we think about other ways of communicating to other systems is either we're like firing out events, so we're doing some kind of event-driven thing, or maybe we're accessing the data that comes out of it, and in the data mesh terms, we'd be thinking of those as data products. And I've put this thing at the bottom. I think this is a really interesting recent work by Malcolm Sparks at Juxt. You can look it up. And he's kind of trying to bring all of these ideas together and put them into a kind of platform, actually, interestingly, with a kind of set of well-defined principles and kind of like rules, which are then encoded into the platform. And it's all about this idea of trying to keep this as formulated and structured as possible across a larger estate. Again, this is maybe not quite as relevant if you're just a team of like 5 people with like one kind of like monolithic application. But when you get into the scale of having multiple systems interacting together, it becomes more important. So I think these, like I said, I kind of put them under product because it's about this borderline between how do we shape the product. And if we get these things kind of like wrong, quite often it makes it difficult for us to do the product things that we want to achieve because things are too coupled or entangled. Delivery. I'm only going to say that one small thing about delivery, really, which is that I tend to think of it as navigating, like trying to find your way from A to B, wherever the product people want you to go, wherever the product wants to be, wherever it wants to go. And then sometimes, there's obstacles in the way. Do we want to go over the mountain, around the mountain? And deciding how to go and where to go, that's when the cycle comes back in, right? Like if we have any one of those three things sort of overwhelming the decision-making process, we tend to take strange routes. Maybe we're a little bit too excited about product features and we're not really taking account of some of the more engineering things like, is it secure? Will it fall over? Should it really be synchronous or asynchronous? Which can actually, like, in the end, destroy even your customer experience because you didn't really take them into account and you were just listening to the product. The same route, you might build something that costs you way more than it's ever going to be worth, and I'd sort of expect the delivery mindset to kind of like catch that out and work it out. Yeah, dependencies, again, is a little bit like what we talked about before. It's quite difficult to manage multiple teams all over the thing, and so having this kind of like clear idea of where you're going helps with that. And then the other big thing that helps is, this is a very kind of like classic Agile thing. Lots of people say it all the time, and I hope everybody takes it to heart. But trying to break things into as smaller steps as you can. So small iterations, MVPs, whatever, however you want to call it, but just trying to work out either very obvious stepping stones towards a live in the hands of customers experience or an actual release into the hands of customers is the idea. Engineering. Like I could talk for several days about engineering practices, which I'm not going to do. What I was really wanting to say here is that for me, like, I'm quite old. I've been around for a while, and I remember when I first sort of really got into coding and Agile and whatever, it was all about XP. And actually, out of all of the things that I've ever learned, like XP, I just keep coming back to. Like the practices that are in there are still as relevant today as they ever have been, as far as I'm concerned. And what I really love about it is, so firstly, it's focused on the making of the code, right? Like that's where they came from. They were sitting down, they were making code together, and they were thinking, okay, this is sort of working. What happens if we do this all the time? Does that make us work even better? And they kind of found that it did. So you don't necessarily have to like adopt the full extreme attitude, but thinking about these practices and trying to think like, have I tried this? Is it working for me? Can it work? Could I be better? I think is a great way to start. Some of these other things, oh look, infrastructure as code. Actually, hello Keith. Keith's actually going to do a little talk after this sometime at 2 o'clock this afternoon, so that's quite nice to have him in the audience. Is everybody familiar with all of these things? Maybe not the sensible defaults. I'll talk a bit about that. Integration patterns. So kind of integration patterns in Kubernetes. I just picked a random Kubernetes book. I've not necessarily read that one, but pretty much these days, big scale systems seem to be converging around like, I didn't put microservices up there, like event-driven kind of systems using Kubernetes as a sort of deployment thing. So there are some sort of trends evolving that are kind of, that's what people do pretty much when they do big systems these days. Sensible defaults is an interesting thing. I think you can go and look at that up on the ThoughtWorks website. I did look it up earlier. ThoughtWorks in the house there on the left. And this is something that we had in ThoughtWorks for like many, many years. And the idea is like a bunch of practices in all kinds of different areas, a bit like this talk in some ways across different delivery, engineering, and product, that are not necessarily like mandatory, like you must do it like this, but like you're not likely to go too wrong if you use these things. So that's well worth a look in terms of some more detailed advice. Yeah, maybe being an engineer, I should talk a little bit about architecture and so forth. And Gregor, his books, read anything by Gregor. I've got a list of people in a minute as well. But yeah, basically that's one of the best books I've read about architecture. And interestingly, he's also talking about his metaphor in there is kind of about scale. So if like engineering's on the ground floor of the building and the boardroom is at the top floor, and you have to navigate and go down through all the different floors. And if you don't spend time at the different floors, then you lose too much context of what's going on, and you're not able to make these kind of decisions at the big level because you're kind of getting out of that loop of both the scale and the three sort of disciplines. Yeah, good. So I'm going to pick on two. I'm going to go back to the classics here. Like I'm not sure we've had a talk on TDD here for quite a few years. We did have some like a few years ago, but I thought it's worth a reminder. So I'm quite interested here. Like how I don't know. Hey, first of all, how many people are actual engineers in the audience, as opposed to okay, quite that's good. Yeah, okay. How many people use TDD? Yeah, some sort of yeah. How many people use TDD on a daily basis in their work? Few, good. Just give some fans, awesome. Yeah, cool. We'll do some more surveys in a minute of like things. So, like, everybody understands this thing, right? So it's very simple TDD. Just write the test first. That's basically the mantra. And I suppose the reason I mention it is because I've done quite a lot of TDD. I'm a big fan of it. And it is a really good way to kind of like structure, a bit like this navigation again, but in the smaller scale when we're navigating from one piece of code to the next and trying to make sense. And it really kind of like helps us move together down those things. And this, I noticed I put tidy. That used to be sort of more like kind of like refactor, red-green refactor. And Kent Beck, who I forgot to mention, Kent Beck is probably one of my biggest heroes in software. I think read everything and anything by Kent Beck. You can't really go wrong. He was kind of like at the heart of XP and pair programming and TDD, and he wrote the test-driven development book. And he's recently done this tidy first book. So he's always like refining his ideas, and he's kind of more in this idea now of like, what if we? And he's always kind of like talked about this a little bit before, but before we even start trying to write our tests, what if we try to make our code easier to change before we then make the change? And this is like a common thing he's always thought. And you can apply this at different scales. So if we want to add a new feature or a whole new product line, and we think about that's going to be really difficult because all of these problems in our way, how can we change our organization or change our code or change our systems to make that change easier and kind of work back from there and try and go back in steps? And so I highly recommend a bit of Kent. So the other one I want to talk about, pair programming. Okay, so now how many people who are engineers do pair programming on a regular basis? Oh, that's great. Awesome, yeah. I don't know if everybody's ever read this book. This is a great book on pair programming. It's quite funny. It's also a bit about people as well. So how different people interact when they're trying to work together. What happens if you get an extrovert and an introvert or two introverts? And it's a great book. So I've put pair programming a kind of bit into context here because I think there's a little bit of a sort of spectrum, right? Like, so who uses like pull requests seems to be a fairly common pattern. Anybody using like trunk-based development as a regular thing? So pair programming, I think you were like, were you doing TDD as well? Awesome, yeah, you're in my gang. So I kind of jokingly thinking like, well, pull request is a bit like pair programming, but just like the hard way, right? So I write something and then I send it to somebody and then you get a bit of feedback and you go back and forth and maybe they're there, maybe they're not. And it can work if you're sort of disciplined about it. But it's a little bit like doing pair programming, but like the hard way. And also even like just interacting on Slack. The other day I was trying to do something on my own and I was basically like constantly chattering on Slack to somebody who knew more about the code than me. And I was like, well, you know, maybe we could just be sitting together and having this conversation, right? So I think there are certain times when it's just natural that people feel like they want to pair. And so I don't necessarily say that people like have to pair, but I do think it's worthwhile thinking about can you amplify it maybe more or do it more often? Because I think pretty much, I mean, I'd be surprised if does anybody really like work completely on their own when they're coding? Like has no communication with any other developers? Pretty unlikely, right? So we're kind of already doing pair programming, we're just doing it a bit further away than we do. And then you can go to the extreme of mob programming. And I was talking with Al earlier. Everybody wants to know about mob programming. he's been experimenting with it in his organization. They've been having some fun doing that. So yeah, so we can go to an extreme of mod programming. We've had talks on mod programming before. Again, I'm not really going to go into that. It's kind of just an extension of that idea, really. And then bringing it together, TDD and pair programming is just like the best combination. If you do them both at the same time, because pairing is kind of like sometimes quite difficult to know who's doing what and where you're doing, and the tests and writing the idea, the whole point of doing TDD as a kind of design activity, it sort of slows you down, makes you do like step by step, allows plenty of space for you to like have conversations about what's going on, and it's a really nice structured way. You can even do like there's the classic idea of like ping pong, where one person writes the test and then the other person implements it. So they kind of really, I think they're really synergistic and at the heart. I mean, really, in the end, no matter what else you have all around, all the delivery practices, all the product practices, all of that stuff is at a bigger scale. In the end, what we're doing is making code as developers and engineers in a small team, hopefully with our product people closely connected to us. And just to wrap this section up, these are a few people. A lot of them wrote, oh, there's Keith. Hello, Keith. A lot of them wrote some of the books that you saw before. Nicole and Jez did like Accelerate, and has everybody's read Accelerate, right? Like, that's like a really awesome book about how you go and about managing developer efficiency, dangerous word, at scale. Gregor we've talked about, Kent we've talked about, and John, actually I didn't really mention much about John Cutler, but he's a great person on the product side. I don't know if anybody's watching him. I was like seeing really interesting insights from him. I don't really know how he manages to come up with all these insights. It's quite impressive. Okay, so we're kind of heading towards the end now, which is good. So we've just got 2 more sections. So I'm not going to dive too deeply into these. They're not totally my my kind of speciality, but I think they do kind of like work a little bit together. So products. This is my simplified product view. This is how I think of like product. Basically, this is where it's really important, the customer, right? Like that's the main thing. We're making a product for a customer. If we're making a product and we haven't got a customer, like what do we do? You know, what is that? Is that even a thing, right? Like, and if we've got a customer and we haven't got a product, then we're like either missing an opportunity or that customer's like, yeah, it's like a niche, right? It's a niche that could be exploited. So that's sort of at the core of everything. And then I think, you know, like as like lots of other talks about product, but the essential element of it is to sort of try and iterate and experiment and work out what the right things for that customer are, listen to the customers, not always listen to them, but provide them new things. And that's kind of a core part of the practice of product. And then there's this kind of like sort of value exchange, kind of like transactional thing going on. So, right, we're creating a product which has value to the customer, and the customer gives us something back in return, right? Like, so they might like, well, hopefully they like pay us or buy a subscription or whatever, and they're happy, and the reason they're paying is because we're taking something that was maybe like hassly for them to do and doing it for them, or making something easier, giving them something back, or giving them some value, right? And when we're thinking about a lot of product, and whenever we're talking about a high level kind of like roadmaps with product people and whatever, we're often talking about things like what are our goals and what are our objectives and what are our kind of like initiatives that we're going to do, maybe our OKRs if we're into that. And a lot of that comes down to, well, how do we know whether we have done this? How do we know whether we've made somebody happy, or how do we know whether this product's really working? Did we make any money? You know, it's all about measuring. And this, like, Accelerate also has quite a lot of stuff about measuring, and I believe it's kind of inspired. That's how I found this book as well, How to Measure Anything. This is a really great book about things that you might think are hard to measure, like quality or productivity, and ways that you can, like, sort of strategies for doing it. And it's kind of like, principle is that there's nothing that you can't measure if you think about it right. And then the final thing about products that I'm going to talk about here anyway as well is that, like, who's the customer? So traditionally, the customer is the person outside the organization who pays you money for your product and you make the product for them. But as we move into thinking about kind of like platforms and internal products, and maybe even those like domain-bounded contexts that we talked about, The customer can be anyone, really. And so it could be another team, it could be your customer service people, it could be developers in another team, it could be your product owners. It could be other organizations who are integrating with you and need to talk to your APIs, so third-party developers. So this concept of a product and a customer is quite generalizable and can extend to almost anything. And that's kind of why I talked about software products as a thing. So we're building some software thing, and it's got a customer, it has some value. And the payback may not be like direct revenue. Like if we're inside an organization, it might be kind of like budget allocation or just generally like measured on how useful people feel that whatever your product is that you're developing. And it's kind of, I think this is a growing mindset shift that a lot of organizations are thinking about now. And I sort of think about it, people talk about like the product mindset, platform as a product, products as platform, it's products sometimes can be platforms to other people. So these things start getting really kind of like mixed up. So I think that's quite an important point. And then finally, we get to platforms. Platforms, like what is it? What is a platform anyway? Like that word gets used a lot, right? And I've got a kind of like basic definition that I sort of keep in my head of it. And really some elements about platforms are that they kind of should encapsulate something that is quite tricky usually sometimes, and maybe like you don't really want to know what's going on in there. You just want the outcome of it, whatever it is. AWS, great example. I don't really want to know how the hard disks and all of that work. I just want maybe even a Lambda I just want something to execute for me on somewhere. And again, there's this kind of like, so this is where it kind of like gets similar, right? It's all a bit like a product because basically what you're doing is trying to provide some value to some customers through the thing that you're doing. And this is a classic thing. And has anybody ever been involved in a platform project in their organization which didn't really, it was more like build it, they will come kind of platform. And they sort of built a very nice platform with loads of great features, but not that many people really used it. And so now we're really talking about thinking about our platforms as if they were products and applying all the same kind of like techniques to them, measuring their impact, just interviewing customers. And in Pleo, where I work now, there's a great example of this. Like the platform team actually are doing a survey, and they came and talked to me and asked me a bunch of questions. Like awesome, like customer research about the platform. What's good for it? What's it doing for you? What's it not doing for you? Where can we improve? And then really like, because like I say, a platform is not much use unless people are using it. It's not really providing value. So this idea of trying to get people to adopt the platform, and that's very much like you're trying to get people to adopt your product if you're trying to release a product into any kind of ecosystem. So thinking about the internal ecosystem of your company as the marketplace, and you're trying to promote your product, which you've got a great idea for, because you think it's going to solve some problem for somebody and give them some value. And the final thing I wanted to say about platforms at this point is there's some economics going on here, right? So if you're a smaller organization, chances are you're not probably going to have like a 10-person platform engineering team, right? Building all these like exciting things. So you're probably more likely to be shifting towards platforms that exist outside your organization already made, kind of like, so like some like managed service offerings from AWS, for example, or like much like higher level abstractions there, which you want to see. So there's this kind of like idea of like, how much is it really worth it? And even in large organizations, people can get a little bit carried away with, we really need to have like we must have like a platform engineering team, and just like be kind of aware of what the true economics are. Which again is kind of like product mindset, right? Like what's the real value we're delivering versus the cost of building this thing. Oh, I missed one really important thing about platforms. Well, the most key thing is that what you don't want to happen is that every time somebody outside your platform wants something from the platform, they have to like raise a ticket with the people inside the platform to get that to happen. That's not really a platform. That's just a bottleneck team that's going on. So what you need is, you need this boundary to be quite solid and have the interface very clearly defined. And the ultimate interface is like completely self-service. Like I don't have to raise a ticket to somebody in AWS when I want to provision an EC2 instance, right? Like it's all automated everything's infrastructure as code, and it kind of like all works beautifully. So this concept of thinking about the thing I'm making and trying to make it as encapsulated as possible and have this very clear interface and as self-service and is one of the most critical points about it is it allows you to scale. Like you can have a small number of people operating the platform and a large number of consumers. And then again, that's back to kind of like economics, because if you spent a lot of money on building something and you've only got one person using it, it's probably not a good trade-off. Okay. I think we're there. So we kind of like covered a lot of different things. I tried to bring them all together. And I guess really like the main idea was just to sort of put all those things in your head at the same time and see what happens. And kind of that's what's sloshing about in my head quite a lot of the time when I think about these things. And I would say like as people get, as you kind of like get more maybe like senior in whatever role you're in, understanding these different areas starts becoming kind of like more significant. I think I'll stop there. That's it. Thanks. Have we got, a few minutes for questions, and that's right, isn't it? Yeah. Ideal.
We can definitely take a few questions. Anyone got any questions?
So all your insights to great talk. I've got a question about not programming. We're experimenting with this. We're on Friday. We'll do something a bit different. Students focus on solving the problem, structuring an itch. That's been saying. But what tips do you have for organising that session so it wouldn't be something to chaos or outcomes?
Yeah, I mean, I think this is where it comes back. Like the TDD and kind of idea starts working then. So, and also this concept of like navigation. Like, if you're not kind of like as a group understanding what where are we trying to get to here, then it's going to get very confusing, right? So one kind of like practical tip is, I think maybe you were doing that, but like is taking turns being the person who's actually sort of operating the code and sort of rotating that around. And that kind of like forces everybody to take the steering wheel, as it were. But then there's also the kind of like, and this is very similar to pair programming as well, right? Like, so what I always like to do with in a pairing session is before you actually start typing on the keyboard, work out a kind of like rough plan. Sometimes you might do it on sticky notes or in Miro or whatever. But like, what are the steps? Like Kent Becking, and like, what are the steps we're planning to do? And then we kind of all know where we are in the journey as we're going. So I think that's probably like at the core of what you're asking now. Like, yeah, how do you keep everybody? And interestingly, that's a little bit like, how do you keep everybody, if there are like 2 or 3 or 4 teams all trying to work on the same, like going on the same journey, and they all have dependencies and need anything. If everybody doesn't have a very clear idea about what the steps in those journeys are, and as a sort of senior engineer, I tend to spend quite a lot of my time doing that, in fact, like understanding what the actual journey is and explaining it to everybody and making sure everybody's kind of like on the same path. Maybe having a person, maybe that could be a person who's like the navigator, but for the group, like, so who has that idea of where they're going to sort of help make it go there. Nice. Thanks, Al. Yeah, anyone? Yes? Hi.
Okay, so I work in product software development, and in my company we do follow the MVP mindset of ideate, create a how very fast in order to release faster, and then learn from that. But then after that, you will definitely have some releases, learnings, and you will adapt it. But then the main challenge that I sometimes face is that we want to create a code that is simple, fast, as I said, but also scalable enough and easier to change once you learn. But then sometimes you don't know how to, and you also don't want to kind of recreate a code from scratch. So what tips do you have in order to navigate those concepts?
That's good. Yeah, that's a kind of like classic trade-off, isn't it? Like, you don't want to like sort of over-engineer. I always come back like, so this is one of the first things I kind of remember really conceptualizing when I started, when we were doing XP, like back in the day. It's kind of like like the rule of 3, like you sort of, you do something the first time and you sort of get it roughly right. And then you do it the second time, you start seeing the like patterns between it. And then by the third time, you're kind of really able to see where the abstractions actually are. And that's when you want to like start trying to like really pull out those abstractions. So I think there's a part of it is about a constant process of looking for those things, and it's a delicate balance between going too far too quickly, because if you make the wrong abstraction, that can also get you in trouble. I remember Eric Evans once on a podcast saying about domain-driven design that you're very unlikely to get your domain design right like the first time. And so this is a bit abstract, but like basically the idea he was putting forward is to optimize for being able to like do more designs rather than take the first design you do and then try and really like solidify and crystallize around it. So I'm not quite sure how that exactly plays out in your scenario, but some of the tools that help you are actually kind of like the TDD, but TDD done in a thoughtful way. It's like you can also like make tests which clarify. Kind of like constrict you, right? Like you can get the situation where you have like too many tests, and when you try and change something, everything breaks. So it's kind of, and actually like Kent Beck is a really good person to read about some of it in his Tidy. That's kind of what Tidy First is about what he's been trying to do is understand what are the essences of design, software design, that kind of like lead to those properties to make it easier to change as you go. So yeah, it's like rule of three, sort of looking out for those like right abstractions. The ancient classics of coupling and cohesion, right? Like that's a big thing. And sort of, literally recently had an experience where we were trying to just like upgrade some stuff in a large kind of like monolith, and it's really hard because everything depends on loads of different things. And so having things broken into smaller parts can help. That's a great. I mean, that's a tough challenge, the eternal challenge. Yeah, happy to talk some more after.
Yeah, thank you very much, Jim.
All right, thanks.
Right, so I'm going to talk today about how I think we can move beyond spaghetti infrastructure code bases and some of the kind of forces I think are at play that lead to the situation, and I'll describe as well the situation and some ideas I have about moving beyond that, basically. So just to give you an idea of my journey, where I'm coming from with all of this. So I kind of was messing around with infrastructure automation and things before it became, like, before the term infrastructure as code emerged. So I was playing around with tools like CF Engine and FAI install and so on. If anybody here know about those tools, just out of curiosity? Some little hand wavies and nods. So I could like automatically provision machines in the data center, like physical servers, and install OS and configure it and all those kind of things, and then Puppet and Chef and so on. And then around 2009 was like this inflection point. So AWS had released the early stuff was out, and it was usable, and we were starting to use it. Some of the companies the company I was working with at the time, infrastructure as code, DevOps, continuous delivery, all of these concepts emerged, even where things, maybe the ideas had been around before, but like they kind of had names and started getting traction in the industry. And so I joined ThoughtWorks in 2010, basically because this was kind of a good opportunity for me to work with different clients, different companies, taking the stuff that I'd been messing around with before and trying to help them to adopt it, because that was becoming a thing. I wrote the book Infrastructure as Code, and the first edition was published in 2016, and the second edition was in 2020. Third edition I'm working on right now, slogging through that. Should be out early next year, I think. And that was really about taking things beyond, obviously, the clients that I was working with directly, and trying to kind of share ideas and thoughts about how I believe this stuff works and can work, more widely in the industry again. And so in the past few years at ThoughtWorks, I've got a role as a kind of a community practice lead globally. And this has given me the opportunity to work with clients and teams, lots of different clients and teams basically, and kind of get ideas and so on. And my kind of current thing, I guess, is I'm exploring and sharing what's next. So it's like I'm kind of like seeing things that I'm seeing that I find frustrating and people find frustrating, and thinking about what can we do better, right? And so that's kind of the idea of this talk. And so I'll try to, hopefully I'll have time to take questions at the end, but we'll see. This is kind of, this is this is actually a fairly kind of new talk for me in terms of like I'm putting it together in a way to kind of share it and hopefully get feedback from folks. So also I'm happy to kind of hear people's thoughts afterwards. So my kind of basic premise is that infrastructure code bases that we tend to have, most teams that I work with or meet, people that I talk to, and even ones that I'm on, our infrastructure code bases are just too messy, right? It's partly that we're writing all infrastructure code very custom for everything that we do, rather than necessarily being able to kind of reuse and share stuff as much as we might like. But also like even the tools that we use to run and manage our infrastructure, like everybody has like these very custom scripts, make files or whatever, and so it's just like everything is we're kind of doing everything from scratch, and so it feels like we're not really at that kind of point of maturity that even like with software development, where we are. So this is where I feel like we really have a ways to go with this. So problems that we see is, again, too much custom work. Infrastructure is often seen in organizations as a blocker, like getting environments created or changes done and so on, or are things which are kind of something that slows us down rather than helps us to kind of move quickly. The costs aren't always well aligned. By that I mean not just there's a lot of attention on cloud, FinOps and those kind of things around the cost of the cloud vendors and resources, but there's also just the kind of cost of ownership and how it kind of scales as our organizations scale and all that is, it's just too much. And we often don't have the confidence of our organizations in terms of the systems, are they stable? Are they going to be reliable enough? Are they going to scale when we need them to scale and so on? Are they compliant with the things they need to be compliant with? So there's often very low levels of feeling like everything is really in good shape, right? It's all kind of it feels like it's coming apart at the seams a lot. And legacy accumulates, so keeping systems up to date, whether it's databases, core systems, whatever, keeping up with them is really hard. So where we would like to get to is we want to be able to kind of share more infrastructure code within the organization and ideally across organizations. We want to empower teams. This will be one of my themes a little bit is helping teams who are using the infrastructure to kind of do it on their terms and be able to kind of help themselves basically. Building governance into the system, so rather than kind of building things and having somebody come and tell us where the flaws are or whatever, that it's something that's kind of inherent in how we work on our infrastructure code, how we deliver it, how we deploy it. Lower the costs of scaling, and here I don't just mean scaling in terms of the number of users of the system and the capacity. I mean, as we put more workloads onto it, run more things on it, have more teams working with it, and even as we do things like going into maybe different markets, different products and so on, where you have multiple instances of things, often this is where things get really difficult in terms of that kind of, again, that cost of ownership. So a lot of times, clients that I work with, where they're going to go, okay, we started out in this one country, maybe we started out in the UK, and now they want to roll out in other countries. It's like each country they end up having to, for whatever reasons of kind of local regulations or this or that, they need to they kind of copy the infrastructure code over and maintain it. So everything kind of like grows linearly, and even like people, we're going to need a separate team to manage the infrastructure for each country that we go into. That just doesn't feel like kind of where we want to be with infrastructure code. Then in terms of that legacy, if we could be continuously updating from everything from kind of like patches and the very kind of low-level basic system updates to the higher things, upgrading of the kind of the stacks and so on that we use, to basically get away from having to do big bang transformations every few years, which are very kind of risky and expensive and disruptive. If we can kind of do that more continuously, it'd be great. So how are we going to do this, right? So I'm going to talk about three kind of areas of things, so three kind of parts to what I'm going to talk about today that all join together. So one is rethinking the architecture for our infrastructure as code, how we deliver it, and then how we do deployment, how we deploy infrastructure code and do provisioning and so on. So I think there's changes to all of these. So in terms of architecture, the big problem that we often have here is these monolithic infrastructure code bases and monolithic deployment. So when I talk about an infrastructure monolith, it's not just that it's a big project, say, it's that we have the infrastructure for different workloads that are all kind of deployed together, and not just infrastructure that's kind of shared. It's one thing if it's shared, if it's like a Kubernetes cluster or some kind of shared networking, that kind of makes sense. But if you have, like, say, this application is using a database, this application has, I don't know, virtual machines or whatever, and those are all defined inside the same deployable infrastructure code project, right? What you're having there is you've got kind of low cohesion and high coupling, right? So it's like, basically, if I'm going to make a change, I need to make a change to the database for this application. That means I can potentially impact the infrastructure for other applications that are running on it. And while there are kind of features in infrastructure as code and the tooling that we use to help us manage that. So for example, we have, you can say that, well, if I only change the code for that database, it's not going to affect the code for this virtual machine. Well, if you've worked with infrastructure code, that's not always how it plays out, right? A lot of times something changes that you didn't think should have changed. But then you can run a plan, like Terraform plan or some kind of preview command that will tell you, well, that's going to change. But the point is that this is like a cognitive load, a cognitive overhead of like, I just want to change that database. Why do I have to kind of like be kind of combing through the output to make sure that I'm not going to break something else? What if that does change, something else changes that I don't mean to change? I have to go and kind of track down why that's happening. And it's like, well, I shouldn't have to think about that. I should just be able to think about just the thing that I'm actually trying to change. And so all of this creates barriers to making changes. It means that, we need to have like more governance. We need to kind of have coordination. If you want to deploy a change to the infrastructure that we use, then you need to kind of discuss it with everybody and so on. This makes barriers to change are barriers to quality, because if it's hard to fix something, if it's hard to make changes to something, if there's a lot of process around that, that means it's going to be harder to make fixes to it, improvements, and so on. And so you end up accumulating technical debt and so on, because it's just, you just kind of build up the list of things that we need to change at some point. So how many folks use Terraform or have experience with Terraform out of curiosity? Yeah, okay. That's most people here. So the things that I'm talking about apply kind of regardless of tools and specific tools, and regardless of like the cloud platforms. But Terraform is like kind of the 800-pound gorilla in this space, and also it has a lot of the kind of design issues are that I see are kind of driven by that, because it kind of drives the mindset of how we think about infrastructure and infrastructure as code. So one thing is that when I go to a client and it's like, we have a big Terraform project, and it takes like, I've had a client where running Terraform apply could take 2 hours to complete, because they had literally 60 MySQL RDS instances in one file within this project. And so the kind of first conclusion was, well, hey, let's break it up into modules, right? We'll use Terraform modules like libraries, right? This will help us kind of make it, nicely structured and modularized code base. Well, the problem with modules and any kind of library type thing is that they, you're still deploying them all together, right? You're still going to run your Terraform apply. It's going to pull all those modules in, and it's still going to kind of, still going to have that 2 hour or however long deploy and that blast radius, so that risk of breaking something that you didn't mean to change. So that doesn't really solve the problem, that I'm talking about. It's great for organizing and sharing code. So it's not that there's no kind of purpose to them, but it doesn't help with this particular issue. So what we really want to do is kind of break up, and this is familiar from like with software monoliths and so on, where we talk about microservices, or at least smaller services and smaller divisions of things. So we want to do the same thing with our infrastructure, have multiple deployable projects, deployable components that we can develop separately, test separately, and deliver into our kind of system separately. And this is it's not like a new like insight or whatever. It is something that we do on projects, but I think it's that, again, the tools aren't really designed to make this really easy to do. So we end up having to do a lot of extra work then to kind of make this all work. And what we really need to do to help this work is kind of more helpful abstractions. How many people saw Jim's talk earlier this morning? Because so Jim Barrett was talking earlier around some things like abstractions and a lot of different topics, which I think really it was kind of nice kind of feeds into this, right? So I'm taking a lot of the concept that he talked about and thinking about how do we apply it to infrastructure. So the thing about abstractions is they can be controversial when you talk about these abstractions and platforms. And so I think the important thing to remember is that abstractions are not helpful if their purpose is to hide things. You know, developers are too stupid, right? They don't know this stuff, and so we'll hide it for them and not let them know what's going on. We'll just give them a black box. You know, that's not helpful if you can't see it and understand what's going on underneath. Or if they're there to disempower people, like we're going to force people to do the right thing. Again, you know, they don't know the right way to use infrastructure, so we're going to force them to use it or to structure their applications. And so we're going to make them do it the way we think they ought to do it. Again, that's not helpful. To me, the important thing with abstractions is that kind of context and the cognitive focus. So if I'm working on the business logic for an application, I don't want to have to be thinking at that point about network routes and routing tables and how all that kind of low-level stuff works. I might need to, so I might be working on the business logic and I might deploy it and find it runs slow. And so I want to be able to have the visibility into what's going on and to be able to understand it and troubleshoot it and maybe even contribute to fixing it. So to me, it's about focus rather than anything. So with infrastructure and infrastructure as code, I think the abstractions that we have, again, with most of the tools that are out there, are not really helpful enough, right? So most infrastructure as code is really low level, right? So it's really kind of dealing with very, the kind of primitive concepts of what the platform gives you. So routing tables and routes and gateways and these kind of things. And that's great for systems administrators. I think especially a tool like Terraform, I think it's kind of targeted at and written by people who think in these ways, and it makes sense to them. Kind of developers and people who are responsible for deploying applications and running them and all that kind of stuff, they're not necessarily thinking at that level all the time. Right? Again, it's about context and what you're trying to do at a particular point in time. So to kind of put it visually, if you think about, okay, you've got your application that's running, and what it really cares about is just the infrastructure resources, just the things that the cloud platform provides you, via the API, the kind of, those low-level primitives, right? And when you run your infrastructure as code, however you've organized it, however you've delivered it, at the end of the day, you end up with this is what you end up with, right? And so this is the raw, what's happening. And when we think about code, so stacks is the term that I use for the deployable unit of infrastructure code. So CloudFormation and CDK and Pulumi, they all talk about stacks. Terraform doesn't actually have a term for this. It's kind of at the code level, it's a Terraform project. You have a state file which correlates to this. You have a workspace which maybe contains things for managing this. But when you talk about you ran your Terraform project, you ran apply, and you have some resources out there, you don't really have a term for that collection of resources. What is it? And to me, this is a symptom, right, of the fact that, for Terraform in particular, this is one of the most important concepts in terms of a unit and a module that we work with when we're working with infrastructure as code is the unit that we deploy, as an independent group. And the fact that it's kind of not defined and kind of treated as a first class object or what have you in the Terraform ecosystem is why I think one of the reasons why we struggle a bit. They focus on, modules is the thing that they provide you, which is not necessarily, you can use it as a deployment unit, but that's not what it's designed for. So, what happened here? Okay. Right, okay. It wasn't the screensaver because that was still on. So I mean, there are cases where what's interesting. So when I talk about how this is not treated properly, I think it's interesting that a lot of the tool or some of the things so if you're familiar with TerraGrunt, this is one of the most popular tools for helping you to work with Terraform projects. One of the main things that it does is it gives you a way to take a Terraform module and use it and deploy it as a deployable unit. It gives you a structure for doing that. And even HashiCorp themselves are coming out with, so they have a feature called no-code deployments, which is basically take a module and deploy it. And they basically on the kind of behind the scenes, this is on their cloud offering, the kind of commercial offering they have. You can get the access to this feature where you can use a module as a deployment thing and it will kind of generate the stack stuff for you. And so again, I think those are kind of indicative that this is an important concept and I think most of the things that we get or being given are kind of hacks to kind of help us to do this. So anyways, there's another thing which I think is emerging in terms of levels of abstraction out there, which is I'm calling infrastructure products because there's not really, it's not got a lot of, there's not a lot of, there's nothing out there that I've seen that kind of talks about this at this level. But there are a few products that have features for this. So Pulumi has Pulumi Applications, which is basically a set of, lets you define a group of stacks they call micro stacks and deploy them as a unit and provide them as a unit. Let me say a little bit more about what it is first. So basically the idea here is it's a collection of, potentially a collection of stacks. It can't just be one stack. You can't just say I have one Terraform project and I want to treat it as a product. But the idea is that it's presented for use, like, so who's using it? Who's those, say, application developers or somebody who's responsible for that, who isn't necessarily, a wizard with the low-level Terraform code. How do you present it to them? What's useful to them? It's not just around the presentation, it's also what is kind of a useful collection of stuff that provides a service. So you might say something like even just like a database. So you have Terraform code that can define an RDS instance in AWS, but there's usually other stuff that you need to put around that, like security policies and other kind of things. And so if you kind of say we might wrap and present to our developers, look, you can have a database. There are a few different things that you might care about, like maybe it's things like what type of data are you storing? Are you storing personal data? Are you storing financial data? And so do you need different levels of controls around that? You can kind of like build that into this level of infrastructure as product and say, I want to deploy a database instance that's going to have personal data, and so it does the right things, right levels of encryptions and policies around it. Versus if I want to use it for less sensitive data, maybe it won't have all of those kind of things. And so I think that's thinking about that useful level of abstraction for developers, I think, is more and more important. So I mentioned Pulumi has something for that. HashiCorp are coming out with a feature confusingly they call stacks. So in HashiCorp and Terraform, stack is not what everybody else calls a stack. It is basically, it's kind of like a Terraform project that calls other Terraform projects or modules or so on and wires them together. And so I think that's getting at this problem that we need this level. They know people want that kind of level of control and stuff up there, but it doesn't really currently implement it in a way that is focused on those users. It's still kind of like for Terraform users, system administrator types, to be able to kind of, it's a convenience for them rather than for the users, if you see what I mean. There's a couple of other tools I'm going to list at the end. Like I have all these kind of tools which I think are interesting and potentially useful for some of this stuff, and some of those also are kind of targeting that level. So I feel like this is an emerging thing. Like I see the need for it, certainly. Most clients that I work with, most projects that I've been with, we've kind of like implement this by hand. With our own kind of custom in-house thing. You have like a YAML file that like says, here's the Terraform projects and how to wire them together. And so I think vendors are starting to see this, some startups are starting to see this and trying to kind of make this happen. So that's the kind of architectural highlights, I guess. In terms of delivery and delivering infrastructure as code, some of the kind of issues it drills down a little bit of a level of the problems I was talking about earlier. Common things that I see with teams and organizations using infrastructure as code is that they find that environments are difficult and expensive to create and start up. And so it's kind of like, we say, we need an environment, we need to do some performance testing, we need an environment for that. The infrastructure team has to kind of go and create that. And it's a project of its own right to do that, right? It's not an easy thing to do. And then changing them is expensive and disruptive, right? So it's like, we have to upgrade. We're going to take the development environment down for a day or two because we're going to upgrade Kubernetes to a new version, and that's it's a lot of barriers to change, and then because of those barriers to change, often different environments are at different levels, right? We have the old version of Kubernetes in that environment, it's fine. We've got it over here. Okay, you deployed your stuff, it worked there, it doesn't work here, blah blah blah. And so that's kind of a common thing where it's hard to keep everything consistent and up to date because of how difficult it is. And then you also get not enough environments. So there's two different things that happen. You have contention over environments. Different teams are trying to deploy their applications and they're kind of getting in each other's way and break things, or they have to wait on each other, or you have a policy, you're going to have to wait for the other team to finish testing their change and their new feature before it's available for you. But then at the same time, in the same teams, you'll see we've actually got environments that are over-provisioned and underutilized. So and it's a funny thing, is these seems like they're kind of like contradictory, but what happens is you get that environment created because there's this demand, and so you have the infrastructure team go and spend a week or two creating that environment, and then when you're done using it, you leave it, right? Because it's too, we're not gonna let it go, right? No, we still need that, we might need it later. And so you end up with a lot of environments that are provisioned too large for the purpose, for any particular purpose, and then aren't always used, and then you get those kind of times when everybody's crushing to get it into what's available. So to kind of like talk a little bit about how this happens, there's this, I'm going to talk about the infrastructure delivery lifecycle, and I have three kind of like parts of it that I'm going to talk about to kind of think about how we can kind of rethink this. And so one is where we're developing the infrastructure code, we're writing our Terraform code or whatever, and testing it out and so on. And then we're running we're applying it and running it to create environments or make changes to environments. And then there's the teams who are actually using it, deploying their applications on it and so on. So these are kind of like three different parts of the process, really, the life cycle. And so I want to talk about recoupling it, right? So currently, the way it's coupled is kind of like this, right? So most of what I see and most of the way that I think infrastructure as code tools and most of the kind of training materials and examples and tutorials you see out there are kind of aimed at this idea of you're going to write infrastructure code for very specific, it's for this one application and this one environment and working in this one way. Maybe you reuse the code across multiple environments, but you probably have stuff that's fairly hard-coded. And so it's all very bespoke. And so this is kind of okay when you've got a smaller system and a smaller team where there's really high levels of collaboration. So we need we've got application developers can talk to the infrastructure teams so that they can make the changes to the infrastructure code so that they can deploy the next, the change that they need to their application, and they work closely together. So that's kind of okay at a certain level, but it does create a coupling across the lifecycle this way, and it's at scale where it starts to hurt, right? Because at that smaller scale, you might not even have different teams, right? We have got the one team, and we work on the infrastructure, we work on the application code, and everything's cool. But as you get more and more workloads deployed onto the thing, and more teams using it and so on, that's where it starts to make that collaboration a lot harder. And so that's where you start getting, well, we need a separate infrastructure team now. And that infrastructure team is going to have to start working, going to have to kind of raise tickets or get things added to their backlog. Oh, you need this change for your database, for your application, like I mentioned, because of this new feature that you're working on. You're going to have to wait because they're working on the next, the upgrade to the Kubernetes cluster, and so you have to wait till they're done with that project before they can get around to your thing, right? And so, this is one of those things that happens. It kind of drives silos and drives kind of bottlenecks and frictions between the different people and the different teams. So the situation we have is that we've deployed, we've kind of coupled this way. And what I think we need to do, and in some cases we've done this on some of our projects with some of our clients, is to okay. So what I'm saying here is just that the responsibilities are this way, right? You have the one group or the one set of responsibilities, which is around developing, configuring, and deploying your code, and then the other is getting your application to work once they've done that, right? So what we need to do is what we should be looking to do, I think, is to change the coupling the other way. Yeah. So if we can have the responsibility for developing the code, and then on the other side, responsibility for configuring, deploying, and using the infrastructure kind of together, this is going to enable us to do more of that kind of self-service kind of model and so on. Some of the things I'll talk about. So the idea is that you have people working on infrastructure code, and this is deployable components, so it's not just modules. Again, this is about stacks basically, or infrastructure products, whatever kind of works for your particular system. And it's saying, let's develop those, let's have pipelines to test them and make sure that they're proper and so on, and then make them available to be deployed. And so you put them into like a repository or what have you. And then you've got your team can kind of configure for themselves, okay, this is what I need. I need that database to handle sensitive user data. And here's the module that I use that I've been provided as a stack or an infrastructure product. And so that's what I'll use. I'll talk a little bit later about different ways that gets implemented. But so you take that, and then this is where you get into when I talked about the monolithic infrastructure broken down into different pieces. You get those kind of different components. So different components might be developed by different teams and made available. And by the way, one thing I want to emphasize: this isn't necessarily just it doesn't necessarily mean that it's a team division, right? Like, so this is kind of responsibilities, but you may have teams who have special needs in terms of infrastructure. So often you have, like, say, teams of like data scientists and so on, who are going to use some special, they got special tools and databases and so on and products and things that they need the infrastructure for, and they probably have the experts who know that. So they would, build these things. So it's not that they can't, make infrastructure, but it's just here's kind of the process and the life cycle for that infrastructure that defines here's how you build a deployable infrastructure component, for your own needs, and then here's how it kind of gets managed through the process and deployed. So that kind of final point then, or final part then, is how do we manage the deployment of these things? And so I like this idea of application-driven infrastructure deployment, which I'll talk about. So the contra to that, what we tend to do is what you can call bottom-up infrastructure deployment or bottom-up provisioning. I say deployment because I'm also talking about changes and things. It's not just provisioning a new system. It's deploying that infrastructure code to make changes to your infrastructure. But what typically happens is, and this is tied in with all the things I was talking about before, the monolithic infrastructure, that kind of separate team that's owning all the infrastructure for all the things, is that the process for creating an environment and making a change to an environment is get in the infrastructure team, they create the environment, they deploy the code, they deploy the changes, and then once they're done, then application team, okay, the environment's ready, go ahead and deploy your applications and so on. And this division gets really, really difficult, really harmful, right? So you'll see situations. I've certainly seen situations where, so I was at one client a year or two ago now, where they had a group who was responsible. It was a separate company, so you can kind of see, they were responsible for the infrastructure. And so you can kind of see the pressures that come onto this, right? Because this seems to a lot of people like the right thing to do, right? So infrastructure and software, like they're different things, and so you want to separate the concerns. Application people, like even I said, you don't want to be having to own the infrastructure, so you should separate those things out, right? And so you get a separate company to do it, and so when we went into this particular client who had this group working on their infrastructure, and I was going to organize a workshop, and the first thing I asked them was, well, let's talk about the applications that run on your infrastructure. They got pissed off at me. The guy who was in charge was saying, like, you're wasting my time. Like, I'm not here for applications. I make the infrastructure. Applications are not my problem. Go and talk to the BAs and then come back when you want to talk about infrastructure. And I mean, they had a lot of problems because of this kind of division, right? So they were building infrastructure based on what they thought was important. They thought it was important that every country that they roll out to needs to have completely separate infrastructure with no data leak between, because there's, we know there's like data, protections and regulations and so on. So there's no way to get data from one environment, from one country to the next environment. The people who are responsible for the product, who are also not very open to kind of collaboration across those silos, they assumed that customers would be able to use their product as they went to different countries, because their customers would tend to travel between countries. And so because they weren't talking to each other and refusing to talk to each other, they were obviously heading to a bit of a disaster. They also had a problem where they were worried about the capacity. They wanted to go to China. It's like, I'm going to have loads of users. We need to have the capacity. We're not sure. We think our system isn't going to hold up to it. And so the infrastructure people, they went and they provisioned an environment to test it in, scaled out everything as massively as possible, and did load testing on it. Not with the application. They didn't deploy the software on it. They tested their infrastructure and said, our infrastructure can handle the load. Not our problem if the applications can't, right? And it's like, well, you need to be holistic, right? Things need to kind of work together, or else you are going to get to trouble. So obviously I don't like that. So the idea of application-driven infrastructure is to kind of empower the application teams. And so what you want to do is you say, when we deploy the application, the infrastructure that it needs can be automatically provisioned or updated or what have you for use. And so this isn't about the application developers needing to know how to build all that infrastructure. It's just giving them the ability to use it when they need to, and to kind of configure it to the level that makes sense to them in the way that they need to. And so again, this kind of can work with kind of different workloads, multiple workloads. We can kind of share infrastructure across, well, can we, right? So if we're deploying infrastructure when we deploy an application, what about infrastructure like, say, a Kubernetes cluster or shared networking or so on? Like, when does that get deployed? And so the kind of next bit in thinking about this is thinking about contexts for deploying and configuring infrastructure and these infrastructure components. And so one kind of context is that workload-specific stuff. So this is what my application needs. My application needs, maybe it needs a virtual machine that is just for it. Maybe I need some networking ports open, so I'm going to take inbound connections. Maybe I need DNS and so on. I need a database instance and so on. And so we can define the infrastructure that's just for that application. In that context, by the way, again, so I'm talking about things like context and infrastructure products and stacks and so on. And I think it's not important. What I'm not trying to do is to kind of make a lot of complexity in terms of, you need to have all these different layers. It's just ways of thinking about it. And it might actually be just a simple thing. So it might be that this is just one stack. Each of these is one Terraform project. Or it might be multiple, right? It depends on what you need and what the level of complexity that you actually need for what you're doing. So then you can have a context for shared infrastructure. So, okay, this is the things that we need together. And so we'll define again, one or more deployable components that make up the things that our different applications or workloads need. And you might get into, as you kind of get into larger organizations and more complex requirements, you can say, okay, we've got a couple of different application groups. Maybe they each own their own kind of set. Maybe it's the same components, so maybe they each have their own Kubernetes cluster. Maybe we're using the same infrastructure product to deploy the Kubernetes cluster. So we're sharing that, but that doesn't mean we need to share a single instance of it. It might make sense in our use case to have them separately. Different teams can kind of manage them for themselves. Maybe we have some infrastructure that's shared at that level. So maybe this can be like if you have like an environment or accounts or those kind of things that you define contexts for those and what infrastructure components say need to be deployed at that particular level. And then things like platform services to me also kind of fit into this. So I tend to look at platform services like, say, things like monitoring or identity management or whatever as potentially like applications, or they might be like SaaS hosted things or what have you, but it's like they're just another application that need infrastructure. And so this is the model. We can use the same model for that infrastructure as well. So again, the right thing, the right level of what you need for your organization rather than the needing to fill in all those kind of boxes or multiple, like there could be more layers if you need to in a very large organization. Some kind of, I guess, guidelines or thoughts on how to kind of use and design this stuff. So one is that infrastructure should be defined as close to the workload as possible. So you only kind of bring things down into like a shared level when it actually needs to be shared. I think this is an interesting point because one of the things that you put in at these levels is things like controls and security policies and those kinds of things, which I think a lot of instinct is, well, they need to be down here because it applies. You need to have, it's security is like a high level concern, right? And so when it comes to things like, say, a network, a firewall port, we need to open a firewall port for this application. That needs to be defined with the application because that's specific to the application, not down here. So this is not a hierarchy of kind of control and authority and so on. This is just where do things get deployed when they need to be deployed. Because when you do this, you could do kind of partial deployment. So if you're testing one application or one couple of applications that you're testing how they integrate together, you don't need a full environment for that. And actually you can deploy it on demand just when you need it. And these low-level contexts should be ignorant of their consumers. So you shouldn't have things in here which define, and here's all the applications of their databases and whatnot, right? So the knowledge should be kind of, the dependencies, because that creates dependencies, right? If this knows about these things, then you have a circular dependency, and so you want to make sure your dependencies go in just one direction. So the kind of final bit here is then, how do we kind of manage the deployment of these things and options for doing that? And I'm just going to kind of bullet point a couple of things. So one is, as I mentioned, application deployment triggers. And so the idea here is that you might have like a configuration file. Maybe it's in your pipeline. And when your application gets deployed, you kind of push that So we've done this kind of thing at a couple of clients. We have it's usually like a YAML file, right? And you might even use it in conjunction with tooling for GitOps and so on. So maybe you have an Argo CD that reads this file and manages the deployment of the infrastructure for the application. Or it can be a pipeline, so it can be in the pipeline stage. It can be a push, or it can be kind of like a pull kind of thing. Oh, I was going to say on the pipeline stage, one thing that you can do here is, again, those different level of context. So you can say, we've got a stage where we're going to for a testing environment for a certain set or subset of the applications. And so that can say, okay, we need to deploy this context, which is the group of applications, the infrastructure for those. And so that's how you can manage those different levels. So let's get a quick sip here. Developer portals can be useful. Actually, I would say the difference here of when you want to do it between these for deploying, say, infrastructure, for deploying an environment, say, is that in a pipeline stage, you can do the ephemeral kind of environment. So you can say, this stage of the pipeline, we need to run automated tests on, integration tests across a number of applications. And so that stage can say, provision, the environment level stuff, the shared stuff, and the applications and so on. Then run the tests, and then if the tests pass and don't need to be, you don't need troubleshooting on it, then you can tear that environment down. And so you can kind of save costs that way. You can save costs by, limiting the lifespan in that way, and also by only deploying just as much of the environment, just enough environment, rather than having to use a full environment, full-sized environment that's long-lived. Developer portal tends to be more useful for those kind of longer-lived things where it's like, okay, I want to set up an environment to do stuff over a period of time. You can still kind of time limit it. You can still say, for a non-production environment, obviously, an environment will be torn down after a certain amount of time, even if it's created by a portal. But this can be useful. So some of the kind of useful things we've done is where you have like a QA environment, and the QAs like to kind of prepare their test data on an environment. And so you can have it so they can go to the portal and say, I want a test environment, and these are the applications I want to deploy, and then it deploys the stuff that's needed. And then they can maybe work with it over the course of a week or so. They're happy with it, they're done with it, it gets torn down, but maybe the data gets saved, right? And so maybe the next time they go to the portal, they say, I want to create a test environment again, and can you, I want to use that data, the data backup or whatever that was created because I handcrafted my test data that I really like for that. So there's a lot of kind of interesting things you can do with this kind of model. So there's platform framework tools, so there's things like Kratix and Humanitech, which they make tools for kind of defining platform services and so on, and managing the deployment and provisioning of those. And so those you can tie those into kind of provisioning infrastructure along with it. So you can say, okay, I need to deploy a monitoring service. I'm going to use Kratix for that, and it can also part of it's I forget the term they use for kind of like the blueprint of here's how to deploy the thing, but that can include calling out to the the infrastructure code to provide the infrastructure for it. I think I have one last one. Oh yeah. So yeah, how can you use these ideas? Well, the bad news is you kind of have to do it yourself still, right? There's not anything out of the box that kind of works this way. But the good news is there's lots of stuff out there which is kind of, I think, playing around with this, with different aspects of this, right? And so this is the kind of thing that if you want to take a picture of this. So I'm not vouching for any of these things, or these are all things that basically I'm collecting a list of tools that seem like they might be interesting or helpful in some aspects of this. And so I have kind of messed with some of them. We've had teams kind of do proof of concepts with a few of them. But I'm not sure, right? So this is kind of this is the stage that I'm at. I'm sharing with you, I'm kind of still working through this stuff. So the stage I'm at is I want to see, what toolings, that's out there can help us to do these things better. I'm very keen to hear experiences of people who have, used these kind of things. Yeah. So that's pretty much what I've got to dump on you today. That's the QR code for the feedback form. It looks a little blurry, so I'm not sure if you're going to be able to get it off that. But if you want to give feedback, please feel free to fill out the form. It's the same form, anyways, that you might have seen for other talks. And also, like I said, I'm happy to chat. So thank you. You might have time for one question. One or two. Okay. Okay. we get confusion in our dev teams because there's stuff that they think of as infrastructure, like serverless type stuff, like step functions.
Yeah.
We think of as application deployment infrastructure.
Yeah.
Well, that's good. Do you see that? Obviously, it aligns well with your infrastructure kind of pattern, but do you see that distinction any more clearly?
I think it probably does depend. It's going to depend on the expertise of the team and so on. I think what I would like to think is that this gives a mechanism, right? So I kind of made the point at one point that this doesn't mean that everything that's below the line, that's in an infrastructure thing has to be an infrastructure team owns it. It can be like, okay, this needs maybe some Terraform code to make it happen, or some cloud formation or whatever. So here's how you can kind of package that up and make it reusable and deploy it, right? And hook it into the things and make it play nice with other stuff. So it's kind of as much about this kind of how things integrate rather than necessarily being about ownership. So, is there a hand there?
Yeah, so talk about people level what point you will govern each?
Depends. Depends on what you're trying to govern, right? So I like to push it as close as possible to the thing. So it's like, you have an application and it has, I don't know, a database, say, instance that's just for it. And so you should have the governance for that should be there. And so it should be you can put it in multiple points, as with most kind of security and governance. So in that package, if you've got an infrastructure code package, which defines that database, you've got a pipeline for putting that in and making that available to be deployed. Like, that pipeline should have checks. It shouldn't allow things through that, like, okay, all of our databases need to be encrypted at rest and so on, and they need to have secure, a password policy or whatever put onto it. So that kind of needs to enforce it. And then deployment time as well, you can enforce things like, does it have the things that it's supposed to have? And so, yeah, I think the answer is, multiple points and as close as possible to where it affects. You don't really want to have policies that, I know a lot of people like to have, like, we put the policies into the global level, and you get this with, like, landing zones that the cloud providers have. It's got all the things for everything, and it's like, well, it really loses. It needs to be close.
One last very quick question.
Yeah.
Yeah, so we've got Terraform specific questions.
Oh, okay. Yep. Yeah. I think how you deal with it in today's world is pretty much the way you've described. That's how most people deal with it. I think it's an issue. So I'm kind of going like into the bigger and fuzzier aspects of it. I think it's an issue because, again, modules weren't really designed necessarily for that. I think it's interesting when you look at Terraform in particular. So Terraform itself as a tool is built up of providers. Like the functionality that they provide is created by providers. And so providers I think are pretty good, right, as a way of and you have updates to providers and all that, and they work pretty well because it's their own, the phrase, their own dog food, right? HashiCorp doesn't really do a lot with modules for the things that they are selling and providing so much. I mean, maybe a little bit more now with HashiCorp Cloud and all that. So I think it's kind of like, it's not as mature a construct. It doesn't, it's not, I just think that it needs to come along further. I think there's also something to me around the idea that library level, selling things at the library level is kind of hard. And so this isn't as quick an answer. You guys said it's a quick question, but so way back in at the end of the .com boom, the company that I kind of went bust with was, one of the things we were doing was we were working with Java, and we made Java libraries, and we're going to sell them, and it's like nobody wants to buy Java libraries because they can write them themselves, right? I think the level of what you can kind of reuse and share is probably a bit higher up than that, probably at that infrastructure product level. Here's a useful thing. But even there, I think just like the tooling and the ecosystem of stuff needs to come along before that's going to really work as well. So I think that's another symptom of the spaghetti infrastructure that we're in now. Sorry.
Great. Thanks so much, Keith.
Thanks.
So you may remember this from last summer when 500 flights were cancelled because of one data error. And Willie Walsh, who's head of IATA, estimated it cost £100 million. He isn't known for understatement, but anyway, it did cost a lot. He is known for understatement. NATS had a hot standby system, but that wasn't going to help because it was the data that was the problem, not the application. Although you could say it should have tested for that condition, but that's a bit harder than you might think. With this audience, I expect this slide describes the way you work. Not in many places where I work, but hopefully here. You release software only when all the tests pass. But then your application is vulnerable to whatever data is entered into it. And data changes all the time. You keep getting new data. So the data can hit your application by a number of routes. If anyone thinks of another one, do tell me. We'll go through these one at a time. User input. This stuff really ought to be obvious, but often isn't in the systems I find myself working on. So the data entered by users should be validated, usually using form controls and JavaScript, before it's sent by the form to the application. Mozilla, which does have some quite nice documentation in this area, says that you should check the data again when it hits the application, and I agree. In terms of form controls, I mean, date pickers are good. It means that the user gets visual confirmation of the date they're entering, and there's no confusion about date formats. If you're dealing with any kind of international organization, or even one in this country that has its terminal set, its client set to different date formats, that can cause chaos. Address lookups are easy and cheap in this country as well. But it's amazing how some really mainstream organizations don't use them. But again, you can be much more sure that the address will be correct because the user gets visual confirmation and it will be in a sensible format. Email addresses and telephone numbers are a bit more complicated. We'll come back to those. And another factor in this is user training, because there are responsibilities on both sides, but a responsibility of the users is to know that they just can't type anything anywhere. And some users get quite upset about that. Why won't it let me type this in here? Well, because it doesn't make sense. But that means explaining why that's important. Data from databases can be guaranteed to be clean in various ways, but not always, because the database can do a lot of the work for us, and we'll come back to this too. If the data arrives in a file, it's probably been interfered with by Excel. So that top box there was a text file. The only thing I've changed in that is the spacing so that you can see the columns. But that's what I typed in, opened it in Excel, closed it again, opened it in the text editor, and all those colored things have been changed. And it happens all the time. Phone numbers without zeros at the beginning. Who's come across that? The other thing is this byte order mark. A byte order mark, if you were using UTF-16, which hardly anybody uses, it tells you which order the 2 bytes in the character are. But Microsoft uses that to indicate to Excel that it's got a UTF-8 file. And of course, that would be really weird because only 98% of the world uses UTF-8 now. 98% of the web pages in the world are in UTF-8. So I and many other software developers and product companies have had to do extra work to deal with this stupid 3 bytes that Microsoft has stuck on the front of the file. Does anyone listen to Tim Harford's More or Less? There's a great program there, and the link's there, so when you get the slides, you can look it up. about some really serious Excel errors done at national government level. And so that's enough on Excel. API calls, they're usually going to be an XML or JSON. And that does come with, those formats do come with metadata, but it's not like a database where the data in the database has to match the metadata. If you choose to create an XML file with data that doesn't make sense in terms of the metadata, nothing's going to stop you. So that has to be checked as well. And that comes down to us as developers. That's our job. Data from devices, Internet of Things. I was lucky to work on one of the early versions of early instances of a car insurance system where they put a box in the car with the customer's consent. They actually got some benefits from doing it. They might have lost some in terms of surveillance, but anyway. But the box in the car sent back data every few seconds about the location and acceleration in 3 directions, backwards and forwards, up and down and sideways. So you could tell things that were happening to the car and you could kind of grade the performance according to that. And occasionally we would get a latitude, longitude reading which was 0, 0. And that's a genuine, those are genuine numbers. It's that point down there, which is where the Greenwich meridian meets the equator. But if someone's going down the A3 past Guildford and you're getting all these points and then you get 0, 0 and then back to the A3 again, you know, that really messes up the speed and acceleration fees. Another more subtle thing that happens, so when I live in Kent, and if I'm going back in the evening on the train and it's raining, it's quite useful to check where I am sometimes if I haven't been paying attention to where the last stop was. So this is from an actual journey. So I was coming back along from the top left. There's a little red line there. I was on the railway line and going up there. And the signal from the, this was with Google Maps, which uses the same technology as the car insurance system. The signal from the box does tell you how accurate it is because it will tell you how many satellites it could see. And that makes the difference between a 5-meter circle and a 100-meter circle, or none at all. In this case, it was big, and that circle was big enough to cover a road and the railway. So the next layer of software was saying, it's got a road and a railway, it's probably on the road. So the red line switched down there until the circle moved off the road and back to the railway, and it switched back again. So we were getting data like that with cars on the road, and that could be important because we were looking at people breaking the speed limit. They got bonus points for not breaking the speed limit. And if there's a place in Scotland where a motorway runs right beside the road, and we had one of those, and the guy complained because he'd had points docked, and actually it was because the low-level software had interfered with the numbers and given us something inaccurate. The other way you might get data into your system if you have startup parameters or environment variables or some configuration files or something. Hopefully, those will be in your version control system with the release and you wouldn't change them at runtime. But if there is a situation where you need to do that, or somebody's done it through bad practice, you've got to change those, check those values when they hit your application, and hopefully you can make sense of them, or at least detect if they're wrong. So that was a brief overview of source data. We're going to change gear for a minute and look at how defects work. And there's some counterintuitive things in here which you may or may not be familiar with. But typically, in a system with many components, and those components could be data or code, 5% of the components will account for 50% of the defects. That's been measured in systems from way back in the 60s, I think. It's in a book from that era. It's still true. But that does mean that many components are defect-free from the day they were written, which is great. But the third point is the one that's really counterintuitive, because you think if you tested this thing and you found lots of bugs and you fixed them, that's going to be really good. But actually, the thing you didn't know was how many bugs were in there in the first place. And what has been found is that the more defects you find in a component, the more defects are left in it after you fix them. And that applies to data encode. Now, this was some work that was done in '79, a long time ago. But they took this idea and plotted the number of tests along the bottom and the number of failures. And then for each component, so the black line is one that isn't very good, and you keep finding bugs in it the more you test it. So eventually you get to the point where you reject it. And the white one is the converse, where you do lots of tests, you don't find many bugs, you fix them, you feel more confident about it. I think the concept is worth bearing in mind, but actually quantifying it, and I think probably why this isn't used very much, quantifying it is impossible, because how do you measure the number of tests? How granular are they? How do you know where to put those areas? But I think understanding that general principle at least should give you the confidence, which you might feel intuitively is, I keep finding things wrong with this, I'm going to scrap it and start again. That's what you should do. So how can we test data? We mentioned some of these. And what we've got more to say about is databases and files. So I think the easiest way to test data in a file is to load it into a database and use the database facilities to help you do that. And how difficult that is depends on what database you've got available and the structure of the file. But if it needs to be structured data. I mean, everything I'm talking about really is structured data. I'm not the kind of social media and Google contents, not really. It's a completely different story, I think. So I use Postgres. It's a good database, it's free, and the copy command's great, and you can use CSV files. And CSV files, if they're used properly and they're very simple, work really well. I've seen people do all kinds of things with them, like putting double delimiters in, which is completely unnecessary. But anyway, so that's to get it into your database. So I'm going to illustrate this with a case study that I actually did. It's for a leisure organisation that did a deal with a supermarket chain. And the supermarket's customers got information and discounts on the leisure facilities. The leisure company got a list of contacts. And I got this file of, so I was helping out a team and they didn't really know what to do with it. And I got this file of 26,000 contacts to add to our database. So I had a quick look at it. Nice, simple structure, just a few fields. And the first thing I wanted to do was to get it into the database and then profile it. Now, you may have a data profiler. You can certainly buy some. You can also get one free off my website, because I don't sell software. I give it away. And this is the output from my profiler. The stuff on the first three columns on the left are from the definition of the table that I created to put this data into. And then the right 2/3 are things about the actual data that was in that file. So I created the table with very kind of lenient data types because I didn't know what would actually be in it, whether it makes sense. Allowed everything to be null. I didn't find many nulls except in the phone number. Tells you the distinct value count. And the top one's quite interesting. It's the club card number. And it's the same as the row count of the table. So that means it's a candidate key with this data set anyway. Card number, what you'd expect. Look at the email address, and if you can see, that's pretty small here. That one's clearly wrong. Everything else looks pretty plausible. We'll come back to one other thing that isn't. And then the two things at the right there, frequencies and patterns. Patterns are only applicable to strings, but frequencies for everything. So we'll look at frequencies. We look at the title. Oh, I should say this is fake data. What I did was take the profile of the real data and create fake data that was very similar. I was a bit wrong on the kind of high-level titles. There's rather a lot of generals and brigadiers in there. But the Mr., Mrs., Miss, and Ms., those, so the three female ones add up to about the same number as the male ones. That doesn't prove anything, but at least it's a plausible number if you're dealing with this kind of data. Those frequencies can be more useful in some other kinds of data. Patterns. So the characters in the string are classified according to those groups. So 9 represents any decimal digit. So these are phone numbers. The little s is a space. The plus sign down there is any mathematical symbol, although with a phone number, it's quite likely to be a plus because that's a valid thing to put in a phone number. So we learned just from loading that data and running the profile that the club card number is unique. Always starts with 7. It's always 16 characters long. So that's great. Consent 1 and consent 2 are always yes. Otherwise, they wouldn't have got into the data set, I presume. So they're just not interesting. And this was a fixed thing. You know, they ran it once after a year of offering the service, and then we had that one file. So we weren't going to get any more. The email address has some errors. We'll come back to blah, blah, blah. Phone numbers are inconsistently formatted, but that's okay. Oh, and they've got this convention MX where people don't want to give their gender away by their title. And they put it as XMX, so that was just a simple change. Validating email addresses. They're defined by several RFCs. You probably know our requests for comments. They're not quite standards, and although they didn't make it into being standards, that's as far as it got, and they pretty much define the standard. Maximum length seems to be 320 characters. I think you'd have to be very masochistic to have a 320 character email address if you really like typing. Some characters are not permitted in some places. Some email clients don't accept email addresses that fit the RFCs, and other email clients do. But again, you'd have to try quite hard to get one that doesn't work. And there are dozens of validations available on the internet. And the one we used didn't reject any valid email addresses and did reject quite a few invalid ones. So it's useful, but not infallible. The highlighted bit in yellow is the key bit. Regular expression. If you're not really familiar with regular expressions, that link there is really good because it explains how they work and it tests them for you. Really good. So that one does work, and there are errors in those which I'll highlight for you. And you can see we've got something indicating an invalid character. We've got right arrows, all kinds of things, double dots, double at signs, I think, somewhere as well. So these are genuinely erroneous email addresses. And what the organisation I was with was very good in, where they've got an invalid email address or an invalid phone number, they try the one that looked valid and see if they could get it confirmed. Because you can guess what some of those should be, but we shouldn't be guessing about data. We should try and confirm it, really. Telephone numbers are really much more complicated than you might think. And people do write their telephone numbers in different ways, and Ofcom actually says that you should be able to. That's fine. But if you write that one, it could be the country code for Kazakhstan is 77, and that number is some corporate network in Kazakhstan, but it's probably a UK mobile. It would be good to check, but that's one I might guess, I think. Government Design Guide refers to Google's lib phone number, Java library of about 4,000 files. But even that's not foolproof, and Google says so. You know, it doesn't validate everything properly. Where I was working, they didn't want Google stuff and 4,000 Java files, so we wrote something simpler, and the source code is available, but it's nowhere near as comprehensive as that. But we use reference data from Ofcom for the UK numbers and from something called International Telecommunications Union, which gives you all the country codes. So we put all that in, you just copy those numbers and validate it. And what we found in that data was 2% missing, that's fine, they don't have to give us their phone number. 3% had errors, and all kinds of types of errors. So again, we hope that the email address is right and we can check these, because again, you can't safely guess. Right, so that's that kind of error. Another thing that comes along a lot is duplication. If you've got a reasonable sized database of data about people, you've almost certainly got some duplicates in it. I've never seen one that didn't have. When you're inputting a new file, that may duplicate data that's already in the database. And it may have duplicates in it as well. So finding duplicates is quite important. I won't go into this because I'm talking too much. But this is how Microsoft suggests doing it. Microsoft splashes AI all over all its marketing material. It's got the most stupid thing for finding duplicates that doesn't work. There is something that does work, which is great. And Microsoft's got this function in its Databricks product, because it just recently bought that, but not in its mainstream thing. Levenstein edit distance was invented in 1965. And it's really simple. It tells you how many single character edits you have to do to change one string into another. And it's a standard function in Postgres. So changing banana to Panama, you just have to change the P and the M, and that gives you 2. Changing pomegranate to Uzbekistan is obviously a few more changes. So what we can do is look for records where the Levenstein edit distance is small. Obviously, if it's 0, then they're exactly the same. But this method, which I haven't got time to go into in detail here, but it's on my website, and it's got all the code as well, how to do it. But this one over here, for example, can't see it because I'm standing in the way. Prasad and RR Assad, same first name, exactly the same first line of the address, exactly the same postcode. That's almost certainly a duplicate, and the RR Assad is almost certainly an entry error. So that is one I might change just anyway, but mostly, again, the best thing to do would be to actually check which thing's right. But that's far more effective way of finding duplicates. Right, the next thing is missing data. So data exists somewhere, but it's not where you want it to be. This happens especially if you're synchronizing with other systems. I've done quite a few data migrations where, we're taking data out of a live system and putting it into what's going to be the new system. But of course that's changing, so you've got synchronization issues with that. and again, how not to do it. The product that it was going to was being installed by and customized by a $48 billion international consultancy, and I asked the project manager how he was going to make sure that our 80 million transaction table was actually the same when it got into their system. And he said, oh, well, we'll eyeball a few records, of course. It's like taking a handful of straw out of a haystack and expecting to find the needle in it. So, anyway, again, there are better ways of doing it. It can be a challenge if you've got two different data sets in different systems. And especially if they're changing, if you can get a kind of synchronization point, then at least, count the records. Did you get the same number as you started with? But you can be much better than that. You can count by some partition of them, like the year they were created or the month they were created, whatever. If they're financial records, you can check the total amounts. They should come out the same. And those kind of queries aren't really expensive. You're not comparing each record with each record, but actually those aggregate values. And we can also use hash values like you do if you're downloading files. So we can actually see if, at least try to see if the data is going to match. How am I doing for time now? 26, perfect. So once we've done all our checking, then things are going to keep on changing. And we want to monitor our data as it's on its way into the system. And we have a tool for this thing as well. This was a real one. This one only had about 100 tests each day, but I have run this with up to 1,000 tests a day. In systems, well, we'll come back to how you fit all those tests in. But what it does, in this case, it was organized by subject areas and how many errors we found. And you can see on this particular day, we found an error in the transactions and in the merchants subject areas. And when we look at transactions, drill into that, this is measuring the actual value for the number of transactions and the change from the previous day or the previous run, mostly daily runs, these kind of things. And that change was really pretty big compared. Oh, it's we measure the size of the change, not the sign. So it could be plus or minus, but it's a big change. And the average transaction value, likewise, although if the value is 249 and the change is 897, then it's probably a decrease today. So then we get a graph of it. And what the monitor does several types of graph, but this seemed to be the most useful one because it records the date and the value and the change. And it assumes that your data falls into more or less a normal distribution. It's not guaranteed at all, but very often the case. It's very often close to that. So the green area is where today's change is within 2 standard deviations of the mean, which for those of you who are mathematically inclined would be 95%. If it's a real normal distribution. The yellow area is where it's between 2 and 3 standard deviations from the mean, which is about 4%. And the pink is anything above that. And it would account for about 0.3%. So you would expect, if it is a true normal distribution, that you get about 1 a year in the red. Here we've got 2. So what happened? So this was a financial payment processing system. And I would come in every morning and check those charts and find this. And on this day, Friday the 13th of April, 2018, it looked like that. I thought, we must have loaded the transactions twice. But anyway, we checked into it. And of course, that's not measuring Friday the 13th, and anyway, that doesn't make any difference. It was actually recording what happened on the 12th of April, 2018. Anybody know what happened then? It was the Grand National. For anyone who's as interested in horse racing as I am and doesn't know what that is, it's a big horse race. And what had happened was people had started betting using payment cards. And that accounts for a huge spike in the number of transactions and the fact that the average transaction was smaller. Millions of tiny bets. So when we checked it out, it wasn't a problem. But you can see that being able to detect that kind of difference just by an automated process that runs overnight and then somebody, looking at a couple of screens, that's quite powerful if something's gone wrong. So it is automated. We would run it every night. The tests are written in SQL. They're very simple. You just have to write a SQL query to return a date and a reference to the thing you're measuring, a factor ID, we called it, which has got some metadata describing what it is, and the value. And then it calculates everything else from that. Again, it's on my website, and you're welcome to use it. If you do and you want to contact me, that's great, but if you all call at once, it'll take a while. So since this is most useful in a live system, we have to be careful about what impact we're having. So often there's a quiet time at night, but often there are batch processes running at night time. We have to look at how much of this testing we can do and coexist nicely with other things that are there. So standard risk analysis, what's the probability of a so far unidentified defect, and what would be the impact? And as we've seen, impacts of this kind of things can be very high. The match flight plan error was £100 million or something, and post office Fujitsu thing, well, that's just horrific. But that was presumably application error or possibly human error, but it was affecting the data, and if you'd been monitoring the data, you might have had a better chance of finding it. So our default setting is to run all the tests every night. If that's taking up too much time, I've only found one case where we were starting to bump into time that was needed for something else. So what we did was to run different tests on different days so that over the week we cover them all. And also, if we've got some data that we're really confident is static, then we can test it even less frequently. So you can apply the risk analysis. I wanted to sum up. Yeah, doing right. To sum up, I wanted to classify the sort of things that I thought we could do to improve the situation. And I came up with these 4 categories, but it's fuzzy because many things live in both categories. But anyway, let's go through them. So, looking at behavior, I mentioned users, working with the users, and of course, if we're all being good Agile developers, we will be working with our users all the time. So hopefully they will have automatically a better understanding of what the data is doing and why it might be important. But that's something to really bear in mind and work with them on. But they have to have the features they need so they don't improvise. Because if someone's trying to do his job and his boss wants it done by this afternoon, and our system won't do it for him, then he will improvise and things get bad. That happens especially with duplicates, of course. If they can't find the person that's on the phone in the system already, then they'll create another record. And it's not their fault. We have to work with them. On policy, Excel is useful. I mean, I do use it. Someone was talking this morning about pivot tables, and yeah, I do that. But not to prepare data. And yet that is Microsoft's recommended way of getting data into Dynamics, apart from users entering individual records. But when you get things like, our thing from the leisure company in the supermarket. What Microsoft said is put it in Excel, load it in. Well, it's a disaster. And it was a disaster, actually. I don't see any reason for not using UTF-8 everywhere now. But again, Microsoft still thinks we should use Windows 12.52. When you find a data error, just like application testing, add it to the test suite. Because, as Hunt and Thomas say, the first time a human being discovers an error, a defect, that should be the last time a human being discovers it. It should be. It should be in the test system. Avoid large package solutions. This is kind of a personal bruising from the last 5 years of trying to help people with Dynamics and Salesforce. They just seem to be defect factories, those things. And they use common data models, which is another really bad thing because your data will not match a common data model. No matter what you're doing, it won't match a common data model. So you'll put data into fields that have a description that clashes with it or has the wrong data type or something. So, and it's not hard to build your own data model. It's much harder to try and cram it into a common one. So don't do that. Windows, I've tried to avoid Windows ever since 1984 when the Mac came out, and it's been, at first it was a losing battle, but I did work on Macs for a long time, but I'm so disillusioned with what Apple's done recently, I've switched to Linux now for my client. But importantly, I would always use Linux for a server system. I wouldn't run SQL Server on Windows Server. It's horrible. So design issues. So we're trying to trap data errors at the gate. And to be fair, the NAT system did trap a lot. A lot of people said afterwards they'd had flight plans rejected. So it wasn't that they weren't trying to do it, it's just that they missed that particular case of two waypoints having the same name. You think of all the things you can test and you're going to miss some. XML and JSON as input is fine, but don't store those strings in the database. Split them up into their separate fields, because then you can process those. Well, you can get the database to make sure that each field is the right data type. And you can do all kinds of other things with those individual fields so that it's much harder to do if you're trying to pick them out of XML or JSON strings. Don't repurpose, I mentioned that before. Don't deprecate things. If there's something in your system that's not right, but people are used to it, and you come up with a better one, make the change. Take the pain, do it now, refactor it, and change it. But when you've got two versions of something there, and one's deprecated, and they're both in use, that's horrid. And it creates inconsistency. Someone else mentioned this morning as well. Don't create flexibility that the users don't need. Sometimes this would be a really cool feature. Nobody cares. Don't put it in there, because it's just another thing that can go wrong. And store anonymized data separately rather than plonking the word anonymized in all over it. There's a page on my website about that, but about how you can do it a different way, which is much better. But we haven't got time to go into that. Tools. This is almost all about databases. I wrote it all down. I thought, it's all about databases. Well, I went through the phase with a couple of organizations when they fell in love with data lakes. For structured data, a relational database is the best thing we've got. And if someone knows something better, tell me, but it ain't a data lake. And use database constraints. They're not expensive. When I first started with databases, a constraint on a column was, something that would really impact performance. It's hard to measure it now. And that will stop wrong data getting into the database, even if it gets through the application validation. Reconciling, I mentioned. Profiling, I mentioned. Automatic data monitoring, I mentioned. So, that's it. And I left some time for questions. Oh, not much. A little bit. Okay. Yes. Well, it's tricky because, you know, with where we got the 0, 0 ones, obviously we'd remove that and calculate between the points outside. But for that one, it was really tricky. And as I said, it happened with the car insurance system where the two roads were close together and the speed limit on one was 30 miles an hour and the speed limit on the other was 70. And we really need to know which one the car's on. So we had access to the people who were doing the low-level software, taking the data from the boxes and then presenting it to us. And it took a big fight to convince them that they shouldn't fix things for us. You know, we really needed that thing about how accurate it was, like how many satellites it could see. And if it's wrong, don't try and fix it. Just tell us, and then we can deal with that in the application. I think without that information, the application really hasn't got a chance of fixing it. So it's important to kind of surface that a level up. Yeah. Oh, thank you. Yeah. Well, the aggregate functions in the database work, but it's very easy if your structure is quite complicated to miss something that go into the aggregation or to duplicate it. And what I would try to do, and what I've encouraged teams to do, is if we're doing some complicated query and we get an answer and it looks plausible, then find some other way of trying to calculate parts of it or all of it a completely different way and see if it matches. Because far too often, well, it certainly happens with Excel spreadsheets, where people work on it and tweak all kinds of things until they get an answer which is what they expect, what is plausible. But people do that with databases as well. And it's part of the discipline of the developers that even for trivial queries, you know, you should check to see that the results you get are as true, that you have the highest confidence in them that you can. And it's amazing how, especially if you're working on, well, most databases, sadly, you don't often find one where you can't simplify the structure or match it up better to what the business model actually is. But even with a clean model, when you get a complex business requirement, your query can get quite long. And it's really, really easy to make wrong assumptions and stuff. So the best way I know is to, well, pair programming is great because the other person might, why are you doing that? And also just finding a different way of doing it, see if you get the same results. Yeah.
So the situation where you're importing data and the deduplicating of that, do you have any tricks or anything for dealing with situations where it might be like an actual update before you adjust this change and stuff? How do you cope with that?
Yeah, well, I've worked on quite a few data warehouses, and you know they get refreshed every day with what comes in. But sometimes you want to keep history, and this could happen for other kinds of things where you're synchronizing two systems or doing a migration. So sometimes the source system will tell you the created date and the updated date of the thing, and you can then deal with those either by, if it's an update, changing it in the target system, or building a history, which is quite, you know, it's called slowly changing dimensions, which it's just a history table. And it's in a lot of source systems as well. You know, you have created on, updated on, and then you see the values that have changed. And that's usually quite useful in a data warehouse. With financial systems, you should never get updated records, although you often do. You know, when a value goes in wrong, like somebody, a new person typed in, expected when they typed in 10,000, that would be 10,000 pennies, and therefore would be recorded as £100, but in that system it wasn't. So it comes in as £10,000. So the correct thing, which they did do, was to put in a new record which has a correction or a journal entry which says, referring to this transaction, but here's a new transaction which is minus 9,900 pennies. Yeah, whatever it was. Anyway, so it gets it back to what it should be. But that means anyone auditing that can say, okay, this was wrong, but we fixed it, rather than losing that important information. Yeah.
We're out of time, but thanks very much, Mark.
Okay, thank you.
So everyone, hi everyone, thanks for coming. So yeah, talks data science and agility at Spring and Nature where I work. So yeah, my name is Charles Kubicek. So just a bit about me before we start. I've been a software engineer, that's my background, for about 20 years. During that time I spent 10 years in Agile, digital transformation work in companies like ThoughtWorks, Equal Experts. That's where I kind of like learned a lot of these things from a lot of the people there. And I kind of pivoted a few years ago into data, as they call it. So I think during a lot of these kind of like agile and transformational things, I kind of realized that data was like neglected, yet it was so important to kind of like improving users' experience in many ways. Spring and Nature, we have a lot of data, as you could imagine, a lot of data engineers, data scientists, and there's a lot of work to do, especially trying to work out like where our cloud bill actually got spent on. So for the talk then today, I'll talk a bit about challenges that we have with data, the idea of shift left, how that comes into it, concept of data as a product, and then talk about like how we can improve delivery possibly. So just a bit of scope to begin with. I guess there's three kind of like outputs you can get from data science possibly. One is an answer to a question there and then. One is a tool, like a dashboard. The other one is a model, like a machine learning model that you can deploy and use in various applications. So in this talk, I'll talk specifically about the last two, a tool or a model, some deliverable that's deployed into a production environment. So let's look at challenges then to begin with. So I see three challenges I'll talk about. One is a hidden raw data handoff. Next one is data inconsistency that comes in. And then last one is a production handoff. So the first challenge, hidden data handoff. So this is a pyramid that I got from O'Reilly. It's a data value pyramid. So it talks about how data scientists can create value. So it begins at the bottom with raw records, raw information. And then that's kind of aggregated into charts. Charts can then be linked and related into reports. Reports can then be used to make predictions, and ideally at the top, those predictions are used to drive actions and value. So that's all good. My experience though, these two things at the bottom, innocent looking things, collecting and cleaning, tend to be the most difficult, the most complex, the most time consuming. Once these things are all done, the rest of it, there's a lot of tools, a lot of like ways of working that can do those two, but really without those two, it becomes very problematic. So this word collecting is interesting. To me, collecting is like Easter Sunday with your basket, going in the garden, collecting nice little eggs that are going to be nice and tasty. The reality for me, though, when I've been doing this kind of work, is more like this. It's a dump, a data dump, that's literally what it's called. So it's an extract from a database, kind of as it is, and it's up to you to figure out what's in it. So there may be some useful stuff lurking in there that is helpful to you. There might be a lot of rubbish that doesn't make any sense, random identifiers. There might be some scary stuff in there, like personal information, sensitive information with no link to how it can be used or even where it came from. But it is a handoff, right? This is the beginning of a process. That's where some information starts and it's handed off to someone else to figure out. So one of the worst things about the dump is once you've got it, you've got to clean it. You've got to clean the rubbish, which is madness, but that's what it is. So in general, like these dumps can be useful for learning, experimentation. Like I said, there might be some useful stuff in there, but it's not really supposed to be used in production, right? That's like that's a bad idea. I much prefer the term connect. I think we should be connecting to data instead of collecting it, right? Because ultimately we want to build some live deliverable that needs a continuous feed of information. So second challenge that I've seen is data inconsistency. So let's talk about cleaning again for a moment. So what is cleaning exactly? So it's filtering data out that maybe doesn't look right, formatting it, so like dates, times, converting like currencies, deduplicating data that looks like it's being duplicated, removing outliers, or correcting things that look wrong. So all these are kind of like a matter of opinion. It's normally based on what someone thinks is right or thinks is a mistake. But the real trouble comes in this kind of situation here, where you have maybe a source system and two teams, maybe who are different parts of the business and maybe haven't even heard of each other, that are producing a model and reporting on the same information. Now, because they're unaware of each other, they use different assumptions while they're doing the cleaning, represented by the different colors there. And then that model or whatever it is goes into some dashboard, and the numbers are slightly different. Now, depending on who's looking at the dashboards or who's seen both of them and the kind of decisions they want to make, this could be quite a big problem. Not just in terms of they can't make the decision they wanted to make, but they don't trust the data that they're seeing. They don't trust that the teams have done the right thing. They may not even trust the source system anymore. That's a problem. One of the things I might do is just ignore it, not make the decision. Worst case is create a third team to go and find the right answer. So the third problem is a production handle. So a while ago when I was trying to figure out this whole data science and delivery thing, I asked someone, I said, what is, how do data science models get delivered into production, how does it work? And this is what they said. The data science process is like scientists creating a vaccine in a lab. They hand off to manufacturing, scale up and deliver. And this was a picture of me after I heard that. So this kind of made me upset in a few ways. First one, it kind of assumes software works like hardware. It's like we have the, and I can imagine real scientists in a lab, right, working with real chemicals, real real people at the end of the day. They're kind of like vaccines, go into real people, real manufacturing. It's based around hardware and those constraints that come with it. But yeah, I mean, in Agile, we're constantly rethinking our processes, right? Because we're working software. It's soft, that's the point. We can change how we do things. And the sort of message that I got from there was we just take all the constraints from hardware into the data science process and copy them, which is a bit of a shame. The other issue that I had with this is that scaling machine learning models is as hard as developing them in the first place. So there's a nice diagram which captures this quite well. So this is in a paper from a while ago now, a Google paper in 2015 called Hidden Technical Debt in Machine Learning Systems. You can see in the middle here, this is the machine learning code, and the rest of it is all other things that have to happen to run machine learning system in production successfully and continuously. So all these things have to happen for each model. So it's not like we can simply just create this model and hand it over the wall. The data scientists still need to be involved in some of these things here. And in the meantime, a lot of the cloud companies and other companies have tried to automate as much of this as possible, build services to do them, which is great. But some of these things like collection, verification, still going to have to be done internally, because those systems that have generated the data that are kind of exporting them, their internal systems, and that work is never going to go away. So just to summarize a handoff, it happens too soon in the development phase. There's not enough context in handoff, and there's lots of data work still to be done once the model has been developed in that environment. So yeah, just a summary of the challenges. The hidden raw data handoff, the data inconsistency, and production handoff. So I like to overthink things a lot. So I reflected on this problem of the vaccine, and I thought, how can I explain this? What does a software vaccine look like then? Well, it's kind of like protection against viruses, and we do have software viruses, so maybe there is some thinking we could do here, could be done. So as you probably all know by now, if you kind of wear a hoodie, you put the hood up, walk into a dark room, sit down your laptop, this person here, you become a hacker, right? And you're writing viruses, and you're trying to attack the companies we work for. And in the early days, like the way that we defended against this was, once our services went into production, you put firewalls around them. But the problem is there's loads of like bugs and things that could be hacked in the services that we deploy. So one of the ways that we helped kind of get around that, or assisted with it, was this idea of DevSecOps, or AppSec, I think it's called now, I'm not sure. But the idea is to do the security analysis at different phases of the development cycle. So at each phase, we're thinking about security in some way. While we're developing, I'd be thinking about SQL injection attacks. During testing phase, there's automated tests we can put in. So this concept is called shift left, and works quite well. So yeah, I mean, maybe shift left is our software vaccine at the end of the day, right? We're kind of like protecting against risks by implementing a process or tools early as possible in the development chain. So what does this mean for us with data? Let's get back to this. What does shift left look like? So to use our dump and clean that we were talking about before, what we've got is a producer and a consumer. And the producer is handing off information or data to the consumer. Maybe there's some automatic dump going on. And the cleaning is happening over here. So what if instead we shifted this left, and instead the producer, instead of just doing a dump, did a bit more of a mindful export and then transform. So the consumer had a bit less to do. They still might do some cleaning, but actually the producer, with a bit more information of what a consumer and other consumers need from their data, could also do some of the cleaning and do it consistently. Also, the producer could then even go to the left and do some of the cleaning up front as data is being acquired. Like if you were here for the last talk, that's what it was talking about. How can we make sure that user interfaces give us the best chance of acquiring good data in the first place? So this kind of concept is kind of part of data as a product, which I'll talk about next. Has anyone here heard of this idea of data as a product and data mesh? A few people have, good. Has anyone like used it in an organization? Yeah, good, excellent, okay. So I'll talk now a bit about how we've been using this at Spring Nature. So data as a product is standalone data that is designed for consumers, and this is the big flip here. Instead of just having a one-off database dump, which is like zero effort, this time we're putting more effort and trying to understand what people downstream in the supply chain are actually doing with our data. So some of the attributes of data products are that they're discoverable. You can find them. You don't have to hunt around and guess which teams might have the data you want. They're well described, so it's clear what you should be using and what you can't use. They're interoperable. That means they can be used easily with other data products. We'll get onto that a bit later, but what it involves is a shared place where all the data goes, kind of like a warehouse. And things like identifiers that can link between data sets. It can join them easily. They are secure as well, so it means that any personal information in there can't just be made available to anyone. If you want access to it, you need to go through an access control system. And ideally, with those things and a few others, they're trustworthy. People can trust the information if it came out of a data product. If they know a report or something was made from a data product, then there's a level of trust there. So data as a product is data which is extracted out of some source system and then published on an analytical data platform. So this is kind of another way of saying something like BigQuery or Redshift on Amazon, or something like Snowflake, a kind of modern data warehouse type system. But one of the key aspects here is that it's owned appropriately. What I mean by that is that the team which acquired the data or own the system that acquired the data or generated the data, they export the data onto the data platform and it remains theirs. It's still their responsibility. Even though it's gone onto a different system, it's almost like an extension of their ownership remit. That's a really important part. It's not a throw over the wall style situation. There are standards involved, so how it's published, there's standards around the system that it goes onto, and also which sorts of identifiers are used, and also standards around metadata. So as data is published, there's metadata around the entire data product, individual fields in there, just basic stuff around which team owns it, how to get in touch with them, how you get access to it, where the source code is, things like that. And all those kinds of things help with trust because it's giving some, trust indicators, as I call them, to the data. There are data contracts. So as data is published, there's a conversation with consumers and there's an agreement reached about how the data, when it will be published, for example. Certain aspects of data quality can go in there. How the schema is evolved. These are kind of like agreed up front so everybody knows, the producer and consumers know exactly how things are going to be updated. Quality is observed. So this is like a system which is continually checking to make sure that constraints in the data contracts are met, and if they're not, then it raises an issue that can be fixed. So it's just checking to make sure data has been delivered and that fields are in the right format. This is quite a new thing. I think it's quite a long way to go because it's not clear sometimes if there's a problem with some data, exactly like what the consumer should do. If there's a fault, do they not ingest data? Is there a batch which they just leave, or do they just take part of the batch? It's kind of up to the consumer, and that's a bit of a tricky one. Also, the usage is monitored, so all the queries that are being run against data products and who's been running them are saved, and we'll get on to what we can do with that information later. So in data products, the generating team, I put a star there because it may not be the team, we'll get to that later as well. They transform the data for use. Why then? Well, it's because they acquired the data. They understand, like how it was acquired and what constraints were there. They understand all the nuances, so all those edge cases. There might be a reason for them. That's probably worth knowing. Things like duplications, maybe they're for a reason. They have existing processes already, but it's probably someone already using the data, maybe. So it's probably quite simple to kind of like fit something new into it. And they care, or they should care, how data is used elsewhere in the organization. If someone's like has an idea, they can probably talk it through with them to see if it's like possible or even legal with the data. So just an example to go into some details about how these data products actually work a bit under the covers. So imagine this example. We have two source systems. They're both exporting their data as a product, as represented by the hexagons. Then on the right here, we have a predictive model that's being used. Say it's generating recommendations for this user-facing application. And then the user-facing system is also using some data from this product as well. So first of all, let's look at the ownership boundaries. So there's three ownership boundaries here. As I mentioned, there's the source system. Data product one is owned by the same team or the same group that owns the source system. It stays their responsibility. Same with the second one. And on the right, we have consumers who are consuming those two data products and then using them for their work. So let's kind of go down inside this data product and see what it is. So we have this kind of data pipeline, as it's called, going from left to right. So this first step here, going from source system one into landing raw, this is almost like the raw export that I talked before, the dump. It goes into there. However, it stays private to this pipeline. Remember, the pipeline is owned by the same team or the same group that owns the source system. It's still their thing. So it's fine for them to dump their sensitive data in there because no one else is going to see it. From landing raw, it goes on to staging, and staging is probably like the canonical complete view of the data product. So in between raw and staging is where all the transformation happens. Now, ideally, if we're going to be creating a metric that people care about, we want to have some standard which defines how that metric is calculated. So in the source system, we're taking snapshots over time, or maybe it's a change data capture, a continuous feed of information, but we're taking raw data in, and we're trying to create this kind of like historical view of what's happened in this system. And how that's calculated should be standardized, so everybody knows this standard means this, and that can be used in the calculation, And it should be totally transparent. The source code of how that happens should be open. Open to the company, I mean, not open. And then on the right here, we have various views. So these are kind of like views of the data product that have been designed for different consumers. So one consumer is going into some other live system, so we might transform the data or aggregate it in a way which actually looks quite different for what that application needs. That's what we've ended up doing. And then some of it goes out back into the like the warehouse style system, ready for other people to use. So this kind of term in the data mesh terminology is called an output port. So this is kind of like the kind of public-facing part, and there's quite a few kind of things that are attached to this. I'll talk about them now. So first thing is a data contract, like I mentioned before. There's a link out to what people can expect who are using it. There's usage that is continuously measured about who's using it and what they're using it for. There's metadata, which is published through into a data catalog. And then finally, secure access. So access is granted on the output ports. So from these things here, we can also do observability. So the observability system can be measuring data quality based on rules that are defined in a data contract. And those like rules and how they've been broken and then fixed can be stored in the catalog. Again, those help us like understand if we can trust the data or not, because we can see the types of issues that have happened and how quickly they've been able to get fixed as well. Data issues happen all the time. I don't think that's a bad thing. It's more about how the team's able to respond and fix them, which is important. And yeah, observability, yeah, that all goes into the data catalog. And the data catalog is like a tool open to everyone in the organization who can go on and they can search for it. So they can browse by entity or by department or something like that. And they can find what data products already exist. They can find who's using them, looking at the usage. They can define what other things like dashboards are using the data product as well. So ideally, you know, a lot of what's already been happening in the organization is open to people, and that's helpful, especially in organizations like ours that are very large and quite siloed. So then, what we've got at the end of all this is not a data dump, but more like data treasure. We've been able to kind of like flip this from something which was like potentially like reducing value into something which is more valuable. So this is great. It's not without its challenges though. I'll talk about some of these next. So incentives. Actually, sorry, I'll just pause for a drink. So you could imagine walking up to a project manager or a product owner and asking them, while you're busy building your service, could you also export your data as a product and do all these things? So responses might vary, depending on what you get there. And I think, yeah, it's quite tricky. And I think the reason is because talking about data products is different to talking about like an actual software product that you deliver to your users, because data is very abstract. It's hard for non-technical people to understand exactly what it is, and from that, how it produces value. So one of the things I think is important is to take a leaf out of like data science and data analysts and to look at storytelling with data. So we need to craft like our own narrative with real data to continually demonstrate to people why this is a valuable idea and what we get from it. So one of the things we started doing recently is to look at all that usage data that we started collecting. It's called lineage data, and then putting it into something useful. This isn't it, by the way. This is just a demonstration of what our data lineage graph looks like. As you can see, it's a mess. It's quite chaotic. But in here, there's some interesting things we can already start to see. So I don't know if you can make it out, but some of these nodes are actually squares, and they represent data products, or those output ports, and the circles are intermediary steps. So we can already see that some of them, like that red one there, has a lot of kind of data coming in. This green one here has data going out. So there's something interesting there that's happening, right? There's a story to tell around why so many people are using that thing in particular. The different colors represent different cloud projects, which roughly relate to things like teams or even whole departments. And that's also something interesting to tell as well. If we zoom in on this bit here, we can see that coming from the green bit there, there's actually a lot of different projects or, teams or departments using that data. So that represents data that's moved across silos in the organization. And that's valuable. That's something people want to hear about. We've been able to kind of like do that integration, which has normally been quite problematic. So yeah, this is good. So in terms of teams, what we've seen doing data as a product for a few years now, there's roughly 3 types of teams that we've seen evolve. The first one are existing product teams that start delivering their data as a product. For them, it's almost a natural thing to do. So they have a product, they have an API, and data as a product is another kind of like interface that they kind of deliver to. So it's fairly natural for them. They're kind of natural owners of the data because they typically collected it as well. I guess one of the challenges there, though, is they may not have a data scientist on the team. So a data scientist or someone else will kind of pick the data up afterwards. That's fine. It just means that the feedback loop is maybe a bit more convoluted. The other thing we've seen is a whole team set up to deliver data as a product. So this is important for like key data in our organization because it's if there's complexities around, but we have to get it right, it needs a team almost to be looking at it all the time and to work with all the other teams around the organization for their use cases as well. So you have a whole team of data engineers. That's great because in that team, we can also build it to include data scientists, data analysts, and then we have almost like a cross-discipline data team that can be producing the data, but also using it themselves to build like those deliverables that I talked about. And finally, there is domain data teams. So this is like a domain in an organization made up of multiple teams or a department, you might call it. So they are like delivering data as a product on behalf of the product teams. So this is just what we've seen where we just haven't been able to get enough people to kind of like have like more data engineers. It means that there's not a closer link as to how the data was acquired, but there's still, we found a good enough link. And this is actually a good enough way of doing it, actually. Yes, so just a word of warning on this data as a product idea. This is a survey from the company DBT. So they asked people about moving towards this like decentralized architecture where we're pushing all the data processing out to the side. And it turns out that this is quite common for company size. The company size on the bottom here. So large companies are doing this already or looking at doing it, where small companies haven't got any interest. And that kind of, I think, is about right, I think. So one thing there to look out for. So just a summary with data as a product then. So data as a product can be used for reliable data connectivity. So it solves that collecting problem that we had earlier. Teams close to the source transform the data, and that goes towards solving our clean problem. And data transparency increases trust in data and with it, its value. So we don't have that horrible situation where someone's asking for, another source of truth. It like by doing this, we can maximize what we have because people trust it. Okay, I'm going faster than I thought I was going to. So I have to slow down. Okay, so talk about delivery now. So in data science world, roughly speaking, I guess there's 3 different things we could deliver or that people talk about as deliverables. One is notebooks, one is machine learning models that we've kind of learned and serialized, and one is like machine learning models as APIs. So off the bat, I don't think a notebook is deliverable. I think they're very good for discovery and examples, sharing information, even whole like reports. You can build them in a notebook and it's great because people can get into the weeds and see how things are done. But you can also misorder execution of cells and it can get messy quickly. So yeah, I don't think so. I think for models, it needs to be kind of like deployed as part of some automatic reproducible process. Again, that can be kind of trusted and verified. So yes, for deploying machine learning models, the industry has broadly come up with this idea of MLOps. So I borrowed this from this website, mlops.org, which is pretty good for talking about it. So it gives 3 main parts to it: the design of machine learning model development, and then operations at the end. So design is like requirements, use cases, and an availability check. I'm not sure if a check is enough, but fine. Model development, which is data engineering, model engineering, testing, validation. Doesn't say anything about data science there, but I mean, it's in there, I suppose, with the model engineering. And then operations, which is deployment, pipelines, and then monitoring triggering. So I know they mentioned data availability check, but I think data needs to be in here as something which is part of the process. And on the other side, operations needs to be, after the operations, there needs to be some integration, because you don't just want to deploy the model on its own, it's going to be used in something else as well. So I think that last one is a bit of a challenging handoff, actually, because if we're going to integrate with existing services that are backing our apps, we're probably running it already in some microservice platform or something similar. So which operations environment does it go into? The microservice one, or is there something else? We have two environments. And also the other thing is, like, there's unpredictable costs here, because some of these machine learning models tend to be resource hungry, very resource hungry actually, in terms of memory and CPU, because they're doing inference at request time. However, I don't think this is the only option. So one thing we do quite a lot of at Spring Nature is build these like data APIs. So what I mean by a data API is that it's some API which, you know, is just used for returning data. It's not transactional. We're not writing to it. It's just ingesting data from somewhere and exposing it as an API for people to use. So one of the principles that we use when building these services is that we should minimize the amount of like compute work done at request time and move everything again back left to the ingestion time. So when data comes in, we do all the processing we need to do. We understand what our users want from the API, and we're literally transforming the data almost to the point where the output is what the user is going to be getting when they request the API. So there's almost nothing to do at request time. They're just pulling data out almost. We might have to change the format a bit to match if it's REST or something else. The same with search results as well. So from that, what it means is we get an API that's very fast. It's very simple because there's not many moving parts. We've reduced the compute at runtime because we've moved it all to the ingestion time. So, and also because of that, the failures are handled in advance, so we get quite a resilient service. So taking these principles and moving into our machine learning model, what is it that we can pre-compute? What can we move further up the MLOps chain? Well, if we think about it, this is what the kind of like workflow looks like, very simply at least. You know, we have our data, we train a model, we test the model, and then the model gets deployed in production, and this green thing here is our production environment. But what if we kind of change this again a little bit? What if instead of deploying the model, we apply the model to some data that we bring in, and we deploy data instead of the model? So imagine then, if we are trying to build a model for recommending something to our users. So for each user, we want to build some recommendations. So that's a finite set. We know who our users are. So when we're building our model, we can choose an algorithm which maybe takes into account what all of our users have done. And then we will build that model, and then we can apply the model to each user offline. Now, depending on how you do it, this could be done without using much CPU time. And as a result, the output of that is a set of recommendations for each user that is active on our website. And it's that we deploy. Now, we can run this once an hour, so it won't be like live recommendations, but actually, I'm not sure every website needs live recommendations. I'm sure we can kind of live with an hour's delay. One of the problems there, though, of course, is that they'll see the same recommendations all the time, but we can choose like 10 recommendations per user and choose 3 at random to show them a different list. There are ways of getting around this expensive request time compute for machine learning models, I think. So in summary, not every problem needs real-time machine learning, I don't think. I think we can kind of like move some of that work offline. We can move like compute up to the left if possible. I think that's doable. We should keep like user interactions as simple as possible. I mean, I understand this isn't going to work for real-time things like LLM chatbots, but I'm not sure how applicable LLM chatbots are to that many problems. Okay, so I finished a bit early actually, I hope you don't mind, but we can ask more questions. So here's some takeaways just from what I've talked about from this. So yeah, we should treat our data as a product. We should shift data responsibilities to the most effective point in the data supply chain, like the cleaning of the data. We should use standards and transparency to increase data value. We do that by increasing trust in what's happening. We should calculate key metrics once, close to the source. We should reduce compute done at API request time. And we should ideally treat the delivery process like science experiments. We can try things, we can change things. We shouldn't be limited to like what has come from science. So that is it. Thank you for listening. Please give me some feedback there, that would be great. Thank you.
10 minutes for questions.
Doors.
Yeah, go on.
In this affair, laser.
Yeah.
That it's products.
Yeah. Yeah.
But you said that saying to the planet. What did you say? They did their next ones. Like evolving.
Yeah. It's a bit of a tricky one, I think, putting more and more work onto that team. Yeah, that's when it goes down to the team size, ideally. I think then it's about saying that it is best to process data sort of close to that to source. So the team should be taking on some of that work, I would say. The team doesn't always want to. That's fine. That does happen as well. But the thing is, if they don't, then you get the data, you get that problem again, where the data is being processed in different places. And that is real in our organization, right? That does happen. And so that is the solution to it, is to move the work close to the source system. But yeah, I mean, then it's a question of like data engineering capacity. Then it's like, well, if you want to do that, then you've got to hire the people, and then that's a different problem. Someone else had their hand up, I didn't quite see. Yes?
Still wait. Yeah.
Yes, yeah. Right, well, it's not that easy. So I mean, the way that we've done it is my vision for this right early on was that we should make all data open and everyone can see it. And when I actually got close to reality, it's like, oh, hang on a minute, we can't do that. So first of all, we have to make sure that ideally humans don't see PII data. That's kind of like where I want to get to, and it's only like machines and automated processes that can see that information and then send it on. I think what's tricky are things like deletions. I think, like deleting sort of data over time. It's quite complex for us because we maintain a scientific record, so we do actually have to keep some data. But yeah, I mean, that's part of the kind of data life cycle, is that we have to go in and remove some parts of data, especially if if time has come or if someone's asked to remove it. But this whole kind of idea is supposed to make it a bit easier to do that, because we should be able to know through the catalog where PII data is if it asked to be removed. Yes, at the back.
Only do like this, but and the fact that it can be if
Yeah, so data literacy is quite a challenging one. I think it's something which we have to kind of try and introduce organization-wide. But I think that's where the data contract comes into it. I think what we do at the moment is when we can use our lineage graph, like I showed before, to understand like hotspots of data. I mean, we can talk to the team who's involved and like find out what they're up to. That's kind of like so useful. And then that's where we can introduce them to the idea of like ownership of data and what the responsibilities are. And it's super interesting because for some teams it's very natural to them. They're like, oh great, I'm just glad you gave me the framework. And other teams are like bewildered, like, oh, we didn't know we had this responsibility. And so that's when we can kind of like introduce like the sort of coaching of it. But yeah, data ownership is a hard thing actually, especially for vendor products like Salesforce, things like that. People don't naturally think of the data inside it; they just see the processes. So yeah, it's different depending on the source system and the department. Yes.
Is the data
seems like it did, but still at good or more than or let's say for.
So in some cases when we started out, we just knew that some data was going to be valuable. And so it was like, right, we need to get some data engineers and we just need to do this. Yeah, what has been happening now is that, yeah, it's been kind of surprising. We've seen like teams spring up who want to use data and all of a sudden find it really hard because like the data quality is quite poor. And we've been caught off guard as like an organization. So yeah, then we have to try and figure out, well, we have, we actually need to be hiring people closer to the source system who can kind of like figure out how to get standards into it to sort of improve it. So it's quite unpredictable and it's a bit of a mishmash. What we just try and do is mediate between the different kind of like producers and consumers, which sometimes we can do and other times we just can't. We just don't have the people, but we do our best. Yeah.
With the get structure, they cut. Because the well, if you give that a very simple secret team that the way so it's they
it was, yeah, I mean, that's like the chicken and egg problem, which comes up all the time in data. As usual, we started with a spreadsheet, and we just kind of like got down between two teams, like what do you need from each other? And just getting it to one spreadsheet was hard, actually, to get people to come to the same place. So for data contracts, the infrastructure is still spreadsheets, actually. But we are using, we just recently started using some infrastructure to do the data quality testing. And that's because we realized that we're at a point now where we could scale this up. We have like 40 or so data products, and we think, oh, it's worth doing this now. And we're still trying that out. There's one more question? Yes.
Oh, check that date. No.
So in terms of technology, I mean, we're kind of like constrained by our kind of cloud, which is, mostly Google Cloud. And so we basically built on that. And we're such a small team, we're just kind of using what Google has given us and then introducing standards and explaining to people how to use it. So we get, regardless of what technology is used in the source systems, we ask everyone to export onto Google BigQuery, in most cases at least. And it's like, from there they can build their processes using things like DBT, for example. But really, I'm not precious on technology choice. As long as the data has been exported, it's got the metadata, it's to the standards, that's the important bit. Yes?
So one criticism I've heard of data mentioned in the products is that because the focus is on the individual data source, both from the reporting like you mentioned, that eventually it's leaving gap with like when you're actually using the data, is that you use it across all those things, so that the it's fairly.
Yes, it is something we've experienced. We put a lot of effort in getting the data shared, and we realized we neglected how the data is consumed. So yeah, we suddenly realized that we need to put a lot more effort into like data architecture, I suppose you could call it, so to stop like the spread of too many things. And that's something we're dealing with at the moment, because we sort of, yeah, it's a really hard problem because a lot of people want to get involved. You've got architects, enterprise architects want to get involved. People want to come with models, things like that, and it's all interesting, but it's like, right, we need to try and simplify this as much as possible. Ideas when people talk about product, user, it's kind of obvious like what set of data products to use, or maybe what kind of like aggregates people are using. That's, yeah, it gets messy actually quite quickly. Yeah. Ah, right. That's a good question. Yeah, so we tried quite a few data catalogs, but I mean, we wanted to get a nice curated set of data products people could trust, but a lot of them just seemed to be throw it all in and we'll make sense of it, and they were horrible. So what we ended up doing was building quite a simple web application, which is almost like a sort of integration system. So it's quite simple, but it's going to BigQuery, going to other systems, pulling out information. And we just spent a lot of time talking to users around the company, so different types of data people, to figure out what they wanted to see from it, which was interesting because what they wanted was different to what the products in the market were offering. Because you found the same thing. Yeah, so that's where we just opted, where I work with a few software engineers, and really good ones who, actually built a data catalog. And yeah, as it gets bigger, it does need more curating. We need to introduce more concepts into it, but it's all about presenting something that people can trust and want to use. But yeah, it's been great. I mean, people want to put their data in the catalog now, which is great. Thank you.
Okay, hello everybody. My name is Claire Sudbury and I'm going to be talking about continuous integration. I will show this QR code again at the end, but you can use this QR code to give feedback on the talk, and I'm always interested in hearing feedback. I pretty much never do exactly the same talk twice. I'm always looking for ways to improve things. So feedback is very useful in that process. You can also download these slides. I know the conference is also going to make them available, so I've actually been given a stick to put them on when I'm done. So you'll be able to get them via Agile on the Beach, but you can also use that QR code, which I will also show at the end. Okay, so what is continuous integration? You can tell by the title that I'm going to suggest that the current understanding of continuous integration might not match the original definition. So let's start with what I think continuous integration is, and I'm going to ask you all to stand up. Get the blood flowing after your night out on the beach last night. Okay, stay standing if you do continuous integration where you work. Okay, good few people. Stay standing if everyone on your team commits and pushes to a shared main source code branch at least daily. Everyone. Okay. Stay standing if every one of those commits causes an automated build and test. Okay. And stay standing if when the build fails, it's usually back to green within 10 minutes. Okay, well done. You can sit down. So that was Jez Humble's continuous integration test. The joke is that there is continuous integration certification available. If every developer commits at least daily to the shared mainline, if every commit triggers an automated build and test, and if build and test fails, it's repaired within 10 minutes, then that's continuous integration. And that's what I mean by continuous integration. It's not what most people mean by continuous integration, and it's not what most of the products out there mean by continuous integration. So products that have CI in their title, they don't necessarily mean that. But that is what Kent Beck meant when he first defined the term in 1999 in Extreme Programming Explained. He says, no code sits unintegrated for more than a couple of hours. At the end of every development episode, the code is integrated with the latest release. So that doesn't count as if you have it sitting on a branch. That's not integrated with the latest release. So, and this is who I meant by they when I said that's not what they meant. So it was Kent Beck and his cohorts at the time who first defined the term continuous integration. And while we're here, I want to draw a distinction between continuous integration and continuous delivery. Continuous delivery is where not only is the code being continuously integrated with the rest of the code, but it is actually being deployed in a way that means it can be used by users continuously several times a day. It is possible to have continuous integration without having continuous delivery. As far as I'm concerned, continuous integration facilitates continuous delivery. So I think continuous delivery is also a good thing. But the topic of this talk is continuous integration. So I just want to draw that distinction. Some people also talk about continuous deployment. Some people draw a distinction between continuous delivery and continuous deployment, but that's quite niche. Most people don't. I don't, to be honest. You can if you like. But I'm talking about continuous integration. So you can also call my definition of continuous integration trunk-based development. And that's what I tend to call it. Because of semantic diffusion, because the term continuous integration has started to mean different things to different people, I find trunk-based development to be a more descriptive term. So what I mean by trunk-based development is that all code is being integrated, is being pushed to the main line, which used to be called the trunk in some older version control systems. Actually, most people don't call it the trunk anymore, but when I say trunk, I mean the main line, which also sometimes used to be called the master branch. What I'm saying is that all code is going to the main branch. It's not sitting in feature branches. And I will tend to use that term. Martin Fowler doesn't like it. He prefers continuous integration. He thinks it's disrespectful to Kent Beck and the people who originally came up with it to try and use a different term. But because the definition of CI is a bit muddy, I prefer TBD, trunk-based development. So my claim is that if you use trunk-based development, you will be better, faster, and happier. Better quality code, faster delivery, and happier developers. Happier because better and faster means more satisfaction, but also because trunk-based development facilitates and necessitates better communication and closer collaboration. And that, I believe, tends to lead to a better development experience. But I'm not the boss of you. You don't have to do what I say. I'm not here to wield a big hammer and hit you all on the head if you don't do continuous integration. I'm not here to judge you. A lot of people think that people who like to talk about trunk-based development are just really annoying people who are just going to keep telling you off all the time. There are many reasons why people don't do what I would call continuous integration. I'm not here to have a go at you. I'm just here to extol the benefits and the virtues of continuous integration and maybe persuade you that it might be something that you want to think about, or if you think you're already doing it, to improve the way that you're doing it, to get closer to the original definition. And if you are already, if you're one of the people who is still standing at the end, fantastic. Hopefully what I can do is make you feel great, but also give you some arguments that you can take back to colleagues who might be less convinced or who might still need a little bit of a help. So my argument is that if you're using feature branches or any form of branches, what they can do is slow you down and increase risk. And I'm going to make this argument by telling you a story. I am also a published novelist. And when I was writing my novels, I read this book, Story by Robert McKee, which is a great book. Highly recommend it to anybody who is not only writing fiction in the printed form, but also people who are playwrights or screenwriters. In fact, he wrote the book for screenwriters. He himself was a screenwriter. But what he talks about is how to structure a story in such a way that you keep your audience engaged. And I love to tell stories. I find storytelling is a useful way of delivering information. And one of the things that he talks about is that every small chunk of your story, so if it's a film, every scene, if it's a book, every chapter or even subchapter, should have a start state, a turning point, and a new state at the end. And that's how you keep your audience engaged. Things keep changing. You're pulling them forward with you, and things are happening. So it's not just random things are happening, but things are happening to change things. So things change as a result of the things that happen in your stories. And I'm going to use that structure very broadly to tell you a story where on each slide there will be a start state, a turning point, and an end state. And what I'm going to do is I'm going to tell you a fictional story of a development team on their journey towards continuous integration or trunk-based development. So my fictional team is very new. They're working on a new product. They haven't been going for long, but up until, for a few weeks maybe, but up until now, they've been using branches. And what they've been finding is that every time somebody finishes work on a branch and then tries to merge it back into the main line, there's merge hell. it causes lots of problems. It slows everything down. And they think they've managed to merge it successfully, and then it turns out they've obliterated something that somebody else did. Things are now broken. Things aren't working. It's causing them pain. One of them has read an article about trunk-based development, might even have been the one I wrote for O'Reilly, and they come back to the team all excited and say, we should do trunk-based development. We're all going to do trunk-based development from now on. No more branches. Hooray. Okay. But somebody else comes in and says, no, you can't, because we wouldn't be compliant if we did that. There are various hoops that we have to jump through in order to be compliant with standards such as HIPAA or SOC 2 or ISO 27001. And so we need branches because we need pull requests and we need code reviews, and we need to be able to audit where this code is coming from rather than it all just arriving back in the main branch willy-nilly. So they go back to branches. And now they have branches and they have pull requests and they have code reviews. And this is leading to a lack of trust in the team, because now the default is every time you finish your work, you have to have it overseen by somebody else. And the people who are overseeing it feel like they're not doing their job right if they don't find fault. And now particularly newer developers are really paranoid, they're really worried. And because that builds and leads to more of a lack of trust, that leads to more pull requests and more nitpicking and even more lack of trust. So now that we've got even more pull requests and even less trust, we're moving really slowly because everybody's worried. Nobody wants to merge their code back into the main line because they know that'll be a pull request and a code review, and that leads to being told off constantly, and nobody trusts each other's code. So this is where I get on my high horse a bit about pull requests and code reviews. I used to work for ThoughtWorks, and I still hang out on a couple of Slack groups where there are a bunch of people who do or did work for ThoughtWorks hang out. And I asked them, what do you people think of code reviews and pull requests? And I got a deluge of responses, negative responses, people who don't like them. So Dan Abel said, PR feedback is the last point in the dev cycle where feedback is useful and often the most wasteful. Keith Morris, who is, I don't know if he's in the room because I can't see you all that well, but he's been at the conference this week. This is from his book. He says, using pull requests for code changes by your own team members is like having your family members go through an airport security checkpoint to enter your home. It's a costly solution to a different problem. So the origin of pull requests comes from open source. And if you're working on an open source project, then you're inviting contributions from people you know nothing about. So you do need a gateway. You need some way of checking the code before you integrate it with your code base. And that's where pull requests are really useful. But in a trusted team of developers who know each other and are working together closely, pull requests can reduce trust and cause problems. Dragan Stepanovic, in a great talk that I saw him do at Newcrafts, I think it was last year, said that he did a really interesting piece of research. There is a link to his article about it on this slide and also in the links at the end. He says the bigger the pull request, the more likely it will suffer from the so-called looks good to me syndrome. So if the pull request is big, if it's been a really long-lived branch with lots of lines of code changed, it's more likely that people will just go, I don't know, seems all right. And reviewers have less incentive to build in the quality. But if the pull request is small, which is actually what I would argue for, I think the smaller the better if you're going to have pull requests. And I understand that people, for a lot of reasons, do have them. Then it's more likely that people, because there's only a few lines of code, so it's a lot easier to go, oh, I don't like that one, and actually find the time to look at it properly. And then we get back to what I was talking about before, that people feel like they have to do their job, so they have to find something wrong with it. And Dave Farley says that my experience across the board has been that regulators prefer these approaches, trunk-based development, continuous integration, once they come to understand them, because they provide a better quality experience all round. So this idea that you're not compliant if you don't have pull requests and code reviews is not actually true. If you look at the letter of all of those standards, they don't say you have to have pull requests. They talk about accountability, they talk about being able to audit, but they don't specifically say that you have to have pull requests. What Dave Farley does with the teams that he works with is he points to what the value you get from a good automated pipeline with good tests. And that's actually much more traceable and much easier to look at than pull requests, which are very organic, very manual, and very variable. Sorry, my mind has gone blank. I was going to say something else about that. But so what he says is that he works closely with auditors, he works closely with people, and he shows them that the benefit they're going to get from automated systems and persuades them that actually this is better for all the reasons that I'm going to go through, because your code is being integrated quickly, it's not sitting somewhere else for a long time, you've got less risk when you're merging, you actually get a better experience. Oh, and the other thing I was going to say is that all of those standards aren't saying that you are not allowed to have bugs in your code, because we all know that's impossible. And I'm not going to claim that a good continuous integration system means no bugs. I think it means fewer bugs. But there are always going to be bugs. There are always going to be issues. Compliance is not about removing bugs. It's about being able to fix them when they arise and being able to trace your processes back. Dave also says the more complex the compliance mechanisms around change, the lower the quality of the software. I believe that it is not possible to implement a genuinely compliant regulated system in the absence of continuous delivery, which you can't do without continuous integration. So there's this thing about complex compliance mechanisms. The more hoops people have to jump through in order to get their code into production, the more delays and the more risk, and the harder it is to verify quality. Okay, so people then say, whoa, hang on a minute, you're talking about code reviews and pull requests, but surely we need some mechanism to review our code. And yes, absolutely, it's a great idea to review your code. It's a great idea for as many eyes as possible to see your code. And a lot of the time, the compliance standards talk about how many eyes have seen code rather than how those eyes have seen it. And pair programming and mob programming, or as I like to call it, ensemble working, are very good ways of getting multiple eyes on the code. They're also great ways of doing code reviews. So rather than every single piece of work resulting in a pull request and a code review, which is quite bitty and necessitates a lot of context switching. So somebody who's working on something completely different has to come and get their head into what you're doing and make sense of it. And that's often quite hard for them. A better approach is to all together get together at regular intervals as a team and review recent changes and have a look at the current state of the code base and tell each other what you've been doing. And also the benefit of ensemble code reviews and ensemble work in general and pair programming in general is that you get to talk about what you're doing while you're doing it. So that thing that I think it was Dan Abel said about PRs being the most wasteful point to get feedback, because once you've finished working on a branch, you've already done the work. Which is another reason you get the looks good to me syndrome, because your colleague knows you've just spent 2 weeks, 4 weeks, however long, working on this feature, and they know that you've already finished it. So now for them to say, oh, actually, I think you should rip it all apart and start again, not helpful, not useful, not effective, not efficient, they're not likely to do it. Whereas if they're working with you as they go along and they spot that you're disappearing down a rabbit hole, or you spot that each other are disappearing down rabbit holes, then you can correct as you go, rather than waiting to the end. Okay, so back to our fictional team. There's been an explosion of PRs, a lack of trust, they're moving really slowly. And somebody remembers again that article about trunk-based development. They've also read Dave Farley's stuff about continuous compliance. And they've decided, nope, we're doing it. We're going to do trunk-based development. No more branches. Now, this is what I'm calling big bang trunk-based development, because they're just doing it suddenly with no preparation, no thought about how they're going to do it. They've just decided they're going to do it. So all of those branches are just going to be thrown away. Everything's going to go into the main line as soon as it's finished. But up until now, they haven't been writing brilliant unit tests. They don't have an automated test suite built into their pipeline. Their testing regime is entirely manual. So they can't deploy. So they've got all this code that's being integrated all the time into the mainline, but they can't deploy it because they have to test it. And that takes time. So they're not getting the benefit that they wanted from it. So the combination of big bang trunk-based development and manual tests means that they're now saying, well, we have to continuously deploy this stuff, so let's just get it out there. We won't test it. It'll be fine. So, of course, you know, it's problematic, whole system failure. Now everybody's blaming everybody. They're all miserable. Everything's going horribly wrong. This has not worked. And where there's blame, there's probably guilt and shame. And they work out that actually maybe they need a bit of help with all of this stuff. Now, this is a blatant plug. I happen to be a member of the Saman Technical Coaching Society, which was founded by Emily Bache. This is a fantastic book if you're interested in technical coaching. This is from the foreword of that, the introduction of that book. The foreword is actually by Ken Beck, who's the person was pretty much the they in the title of this talk. But Emily says, in order to be successful in modern development organizations, software developers need new skills. These skills are not easily learnt on a short training course or at a university. Practices like continuous integration and test-driven development, which I'm also going to argue is very useful if you're going to do continuous integration, require developers to change their minute-by-minute habits and ways of working. And having a technical coach, having somebody experienced, doesn't mean you have to hire me or one of my colleagues or somebody like me. Technical coaches can be internal to an organization. They can be trained from within. They can be part-time. But having experienced people who work with teams to help them develop and learn the practices they need in order to do effective continuous integration can make a huge difference, because you can't just do it. You're probably already thinking, well, how am I going to commit my code to the mainline when, you know, I haven't finished it yet? Well, actually, you have to code in a different way. And that is a skill that can be learned. So also, this is from Ken Beck, from the foreword for Emily's book. Software development is best seen as a learning process where running programs are the proof of learning rather than a factory or production process. Walking a new path together along with an experienced guide reduces the time spent not learning because of fear. And I've got a whole other talk about how fear impacts developers' ability to work effectively. So they've now got some help, and their technical coach has encouraged them to start pairing together and working together and highly collaboratively on the work that they're doing. So sometimes they're doing some pair programming, sometimes they're doing some mob or ensemble programming. And as part of this whole process, they're also learning how to be really good at test-driven development, refactoring, and automated testing. But the code that they originally wrote was written without using these techniques, and it's tightly coupled, so it's not very well factored. And this means that their builds are really slow because all of the code is connected to all of the other code. If they want to build one bit of the system, they have to build the whole system. And if your build is slow, then your tests are going to be slow because you can't run tests until you've built the code. But just the slow builds means that this is not going quickly, because ideally what we want is to be able to write code, integrate it with the rest of the code base, and get it out there as quickly as possible. Now, as I said before, I'm not necessarily talking about continuous delivery. So when I say out there, I just mean get it in the hands of all the other developers on the team, literally integrated with all of the other code in your code base so that everybody's using and working with the same code. You want that to happen as quickly as possible. That's not going to happen quickly if your builds are slow. So they minimize the dependencies, they refactor the code base, they make it more modular. There are lots of different ways of making code modular. This is not a talk about architecture, but the more modular it is, the less tightly coupled it is, the quicker your builds will be. So one of the interesting things that you'll notice about continuous integration is it doesn't really work without all of these other practices. And all of these other practices encourage you to write really good code and have a really good code base. So not only does continuous integration rely on really good software development techniques, it encourages them, it necessitates them, and it facilitates them. So, and this is from the book Accelerate, which you may know, which was written by Nicole Forsgren and a bunch of other people, and Jez Humble, in fact. And this was based on the results of the annual DORA reports, which, if you don't know of, they're worth looking up. And these are reports that are run across the whole industry. They're really, really deeply researched about what makes a difference to effective software development and delivery. They're almost, I mean, I would say, and having not read every single piece of research out there, so I can't say for sure, but, and a lot of other people say, the most rigorous research that there is out there about software delivery. And it's really difficult to do research into software delivery because there are so many variables. But they've tried really hard, and they say continuous integration requires relentless work to simplify systems architecture on an ongoing basis to ensure that this automation isn't prohibitively expensive to create and maintain. So it facilitates and necessitates constant review of your architecture and making sure that your code is well factored. This is the book that I was just talking about. There'll be a link on the linked slide at the end. So they've now minimized their dependencies. But this now means that their code is split into more modules, and that can slow your tests down because now you're running an awful lot of tests every time you need to run your tests. But that, again, doesn't have to be the case. So one of the things that continuous integration does rely on is fast tests because you want your code to get back into the main line quickly, and you want to make sure that it isn't going to break anything. So you want a good suite of tests running automatically, but you also want to make sure those tests are passing before you move on to your next piece of work. And if you have to wait ages, then that's really painful. So it also, again, necessitates and facilitates people speeding up their test suites. There are lots of different things you can do to speed up test suites. Again, that's not what this talk is about. You can run them in parallel, but you can also have incremental test software that only runs the tests that have been touched and impacted by the code that you've just written, rather than running the whole suite of tests every single time you push a change. So that's what I'm calling incremental tests. So now they've got a good, fast suite of incremental tests, and they've got into the rhythm, and they're so used to just pushing everything to the server constantly, and there's an automated suite of tests running on the server. They get out of the habit of running tests locally on their own machine before they push changes. So this means if the tests are failing, they don't find out until they've already pushed the code and it's on the server and it's failing on the server. So now the pipeline's broken, the build's failing. And so the build keeps being broken because people haven't been running tests locally. So the solution to that is people get into the habit of running tests locally, which is a really good habit, and also will necessitate and facilitate fast test suites because it's really painful if you have to run a slow suite of tests locally every time you want to push a change. So now they've started running tests locally, and they've agreed as a team that they're going to always keep the build green. So that was one of the things that was mentioned in the continuous integration certification test at the start. That's why it's important to keep your build green, because this has to be meaningful. You're not just pushing your code to the mainline, you're pushing and integrating it in a way that means it works and is now available to all of the other developers, which means that the build has to be green, the tests have to be passing. But some people, some maybe possibly quite often newer developers to the team who are a little bit nervous and are worried that this code that they're writing might not be good enough and that they might break the build. And so what they're doing is, instead of pushing frequently, they're keeping it, they're kind of hoarding it on their own machine. So they might, in the worst case, they might start work on Monday on their copy of the main branch, and then they don't push until Friday. Well, they may as well be working in a branch because they're not integrating with everybody else's version of the main branch. So now we're back to merge hell, because the longer you keep code on your own machine, the longer the period of time between you writing something and you merging it with the rest of the code base, the more likely it is that changes made by other people in the meantime will cause merge problems. So now what they do is they learn about MMMSS, which I'm going to explain, and they start pushing frequently. So hopefully the next slide, yes, the next slide is about MMMSS, which is quite hard to say. MMMSS stands for many more, much smaller steps. And this is one of Jeepor's inventions. And if you haven't come across, well, he didn't invent the concept of working in small steps, but he invented the phrase. If you haven't come across Jeepor, looking up, he's fantastic, wonderful, wonderful man with lots and lots of really interesting, useful things to say about software development. The idea of many more, much smaller steps is that everything you do gets broken down into really small steps. And every step goes from good to good. So you go from working code with tests passing to working code with test passing. And this is one of the fundamental skills that developers need to learn in order to do continuous integration. And it's not a skill they necessarily have. It's not a skill that's necessarily taught in university. It's not a skill that's necessarily being used daily by most developers. It's really common for people to work in such a way that they basically pull everything apart. It's like pulling the car engine apart and having all the pieces laid out on the floor, and then somebody says, I need to go to the shops. It's like, not going to be able to, because I've just pulled the engine apart. A lot of people work like that when they're writing software. They break everything. It's not building. The tests aren't running. Certainly can't integrate it back with the mainline, but you don't have to work like that. It is possible to work in tiny steps. The smaller, the better. And Jeepor's got loads to say about it. And again, I don't have time to go into it, but there are lots of reasons why the smaller the steps you work in, the more agile you are, the more flexible, the easier it is to actually get from A to B. If you're able to dot about rather than just going, I'm going to do that and it's going to take me 2 weeks. Okay, so now they've learned about MMMSS. Tricia says integrating small changes regularly into your code is usually less painful than a big merge at the end of a longer period of time. So now we're really doing what I would call continuous trunk-based development. So I'm calling it continuous because of what I said before about it's possible to do trunk-based development, but have somebody have their own local copy of the mainline sitting on their machine for 2 weeks. So that is technically trunk-based development, but it's not continuous. So I'm going to qualify it and call it continuous trunk-based development, where you're regularly merging your changes back into the remote copy of the main branch. Now, there still might be merge issues. It still might be that somebody made a change to a file in the last 2 hours or the last 10 minutes since you made a change, and their change has got to the main and your change gets there, and there's a merge problem. But if it's only 2 hours or 1 hour or half an hour or 10 minutes since the last time you pushed your changes, you can just throw what you did away and do it again. It's still fresh in your mind. And often it allows you to revisit what you've done. And quite often the second time round, you do it slightly better. So those minor merge issues are not anything to worry about because it's so easy to just throw it away and start again. Or maybe you can fix the issue. It's also a lot easier to fix the issue when the changes made were very small. So there's not a lot to worry about. So what about feature flags? I haven't mentioned yet a question that is quite likely to be in at least one person's head, which is, okay, so I'm making really small changes and the test is always passing and the code is always compiling, but I'm in the middle of writing a feature. It's not finished. I'm not ready for people to use it. What about that? And so the first answer to that question is actually surprisingly easy to write code that is not finished but does not break the code base and can be integrated. You can have classes sitting in your code base that aren't called or used by anything. They're in development, but they compile, their tests pass, the tests that have been written so far pass. And it's also possible with UI stuff. So it's possible to have UI stuff that gets turned on or off. It's possible to have UI stuff that there isn't a button yet that you click in order to see it, so only the people who are working on it can see it. And there are lots of ways of having things be integrated into a code base, but not yet being used by users. Then again, it's also a good idea to work in such tiny chunks that actually a really small piece of work can be used by users. But 10 minutes worth of work, 2 hours worth of work, probably not. So the default answer is feature flags, and I've just realized I put this slide up while I was talking, so you've already read what GPAW's got to say about it. Feature flags are useful, can be useful, but you have to be wary. So what some people do is they say, oh, it's fine, we'll just put everything behind feature flags. So really, it's kind of a branch through the back door. I'm saying, I'm working on this thing, and I've been working on it for the last month, but it's behind a feature flag, which means that it's not really integrated with the rest of the code base because it never gets called. The other developers are barely aware of it, and we've got 1 million of these things. And it's now really complicated because if you think about it, if you've got 100 feature flags, which can happen, and any one of them could be turned on or off, if you know anything about maths, the number of possible combinations of features is really, really big and not testable manually, and quite difficult to test it in an automated fashion as well. So you have to be really careful with feature flags. And what GPAW says is to get maximum bang for your TBD, as in trunk-based development, buck, all developers all the time should be running with 100% of the features turned on. A great deal of the benefit of continuous integration and trunk-based development both is in the extensive pre-testing workout the code gets as it's used by the rest of your team. So yes, feature flags at the front end are where they're most useful, that your testers can turn on and off, or that your product owner can turn on and off, and ultimately can be turned on and off in what's being released to your users. But keep it to a minimum, because it can explode and it can create as many problems as it solves. Okay, so conclusions. How are we doing for time? Okay, I've been going a long time. This was also one of my ex-colleagues, Eli. They said, we use branches when we don't mob or when we modify shared code. Nobody likes using branches, which in turn encourages us to mob more, so work in a more highly collaborative way. And I'm not the boss of you, but Dave says any form of branching runs counter in principle to the ideas of continuous integration. Don't branch, don't branch, don't branch. Just saying. Okay, so why does it make better? The benefits are that you get to work in small steps, you get fast feedback, you avoid merge hell, you reduce risk because it's much less likely that the code you deploy causes problems. Faster integration means fewer queues, collective ownership of the code, better quality code. There is tons of evidence in the DORA metrics and the state of DevOps and the Accelerate book, where they do every year recommend trunk-based development. And in fact, there you go. They say it's been shown for years to accelerate software delivery velocity. And here's a summary of the techniques. You can do some of these things without doing all of them. So you can start down on a journey towards continuous integration. And even if you never get there, you will likely improve your software development practices as a result. So automated incremental testing, minimize dependencies, speed up your tests, make sure the build is always green, build and test on your own machine before merging to a remote server, push frequently, use test-driven development, refactor frequently, throw things away, use many more much smaller steps, get help, build trust, collaborate, be patient, have interactive code reviews rather than individuals sitting on their own, looking at somebody else's code. And if you have all of that, then maybe you can avoid using feature branches and maybe even get rid of pull requests. Bunch of links, which you can get the slides and then you'll get all of the links. This is a podcast that I hosted. There are 27 episodes and relevant episodes are Emily Bates on refactoring, GPAW Hill on test-driven development, and Mary Williams on changing legacy systems. Each episode is me interviewing one of these fantastic people. And I also wrote this report for O'Reilly, What is Trunk-Based Development? And you will get all of that if you scan that QR code. This is who I am. I help teams to improve their software delivery. I do coaching, keynotes, workshops, bunch of links there. And this is the link that will give you these slides, which will also give you all of those links from the slides. Do we have time for questions? Because somebody said there was going to be a clock, but there you go. Does that mean I've got 6 minutes left? Yeah. Amazing. Fantastic. So I don't know why I know why it is. It's because I started sharing these slides when I arrived in the room, which was apparently 52 minutes ago. But I've still got 5 minutes and 44 seconds left. Fantastic. So, are there any questions? Loads of questions. Right, your hand went up first.
Probably got at least three, but I guess one question would be if historically you have someone working on feature plans to work with for Falmouth University, that's a bad thing in terms of this, but then you decide not to go ahead with that feature. It's quite easy to revert it out.
Mm-hmm.
So if you've had someone that's been working, doing commits to mainline for a month, and then this is just not going to work, pull it back out. I guess you can do one change then, that basically you need to make sure that you've just actually done one commit to roll it out. But you can't revert individual ones. Does it make harder to pull things out?
So the question is, if somebody's been working on a feature branch for a month, and they've now committed it at the end of that month, but then the decision is actually this is not working. We don't want this in the code base. We want to back it back out. If there was a feature branch, it's quite easy because it was just potentially one commit at the end of that feature, and you can just revert that commit. I would love to meet people who have actually been able to successfully do that, because in fact, reverting that one commit at the end of that feature is rarely as simple as that sounds, because typically when you decide to do that, more code has been merged on top of it, and actually it's not that easy. But let's say it is. Let's say you've got that one commit and you can just revert that feature. The fact that you're thinking like that means that you're still thinking in the way that people think when they work in that way. If you work following the MMMSS paradigm, where you're always making tiny changes and you're working highly collaboratively, so you're not working on your own, the rest of the team is aware of what you're doing, and you're writing highly modular, loosely coupled code, then it's not that difficult to say we don't actually like that bit. Typically, quite often, in the result of developing a feature, somebody has refactored, particularly if you're in the habit of daily refactoring and constantly refactoring. As part of that feature, some useful refactors have happened, and you probably don't want to throw it all away. But you might say, we don't want to use that bit of the functionality. Now, if you've written your code in a modular way that's well tested and has good APIs and good contracts between all of your classes, you can just say, we're just not using that. We just won't use it. And if there's a whole class, for instance, that you just like, actually, you know what, doesn't do what we wanted it to, we don't like it after all, throw it away. And it shouldn't break anything. So but people get into this way of thinking that here's my bit of work and here's my commit, and we either have it or we don't. And actually, it's better if you're working in small steps, you're doing little refactorings, you're adding little classes, you're adding little tests, you're doing a bit here, a bit there, and you end up with something that the user can see, which again might be turned on or off by a feature flag, or there might just be a button on a page that you just take off and it no longer calls that bit of the code. One habit that people do have, and I have, is hoarding, where you're like, we're not using it anymore, but we'll just leave it in the code base in case. That's not great. You can throw things away. And also with version control, you can get it back again. Yeah. So, yeah?
My question would be, do you encounter any teams that change their way of working to be continuous track-based development, but found out it's just not for them? They didn't like it after all and reverted back to the previous way of working?
Oh, okay. So the question is, have I encountered any teams that tried trunk-based development, didn't like it, and reverted back to previous ways of working? I haven't personally encountered that, no. So in my experience, when people try it, they love it. And it does take time, you know. I mean, like I said, you need to be good at a lot of different things, and you need to learn how to do those things. You can't just do it. And people often don't get all the way there. You know, they implement some of those practices, but they don't quite get as far. And there are lots of reasons why people don't get all the way there. I think what can happen is that people who aren't used to being highly collaborative, so they aren't used to practices such as pair programming or ensemble work, and people who aren't used to test-driven development don't like it. It feels weird and unnatural, and also they get that feeling, which I totally understand because I've had it, of there's people looking over my shoulder the whole time. I just want to go and sit in a corner and write code, and I don't want to have to deal with people, and you're making me pair with people, and I don't like it. A lot of people have that feeling, and it does take time to get used to it. And also you have to allow for differences. You know, some people really hate pairing. And actually, you don't have to make people pair. There are other ways of working collaboratively. But often the reason people hate pairing is because they've had horrible experiences where people haven't been nice to each other, for instance. Again, pairing itself is a skill. You have to learn how to accommodate other people. You have to learn to be able to say, you know what? Right now, what I want to do is go and surf the internet and look at cats for an hour. Can we stop pairing, please? If you can't say that to your pairing partner, then you've got a problem and you're creating a situation that people are going to hate and they're not going to want to keep doing it. So yeah, there are lots of reasons it feels uncomfortable. And there are lots of things you can do to make it feel more comfortable. But if you don't, if you just kind of drop it on people's heads and say, you have to do this now, then people will push back. They will. That will happen. So yeah, you have to be sensitive.
You've got time for one very quick question.
One very quick. Is this a very quick question?
Yes.
Good.
Have you got canonical results to stuff on people's noses that say we must use PRs because of regulators?
That we must use. Have I got a canonical resource to stuff in front of people's noses and when they are saying we must use PRs because of regulators? Yes, Dave Farley. So if you get these slides, in the links at the end, there is a link to Dave Farley's article on continuous compliance.
Thank you very much, Claire.
Hi, everybody. My name's Eleanor Seta. I run a small company called System Structure Limited, where we basically do one thing, which is fractional chief security officer for startups. I.e., I build security teams, and I've built probably, God, a dozen, 15 in the past decade or so. And so I am here to tell you as much as I possibly can. If you're in the position where you have, I don't know, somewhere between 10 and 200 engineers, which is sometimes actually 200 engineers, and they still don't have any security team, but where to start and how to think about security. So I'm going to start with the thinking bit, and then I'm going to get to the doing bit, and we'll go from there. Before I start, quick, who here has a security team at work? Okay, about half the audience. And I'm assuming if the rest of you don't, who here is PM, like product or project side of things, manager / exec, and dev, ops engineers, anybody? Okay, yeah. Cool, just so I have an idea of, yeah. So first I want to talk about how you think about systems. Systems exist to do things in the world. To be useful, systems need to have certain kinds of properties. Most of the properties are whole system properties. They're not like, you can't point at the part of the system and say, oh yes, that's the performant code. Or, well, sometimes you can, but then you have a different problem. So these whole system properties occur in specific contexts, right? It's not, a system doesn't exist in isolation. It has users, it has how much money can you afford to spend on this system. And all of these properties require unified effort to deliver. These are probably some of the properties you care about, right? You care that the system functions correctly. You care that it is performant on the basis of what your user needs are. You care that you don't burn more money than you have running it. You care that it's observable, and you care that it's secure and resilient. And I'm going to talk about those two conjoined because to me they're pretty inseparable as properties. So a system is one that predictably accomplishes the goals of the chosen set of people who you care about. There are probably a bunch of other people using the system who you don't particularly care about. So you have the set of users that you actually care about who are not necessarily everyone on the internet who may be trying to use your system. That you can have those people do that thing in the face of some actions by the set of adversaries you're trying to defend against. I hope no one here is actually trying to play the security against nation state games. If it is, I hope that you're not learning about security from the first time for this talk. If you are, let's talk later. That's a fun game, but yeah. And that you can predictably prevent that chosen set of adversaries from impacting your system. Because if you can't predict that you're going to succeed at preventing those adversaries, then you also, you don't have a system that you can rely on. So who here is familiar with the Resilience Engineering Association? Anyone? Definitely take a look at their work. They're looking at things like hospital emergency rooms, like aviation operations, and also increasingly at running large, complex distributed systems, because it turns out they have very similar properties. And in that world, we talk about reliability as the system doing the expected thing within the expected set of failure modes, right? So this is high availability systems is a reliability thing. Resilience is what happens when you leave the design parameters of the system and you're now trying to deal with something that you had no idea what was coming, but okay, let's try and keep the system up anyway. Okay, we just got, somebody forgot to replace a critical part. Well, we still need to land the airplane. This is where you get into resilience. And this is almost always a property of humans, because this is a property of, okay, how can we use this system in ways that it wasn't anticipated to be used? Every major outage is often the process of going from reliability to resilience, especially if you end up operating in a degraded state, et cetera. If your system is big enough, you're almost always pushing into resilience territory somewhere. Both of these are, both security and resilience are things that you can get to from principle-centric design and principle-centric architecture. Some of these are technical principles, some of these are human process principles, and I'll go through a few of each. Obviously, there's a lot more. This is kind of, I'm not going to read this since it's just where we're going. So state and logic. If you have a service, it should either maintain persistent state or do computation. If you have services that both maintain persistent state and do computation, they are much, much harder to debug because you now have to, the result of a computation isn't predictable, the result of a store action, et cetera, isn't predictable. So you want to split those so you can at least test them separately. In general, complexity is the absolute enemy for security. The more complex your system is and the more complex any component is, the more complex the overall system is combinatorially. It is not, if you have one system with one bug and one system with one bug and you hook them together, now you have two systems with at least 3 bugs because there's going to be mismatches between the two. If you have 20 systems, you have possibly 20 factorial bugs. So you want to make them as simple as possible so they're more predictable. You want to make them immutable. You want to have state in as few places as possible. If you have, like, obviously, a running process has state, it has state in memory. But the more frequently you can drop that state out and get back to 0, get back to that predictable starting point, the better off you are. If you are running heavyweight VMs that you patch in production or you update config files in production and you end up with config drift and all of this kind of stuff, congratulations, your system is now wildly more unpredictable. You don't know actually what system you're running where. If you blow everything away to a clean state, I don't know, probably no more frequently than every 5 minutes, but I've seen systems that do it faster, like even with heavyweight VMs. Now you know where you are. Also, the more ephemeral your systems are, so great, you have a web server, it gets compromised. Well, that web server has a 2-hour lifespan. That means the attacker needs to rerun their exploit every 2 hours if they want to stay in that system. Exploits are often loud. Now you have many, many, many more possibilities to catch that exploit being run than if it's, okay, run it once, stay in the system, stay resident there for 2 years, whatever it is. So yeah, both of these are design choices that you can make that will make it much easier for you to maintain the security of your systems separate from whether or not they start out at, from whether or not they have vulnerabilities. Immutable systems, and by this I literally mean ideally no writable disk. If you've got a VM, fine, you can have a no exec, no root scratch disk. but nothing that actually can run code can be changed. You just actually redeploy. That also means that an attacker now has to live in memory, right? They can't write, they can't download tools, write them out to disk. You've made their job much, much harder. Minimal canonical state. Ideally, you have at most one source of truth for every piece of state about the system. We almost always exist in a state of sin here because, like, okay, you have a cloud environment. I have all of my IAC code. My IAC code is canonical in theory, but also the actual running cloud configuration is canonical because that's what's actually running. This means that you need to have active bidirectional cross-checks, right? You need a closed loop control. So ideally, that's not just, fine, we have Terraform pushing state out, but then we also have inspec or something validating that, the system is in the state that the Terraform told it to be. You're not going to get there immediately. Although if you're starting out, you can start building a lot of these, you can start building in this way from zero, and it's a lot easier. You will also catch a lot of deployment issues as you go, et cetera. So there's benefits if you can start working that way. But yeah, as few stores of state as possible. Caches are not canonical. So you can get away with caches as long as you have appropriate, checks on them. Bug mitigations. This is the mitigator. The mitigator raises the bar until he can't see the problem anymore. Mitigations always fail. So do not, if you have let's say outputting, like a cross-site scripting problem. One of the ways that people try to deal with cross-site scripting is, we'll try and validate the input so it can't contain anything that could run a script. You're always going to miss something. So instead, you make sure that when you write those strings out into a page context, they are encoded in a way that they cannot be executed. And you do it right at that point. And then it doesn't matter if you've missed something in the data, some path didn't have input validation, you got data from a third party that was dirty. You don't have to think about that. So in this context, output encoding kills the entire class of injection vulnerabilities. The same with parameterized queries. Anytime you have the choice between applying a mitigation, say address space relocation, like address space randomization for C libraries, which is a mitigation against buffer overflows, but it doesn't actually work in the end because as soon as we shipped ASLR, people found ways to get around it. And it took 6 months, a year for people to find the bypass techniques. And then everybody just copied that. And now everybody was back to square zero instead of, writing in a memory safe language in the first place. So yeah, if you have a choice, always kill bug classes. And kill them at the framework level. Never don't put your fixes, each time I write this function or a function of this type, I have to remember to put this thing in here. If your framework doesn't already do it for you, or your language doesn't already do it for you, either change languages or ideally pick a different language originally, or patch the framework or add your own library that fixes this problem for you. You want to make things as easy as, have your developers do as little incredibly sensitive coding as possible. So if you have to do that, do it once. Segmentation is great because after you've been compromised, you will always eventually be compromised. The attacker probably still needs to get from the place that they compromised a system to somewhere else. The more ways that you can stop them getting from point A to point B, the more likely you are to frustrate their ability to do the thing that you don't want them to do. So that means, between systems, between instances, between environments. So service level firewalls, creds that are per instance rather than per service. So that yes, service A is talking to service B. This instance of service A has unique credentials which are bound to the lifetime of the system. So once that, when we roll that node, then the credentials die with it so that if the credentials got leaked, they're no longer valid. We don't have to worry about it. Vertically within a system, so things like AppArmor, traditional system hardening, traditional least privilege, and then time-based, short-lived secrets, short-lived hosts, et cetera. And then obviously making sure that, dev and prod are actually different environments and that you don't have the data that you're trying to protect in prod. Oh yeah, but it's also, we just have this copy in dev because we need to test on real data. No. So now let's talk about people. If you have the choice to declare a configuration rather than programmatically generating, programmatically creating a configuration with a set of steps. Humans are much, much better at understanding the end state of a declarative system than a programmatic system. So it's much, when you read a declaration for what the state of the system can be, you will notice the errors much more easily than you will when you read the programmatic steps to get there. So if you have the option of using a declarative tool, use a declarative tool. Parser generators are great. There was a whole movement called Langsec, which basically was like, second to memory failures. Parser failures are the most common source of bugs. We are incredibly bad at writing parsers. We're really great at writing language specs and reading language specs. But if you're manually writing a parser, just stop. Just get a parser generator. Your life will be so much easier. And especially get a parser generator designed with security in mind so that you can prove at the tool level, not in the code that you're writing, that there's a proof that this will be a correct parser in all cases. And when I say parser, I mean you're accepting a string, any string, that you're doing something different on the basis of the contents of that string. That's a parser. Not necessarily a complicated parser, but state machines also. How many of you have to deal with business logic that has big, complicated state machines in it? How many of you know whether or not that business logic is actually correct? How many of you know the business logic for your company and can point to it outside of the code? I've never had a client who can do that, including banks. They know what it's sort of supposed to be, and then there's all the edge cases, and those are really only in the code. If you've declared the state machines, you are a lot closer to being able to actually understand how your business runs, as well as dealing with oh wait, somebody started this transaction in a legal state, but the state machine, we never thought to write the code that says, oh, we started a transaction at the confirmation stage, like a money transfer at the confirmation stage. Well, we just accepted it and we moved the money, That kind of thing is really, really common. Compromise is inevitable, right? So you should design for it. Something is eventually going to fail. Something will get owned. You can design your systems to handle more and less predictable failures. But part of the way you do that is assuming, you look at your layers of controls where you have, this is a thing that prevents someone from writing to the database, and this is a thing that someone prevents, someone from getting the creds to write to the database, whatever the control stack is. Assume any given one of those layers is going to fail, right? Maybe don't assume more than one layer will fail, but assume at least one layer will fail. Is the whole system still secure? This is defense in depth, but this is how you actually do defense in depth, is you look at those control flows. Also, you get to choose the system that you have when you're responding to a compromise, right? What would you like to have had during your last major incident? You can think about that beforehand and design for it. A lot of this means visibility. And this means visibility not great, we have these log files, and they contain all of the events that happen in the system, and no one looks at them because they're not human readable. On the other hand, we just have a Slack bot that tells us every time somebody SUs in production, because that shouldn't happen very often. And sometimes fine, we're in a situation where sometimes people need to SSH into a box and do something. Wait, but Bob's on vacation. Why did he just log in? That's weird. Now you've noticed a thing. So those kinds of socially visible risky events are really, really useful early warning systems. Human error is also an absolute constant, right? Your staff and your users click on things for a living. That is their job. Their job is to click on things for a living quickly. You cannot train your users out of clicking on things because that is their job. You cannot yell at them to make them stop clicking on things because that is their job. You can make clicking on things safe. So do that instead, because that actually works. If you do not already use YubiKeys, switch everything over to YubiKeys. Not passkeys, YubiKeys, and U2F mode, or any of the other tokens that are U2F tokens, because that actually stops phishing. You just get to stop thinking about credential phishing. Great. Problem solved. Now you can stop doing phishing training that alienates your users and makes them fear security. Get, Word, and Excel, and all of the other common malware vectors. You definitely don't need the desktop tools. You probably don't need them at all most of the time. Just get rid of them. If you can't, if you still have to yell at your users, get goats. You'll yell at them too, but the goats are funnier. It's still not going to work. They're still going to do what they want. But yeah, decision making at the edge is incredibly important for resilient response to incidents. So ideally, the person who is committing the code, the ops engineer who is changing the thing, is empowered to make most of the decisions about their work without cross-checking with anyone where it's not like a technical cross-check. And ideally, if they need to reach out to another team, like, oh, I need to talk to the DBA, I need to roll this database right now, they can call that DBA directly, immediately, without having to go up a chain and back down a chain. Because, and you have the social relationships in place to let people do that. These are the things that let your team actually respond to incidents, whether they're security, reliability, perf, whatever, quickly. Communication and coordination are much more important than control as a manager, which is terrifying if you're a manager. It's even more terrifying as a security person, and yet it is the only thing that actually works. How many people, if you're managers, know, I guess if you're in Europe, you probably have a better idea, whether or not your teams have taken all of their vacation? If you don't know this about your team, that is a problem, because you have people who are burning themselves out. If you work in a mission-driven company, you have an even bigger problem, because your employees are now motivated to burn themselves out. If your team not only isn't taking their vacations, but is also scheduled for 100% of their time, right? They don't have slack in their schedule. Great, your team does not have time to fix all of the small things before they become big things. Have feature velocity caps. Push back on product and be like, no, this is our. Yes, I know we have more time available. We're not doing it. Ideally, you can do this without hiding it from other parts of the org. Almost every dev team I've seen just kind of lies about how fast they can get work done because that's the only way they can get maintenance time. That's really dumb. You should fix that. Stop lying to yourselves. Okay, so let's talk about the more practical side. Let's talk about scope for security when you're starting out especially. You care about the software you write and your production infrastructure. This is what we all think about. You care about your laptop fleet and your IT systems. One of the things that I end up saying a lot to clients is, yes, I absolutely trust all the engineers who work here, but I don't trust their laptops. That shit does all sorts of stuff. And maybe it's the engineer doing it sometimes, but even if you just trust everyone implicitly, don't trust their laptops. Cloud stuff you've forgotten, like the number of times I've seen like, oh yeah, and then we have Zapier here. And oh yeah, like it has production DB creds. What? Oh, and like, yeah, half of marketing has Zapier creds because they also use it for marketing. We just use the same account. Okay. Yep. The tools that your employees use to get work done, not the tools that you've told them to use to get work done, but the tools they actually use to get work done. Visual Studio has a great plugin infrastructure that can do anything the engineer can do. And those plugins can, literally they can do anything the engineer can do. Do you know what plugins your engineers have installed? Most people don't. You have to think about your products and services from your customer's perspective, right? You have a duty to your customers to think about security implications for them, not just for the company. And how you run your operations. This is all of the like, oh yeah, the CEO told me to go buy a gift card scams. This is all stuff that you have to care about. When to start? For the product, you should be thinking about risks for the users and for the company early. You should know what can go wrong. As early as possible, make good language and framework choices that are designed to make your life easier. Do not write your own authentication layer. There are plenty of companies that will do that for you. Do not host your own authentication layer. Like, yes, I know that there are great libraries. Just let Auth0 do it. Because now, when you have a password leak, you can blame them. Also legally, this will make your life much easier. Just don't do it. Even more for stuff like crypto. The less data you have, the less risk you have, right? The best way to reduce Your legal exposure in the event of a data breach is to not have data. So think very carefully about what you actually want to keep. Try to avoid, as I know has been the fashion for a long, we'll just keep that. We might need it later. You know, product says they kind of want to have that because they think they might do something. No. Business case justification for every piece of PII you keep. Do this stuff immediately, then figure out if it's a real product. Don't bother with anything else until you know it's a real product. For a company, make sure it's a real company. Do not worry about security when you're pre-A or before 10 technical staff, unless you fucking up is going to get your users hurt or killed. Seen that too often. Or, you know, like some other extreme negative effect. Don't worry about it immediately, because this is going to take a lot of your time and it's going to change the way you do development and stuff. You probably don't need to do it that early. Do start at pre-B round, preferably start it immediately post-A so that you have stuff in place pre-B, because it will make diligence easier. Ironically, if you have non-tech funders, you need to do this earlier because they are going to outsource technical diligence, including security diligence, and you will get barraged with checklists rather than having a call with a tech-oriented VC where you can say, well, we're doing this, and then he gets a good smell, and he's like, yeah, cool, whatever, you know, spend some more on it later. Buy as few SaaS systems as you can, because you're going to have to maintain all of those, and you're going to have to track all of them down. Try maybe not giving people the Divi card or whatever that lets them just put stuff on the corporate card with any review, without any review. So just keep that stuff as simple as you can. So when you're starting, if you do not already have an IT engineer and an ops engineer, you need to hire both of them. If you are not in a position to hire an IT engineer and an ops engineer, you're not really in the position to start doing security work because you're not going to have the bandwidth to actually start implementing it. Make sure that you have actual backups that are tested. I would say 95% of my clients, there has been some production critical system that they have not had backups of. And these are not small companies. These are companies that you have heard of. And still, oh yeah, we were, you know, quarterly, no. Get backups. AWS and GCP both have tools where you can put something into long-term storage, and then you can set a minimum retention time, so it cannot be deleted for a year. And then you can remove your ability to change the minimum retention time. And for example, with AWS, if you close your account, you close the entire account, they'll say, no, sorry, we can't close your account for a year because you need to keep paying for the storage for that year because we can't change it. Now, you can often get around that, but that means sending yourself and lawyers to an office level of change, which is not a thing that ransomware can do to you. So you now don't need to think about that, or at least not thinking about the data deletion part of it. Get everything you can on SSO, like everything that will just plug into Workspace for SSO, do that. Get YubiKeys for everybody. Try to avoid having Windows boxes. Definitely try to avoid both having Windows and Macs. Definitely avoid having Windows, Mac, and Linux desktops. Dear Jesus, you've now got 3 times the work, except you actually have 4 times the work because you need to make sure they're all to the same standard. You don't have the money for that. Just pick one. Get some kind of fleet management. If you have a network, Thinkst Canaries are great. They are the only security product which I recommend by name because they actually literally take 5 minutes to set up, and then they don't fucking bug you until somebody pokes them in a way that they shouldn't. And then you find out about it. It's great. They're also a great tool for when you're at the point where you're getting more complex internal pen tests. They'll let you know where the pen test team is, which is a lot of fun. And get some kind of basic log centralization. If you don't have log centralization, you can't figure out what happened in a breach, which means you can't figure out what data got taken, which means you can't figure out what users to notify, which makes the conversation with the ICO really annoying. So get basic log centralization, even if no one is looking at it. Just get it stored somewhere. Governance. If your CEO, CFO, COO, CTO are not on board with security, nothing's going to work. That is an absolute prerequisite for any meaningful security work. Someone has to own security. This should not be the CTO because they do not have time to think about security. And security does, in some places, work at cross purposes with the rest of technology. That person who owns security should ideally be a peer. They should not be a report to the CTO, because they need to be able to tell the CTO no sometimes. Now, ideally, they never actually say no. We'll talk about that in a minute, but they need to be able to. You also almost certainly do not need, and this is like, obviously I'm self-interested because I am a fractional CISO, you need somebody with a bunch of experience. You do not need them full-time. You are not going to be able to use them full-time for a while, but make sure that you have access to that. I don't care where you get it, but finish your vegetables. If you start a migration, finish the fucking migration. Do not build legacy systems in the first 3 years of the company. Actually finish the work that you start. Unless it's like, if it's going to kill the company, fine. If it's not, finish it. It will make your life much, much easier. Think about the incentives you set up. One of the big problems I see is like, oh, we have features that are tied to KPIs, and if you don't hit the KPIs, you don't get bonuses. Oh, now do this security work. It's very important. Nope. Not going to happen. Doesn't matter. You can yell it. Nope. It's not going to happen. Set the incentives that you want to get the results you want. You cannot fight the incentives that your team has. Don't try to do qualitative or quantitative security metrics. You don't have the data. You don't have the maturity. Figure out how to do qualitative security metrics well. A good description of the state of the security written by somebody who is a more neutral party is going to do a lot more use than, oh, we have these 3 weird metrics that we have that we think, well, they don't actually relate to anything, but they sound good and they're metrics. They're definitely metrics, and they're definitely security related, and that definitely makes the board happy. No, get the board to learn how to read a paragraph. When you buy SaaS tools, include the cost of maintenance, because it's going to be more than you think, because somebody has to manage that thing. Getting work done. Yeah, you need to be able to delay product work sometimes. Your planning process is security critical. One of the big failure modes that I've seen is companies that, like, well, we're small, we're starting out, there's somebody who has the product vision and they just kind of decide no, you need a process, because once you're starting to do security work, you now have 2 competing priorities, and 2 competing system visions, and that means you need an actual process. It can be super lightweight, but it needs to, A, be documented so that there's a meaningful way to engage with that process, and B, actually be the actual process by which decisions are made. Not, oh, we have this process, but actually, well, there's this guy, Tom, and no. Follow the process. That means segmenting high importance, low urgency work from actually urgent work, right? So a lot of security work is not urgent, right? It's like, we're not owned today, but if we don't do this, we will be owned, I don't know, maybe this year, maybe not. So you need to have a way to figure out how to balance those 2, which is really, really hard for startups. You need to be moving beyond single quarter planning at this point, because you're going to be dealing with longer term narratives. You need a lot of cross-team coordination. Again, you should be doing this anyway, because it will make your systems more resilient in the case of outages. But specifically for security work, a lot of that work is cross-cutting. Technical decision-making and architecture. How many people here know how architectural decisions are made at their company? Yeah. They just happen? Well, we ended up here. I don't know. Some things, no. Get good at that. It's worth getting good at that. It's worth having some kind of super lightweight process so that you actually know where those decisions get made, so that there's a place to intervene in them. And then there's a place to cross-check so that you don't end up, I don't know, spending a year and a half developing a product that you kill in the last 6 weeks because somebody actually looks at what it does and is like, this is unshippable. That sucked. The more unified your working processes and tooling is across teams, the better, the easier it's going to be to do that collaboration. Security's job is not to be that cat. Security's job is not to say no to things. Security's job is to say, okay, that's interesting. What are you trying to get done? How can we help you get that done? And that is the attitude that you really want your company to understand for all of the security work. It's like, yeah, you know, and sometimes the answer is no, you can't do it that way, but it always has to be, but how can we do this another way? You want your security team to make friends, especially once you're at the point where you have an actual team. Rotate people in and out. Rotations are great for building those horizontal connections. At Etsy, I was their security architect for a year. We had free candy. There was lots of health food in the building. We had candy. And that meant that everybody stopped by the security desk every now and then, and you know, we got to know people. And yeah, it was absolutely worth the candy budget. There are a lot of brilliant security people out there who are best kept in a basement. Do not hire those people. Hire people who know how to talk to people and know how to communicate and know how to negotiate, because especially at a startup, they're going to be doing a lot of that. You need to select for that. It is as important as technical skills for them. Do not ask the security team to do all of the security work. You know, you need to have other teams doing that work. But ideally, there should be, you know, some resources that the security team can also allocate. So they need some way to give back. There needs to be not just a one-directional street there, because you know, if the security team is always asking for, oh, I need you to stop and do this, you know, whatever. Maybe they have a pool of cloud spend that they can give out, or I don't know what it is. You know, figure out how the horse trading can work, and make sure security has some horses to trade with. Compliance. So compliance regimes give really useful incentives and really bad guidance. They are not, you do not build architecture on the basis of what the compliance regime tells you to do. You build architecture on the basis of what actually delivers security results, which often has very little to do with what the compliance regime would suggest, and what the business needs and technical reality, et cetera. And then your compliance team figures out how to sell that to the regulators. This is not about shirking compliance duties, especially if you're in a regulated industry, et cetera. This is about building a good system that also satisfies the requirements. And sometimes this means story time. There was a guy, I think at GDS maybe, and he built a PCI environment that was not segmented. The systems that handled cardholder data were not segmented from anything else. But what he did is he rolled those systems every 5 minutes. So basically no credit card data could be persisted in memory. And he had a long conversation with a very friendly PCI auditor. And yeah, it was fine. There are a lot of things that you can do, even in the face of regulations that seem really explicit and seem to be pushing you towards a specific, possibly not great architecture, to not do that. Security compliance must report to the CISO. That should not be under ops, et cetera. And this is about making sure that actual security is driving the way you do security compliance, rather than compliance driving the way you do actual security, because one of those works. Risk. How many of you know who your adversaries are? I mean, like addresses. Like, if you work at Google, there are a bunch of Google's adversaries where, yeah, like, oh yeah, this piece of malware, I recognize that thing. That's this one guy in China. I know who his girlfriend. You do not have that security team. You probably don't see enough attacks that you can generate meaningful statistical data about them. If you run a marketplace and you have fraud on that marketplace, which you do if you run a marketplace, that's the exception. For everything else, you have exposure. You do not have risk. This is a particular nitpick to me. I don't like to see companies making up data for metrics. So it's like, oh, okay, we have, you know, it would be this bad in dollars or t-shirt sizes if this thing happened, and we think the probability of it happening, no. You think the difficulty of it happening, sure. You think the cost to the attacker to launch this attack, sure. You don't know anything about probability, don't make numbers up. Detection, you're gonna need to log stuff. It's gonna cost money. Try not to spend that money twice, because your ops team and your application team also need logs. Ingest is expensive, ingest in one place that everybody can use. You need someone to look at the logs. Actually haven't checked that statistic in a while, but it's been holding around there for a long time, 210 days to find out that you're compromised. And something like 75% of the time, a company finds out that they have a compromise because either their hosting company or another vendor tells them. Don't be that guy. But hey, that's a pretty low bar. You can do better than that. That's the average. You're not going to hire a SOC in-house anytime soon. You're going to outsource. You're going to outsource to some kind of managed detection team. Which one you pick depends in part on what your growth curve is. If you don't expect to be building a SOC in the next few years, then you probably can outsource to a team where they own and run the infrastructure for you. If you do expect to be growing on that curve, then you want to outsource to a team where they use your infrastructure. There are a lot of ML tools out there for security. They're mostly crap. Detection is a place where they can sometimes be useful, but if you have an ML tool that claims that it will replace engineers, they are lying to you. It will absolutely not. It is at best an augmentation. And if you didn't log it, you can't figure out where they got in or what they took. So you need to have those logs somewhere. Capability, code, is not an asset. Code is a liability. You spend lines of code to buy features. Every line of code is an ongoing cost and an ongoing risk. Tools that help you write code faster are bad. Like, yes, if they help you write code that you know is going to be bug-free, a parser generator, the code that you're writing is the language spec, not the code that's generated. Other than very specific cases right now, you should be asking whether or not this feature is worth the code it takes, as well as the time it takes to write the code. Every tool you adopt, every library you adopt is an ongoing cost. Most technical debt slows you down, and specifically security debt is mostly debt that you don't know about, right? It's where we have a legacy system and we know it has problems, but we don't know what problems. The more of that you can get rid of, and the more of those legacy systems that you can finish your migrations and get rid of, the better you are. On the front end, you probably don't know what JavaScript runs on your site. There's a tool called LookieLoo, which is great. It lets you figure out what all of those advertising, like where stuff is going, what's actually calling what. If you look at a modern website with a bunch of ads on it, you're probably hitting 800 sites on the initial page load. All of those sites can do anything they want in your page context. If you can avoid having advertising, especially on any site that actually matters, anything that a user can do something for real, including the tracking code, especially if you have like third-party code that's still loaded there, just get rid of it. It's malware. It is actively malware at this point a lot of the time. Not even like in the sense of like, no, it's actually malware a lot of the time. The web security has gotten a lot more complicated. You need to understand content security policies and all of the remote object loading stuff. There's a long tail of stuff. There's a Google paper on the post-Spectre web, which is still worth reading. I think there's actually a WC3 draft or something. It's worth reading just if it's been a while since you updated your understanding of the web security model. It's worth reading. Stuff that you integrate on the back end where you're serving the JS is much easier to control. You control the versioning, etc. Do not expose GraphQL to the internet. You don't expose databases to the internet, don't expose GraphQL to the internet. If you expose GraphQL to the internet, congratulations, you need to write canned queries and call them by hashes and deal with versioning on the client side. It's a lot of work. Just preferably don't do that. Supply chain, you also don't know what runs on your back end. How many people here know which library version they have everywhere and are sure which of those have CVEs in them? You need to be able to reproduce point-in-time builds. And you need to have an understanding of this hash, this version, has it changed in the repo? That's weird. A release has changed without an update. Artifactory is annoying. It's the least annoying tool I've seen for having local repos and having this kind of cross-checking. It's better than nothing. Shove all your config in Git so you know what was there. Make sure that you have all of your deploys logged. Make sure that you can figure out, oh yeah, when this query ran, I can reconstruct the system it was running on. When the system gets large enough and complex enough, often no longer possible, but you should have at least some idea. Audits. Red team audits are for testing incident response. They are not how you learn what is in your environment. Do full access gray box testing. Don't hamstring the team by not giving them code access. Do an early test on an MVP, and then full tests later on. You don't need to be doing full fat tests early on. Some solutions to avoid. Don't let the CTO buy things he sees in airports, especially if they're security tools. That is, good tools rarely advertise in airports. They don't replace security engineer. If it's a black box that you can't understand what it's doing, it's rarely useful. DDoS, spam filters, sure. AV, not so much. You want tools that work like the internet. A couple last things on product security. I know we're just about at time. You get to design your attacker's motivation and the problems that your attacker has to solve. This is one of the very few places where you can actually make those choices. So think about your product in terms of designing the adversaries that you want to deal with. Spend as much time engineering the unhappy paths. Understand where all of those failure modes go. Know where all of the decisions are made so that you actually get where the problems are. Document all of this so you can actually figure out, oh yeah, this is where the login flow goes today on this build. If you have to deal with non-credit card fraud, hopefully you don't have to deal with credit card fraud. If you're starting a bank, talk to me. But if it's not credit card fraud, that's a non-credit card fraud, it's a core competency. Treat it like one, build that skill early. And finally, you are responsible for the impact of your work on people's lives. And you don't get to get rid of that content. Even if those people shouldn't be using your product for the things they are, you put a product on the internet, people are gonna use it. You don't have control over that. I'm gonna give you 3 personas that you should be thinking about in the product design process, regardless of whether or not you think they're relevant. A domestic violence victim who's seeking an abortion, right? You're Slack. Oh no, we're not a social tool. I'm on more social Slacks than I am client Slacks, right? These are things that you have to think about, right? You know, trans kids who aren't out at home, right? How does that interact with your parental controls? A union organizer, right? Well, we just make corporate middleware something messaging. Okay. You still have a responsibility to those people. They're not the ones paying you. The ones paying you may not even like, may not like those people. You still need to think about it. Anyway, if you're a startup, you're looking to get serious about security, come talk to me. So one of the things which is useful here is to figure out which things you really care about, right? If your ecosystem is segmented in a way where you can say things about like what should be getting traffic from what, right? Figure out the things which are big red flags like, hey, somebody just tried to SSH into a bunch of these boxes from an IP that is not our one bastion host. Alert on that, right? You're not gonna build out alerts for everything. Do those first, make sure somebody actually looks at the alerts you really care about. That's one of the reasons why I like canaries, is they don't generate false positives. Like sometimes I get a ping, but it's an engineer, like what's this box? Great, I wanted to know that he did that, because he's probably doing that elsewhere, and maybe that's totally fine, or maybe it's a problem that I need to have a talk with him. So yeah, figure out like high value alerts that you can get, and then get the outsourcing done when you can. Word, Excel, and Acrobat are the primary malware vectors still. Like 90-ish% of the time, if you have an owned laptop, it got owned via one of those, unless an employee actually intentionally downloaded a thing and ran it. If they clicked on a thing and then they found themselves owned, it was probably one of those 3. Get rid of those 3, you've gotten rid of the vast majority of your malware risk. Talk to me. Yes, that's a complicated problem space. It's a fascinating one, but it's a complicated one. Thank you.
Today, we are going to be talking about mastering visual communication. So a lot of people think of this as a kind of soft skill. It's not a soft skill, it's what I call a core skill. Okay, so I'm renaming soft skills as core skills because people think, I don't need soft skills, I need Kubernetes, I need things to do with Scrum, but I do not need soft skills. You do need soft skills, they are core skills. So I've now renamed them. You can all take that into the world for me. I need you to say, no, they're core skills. Right, so we are going to be focusing on the visual stuff here. And this is from part 1 of the book that I've written, which is called Communication Patterns. And that was published by O'Reilly last year. If you have an O'Reilly subscription, you can read it online. So do that. If you don't, take away one of the bookmarks that you've been given because you can get 30 free days from one of the codes on there. So enjoy that. So, a quick introduction. I'm Jackie Reed. I am a consultant architect. And so I go into businesses, help them with their software architecture. I also offer training and workshops. So I can go into businesses in person or online. So if you're keen on finding out more about that, check out my website. And then this is your feedback for today. I'm going to give it at the end as well, but I was asked to put it in the beginning because I don't know. Anyway, so what we're going to look at today is effective visual communication. So we can all kind of put boxes and lines on a page, but can we actually get the message over that we want to get over? And I've arranged this into patterns and anti-patterns because in software, we're very used to applying patterns and avoiding anti-patterns. So this is a nice, easy way to show you all of these things in a way that you commonly use. And what we're going to do is we're going to avoid kind of the pitfalls and actually get that message across and deliver that impact that you need to the various stakeholders when you create diagrams and other visuals. Now, the first thing I want to show you is style communicates. So we've got 2 diagrams here. They are exactly the same, apart from the style. Now, if you have a think about it, which one in your head is like the most formal one of these 2? I think we could probably all agree that it's going to be number 2. But what we can do with style is we can use it to visually communicate to people. Because if you have this diagram and you show this sort of style diagram to stakeholders at the beginning of a project, you might get the question, oh great, when do we start testing? But actually you haven't even implemented anything yet. You haven't even done a proof of concept. But if you showed them this sort of style, you might not get that misunderstanding. But then again, show this to your stakeholders towards the end of your project, and they're going to go, ooh, are we not as far along as I thought we were? Are we still in kind of an idea stage? What's going on? And I call this pattern meta style because it's a bit like metadata. You are giving people subconscious messages by how you actually style your diagram. If it's a quick sketch, people probably aren't going to trust it as much as if it's a more formal style. And so what we're going to do here is we're going to use style actually to our advantage and think about what we want to communicate to people and avoid that miscommunication of giving people the wrong idea. So I know it's after lunch and you're all kind of a bit asleep, but unfortunately this is quite an interactive talk. So which of these styles is correct? This is a data flow diagram. It's kind of a level 2 data flow diagram. We're getting into the details here. So which one do you think you should use? Should you use the sketchy one, number 1? Put your hands up if you think number 1. And put your hands up for number 2. Yeah, people usually say number 2, but I'm going to do the software architecture thing and say it depends. Sorry, You don't get that too much in Agile conference, but you get it all the time at a software architecture conference. So yes, you would probably be using the more formal style of number 2, but maybe your company insists that you have to do it this way. So just do it. Or maybe this is just the initial idea of what you're going to do at this level. We're just starting to explore. So you could use number 1. But that's the first pattern for you. Now we're going to move on to another pattern. And this one I call facing the crowd, also known as know your audience. Now, we all kind of know different audiences need different kind of levels of detail, different types of diagram. But we tend to kind of just forget that, and people just say, oh, create a C4 diagram for this. Create a, whatever the type of diagram is, a sequence diagram. And we kind of think, oh, I've got to do that. But we kind of forget to think about the audience and what the message we're trying to get across. So the first thing you need to kind of think about is, who is your diagram for? And sometimes this is going to be, this is only for developers, quite technical people. Sometimes it's going to be just for business, and sometimes it's going to be a mix. And so you have to be very careful when you're thinking about who is actually going to read this diagram. And I've got a few questions for you to think about. So the first one is, what's their technical understanding? Are they a very technical project manager? Or do they just want to kind of know how the technology that you've chosen meets their needs? You've got to get that kind of balance. People don't really want to know what kind of queue that you've chosen, what particular technology they've used. They just want to know that their needs are going to be met. Then you need to think about what level of detail do they need. Do they want, if you're showing someone some kind of review, are they going to want all the detail, or do they just want like the high level detail and you've already done the technical stuff with and the more in-depth stuff with other people? You don't want to give people too much information that they don't want, because then they'll forget the important information that you wanted them to actually remember. Then you need to think about, what do they want from you? And a lot of people do remember this one, but quite often they don't know what they want from you, and so you've got to kind of be the detective and work out what particular people need from you. If you do work out what a particular stakeholder generally needs, make a note of it, because then when you're working on something else, you will probably benefit from going, oh, this particular stakeholder, the product owners normally want this, this, and this. So let's look at that. And then finally, this is the thing that most people forget. What do you want from them? Do you need them to sign off on a decision that's been made? Or do you need them to make a decision? You need to make sure you give them that information even if they haven't asked for it. Because if you don't do that, then they can't do what you need them to do. It's like chicken and egg thing. So those are the 4 things to think about. Now, I've got a couple of diagrams. You've got to work again, sorry. Who would this diagram be for? This is a UML diagram. I did say I was going to use that phrase, UML. So it's a class diagram. Who do you think would want a diagram such as this one? Just shout out. Nobody. There's always someone. Yes, it's a UML diagram, nobody wants it. Anyone? Pardon? Yep, data people, because you're probably going to want it. Architects. Yep, so this is probably going to be the more technical people. It's going to be like the developers who might be developing this kind of area. It's going to be like people who might be creating a database schema, this kind of thing. What about this one? This is a C4 context diagram. So this is quite high level. Who do you think would like this kind of diagram? Product manager? Come on, wake up, wake up. Yep. Yeah, I think so. But, pardon? Yes. Yes, definitely. So, lots of ideas here. Basically, this diagram is pretty much everyone. Because even if you're a developer, you should kind of know this information. If you are a Scrum Master working with a team, you should know this information too. If you are a project manager, you should know this overview. But even if, like I say, developers should see this, people say, oh, but I'm working on this tiny little microservice, which is one of 600 microservices in there. Why should I know that? It's like, well, at some point, your microservice might need to talk to that, and you need to know who's using your system. You just need to have this understanding. So that's for everybody. Now, my first anti-pattern here, this one I call a multi-story diagram, also known as mixing levels of abstraction. Now, this is an interesting one, because for anyone here who's ever coded, you probably recognize this as a bit of a sin in coding. And when people code, we kind of split things up into these different levels of abstraction. And maybe at some level we're doing that with distributed services. But if you're using a layered architecture, you might have something like the presentation layer and a business, persistence, and a database, or the other ones up here. But we should also be doing this in our architecture. And we just looked at a C4 diagram just now, which was the context level, which is the highest level. We then have container, component, and code. If you do use C4 model diagrams, you will probably end up just using these top two. And if you haven't heard the C4 model, I recommend going and having a look, because they're quite useful diagrams. You can't use them for everything, but they're useful in your toolkit. We also, when we're looking at frameworks and things, we split things up into these different levels of abstraction. So the SABSA framework is a security architecture framework, and it splits up things into these different levels. And if we get a diagram that mixes these levels, we kind of get some misunderstandings that can occur, because we end up, if I can get this to work, there we go. So this end, the end of this arrow is kind of a different level of abstraction as to the other end. And that means we're not really quite sure what's going on here. So what we would do in the C4 model is that we would split this up into the context diagram. So this is the same one that we saw earlier. And so that's got this software system in the middle. And then we also have this container diagram. And this is showing the same service, but this dotted line around here is that dark blue box from the previous slide. It's labeled the same down there. So we've split it up, and we can now see actually what those arrows connect to. So mixing those levels of abstraction causes confusion. So just like for those who code, we need to be splitting things up into multiple diagrams. And I'll talk more about how to navigate those multiple diagrams a bit later on. Now, this is probably people's favorite anti-pattern most of the time. I call this one explosion of unicorns, also known as too many colors. And for this one, I need to put on some safety device. I get exposed to this all the time. So very often you'll see a diagram like this. Maybe it's not really bright, but it has many, many colors on it. But those colors don't actually have a meaning. Someone's just gone, oh, all of these are different things. I'm going to color them with lots of different colors. But anyone who sees the diagram thinks, what do those colors mean? And that uses up precious brain cycles trying to find these patterns, because that's what human brains do. We look for patterns all the time. And so if you're going to show people something like this, you might as well actually be showing them that. So don't waste people's brain power with things that don't actually have a meaning. Also, don't force them to wear sunglasses to look at your diagrams. So what can we do? I'm going to take those off again so I can actually see you now. We can actually use that color to communicate. We can group it by, say, a type or a function. So in this case, I've reduced down those numbers of colors and I've used them to actually indicate something. Look, I can even put a key in. Do that, do use keys and legends. I don't care which one you call it, but do put them in. And so we've reduced down those colors. So that's my first big tip. Minimize your color palette. Even if you've got a key, if you have more than, say, 6 colors in there, people are really going to struggle with going, oh, what's that? Okay, that's that one. What's that? Okay, that's that one. So don't put 17 colors and go, but I put a key. It's fine. Reduce those colors down. Split that diagram up if you're going to need to show tiny things like that. But also we want to use that color to communicate. So make sure it has a meaning. If it doesn't have a meaning, don't use it. Use the same color for all the bits in your diagram. Make it black and white. We don't really like to use just black and white now. People try to put all these colors in things, but if there's no meaning to it, don't make it fancy. If you do use just black and white in your diagrams and you want to highlight something, you can then just put one color in, and that completely draws people's attention to that bit that you're highlighting. And that can be really effective, especially if you're trying to present things to people. Right, that's the end of that one. Next, we've got an anti-pattern. This one I call a spider's web. Sorry if people don't like spiders. Also known as unclear relationships. Now, you've probably seen diagrams that are a bit like this, and I bet they were a lot bigger and had a lot more lines and a lot more things kind of crossing over. And a little spider there is very happy in this diagram. So how can we kind of improve this? There's lots of little techniques that you can use. And I'll show you this on the diagram afterwards. But the first thing you can do is just remove the unnecessary information. Don't try and put all the information into one diagram. Think, what am I trying to communicate? If it's not important, like if you have all your little security protocols in there or something, if it's not important, take it out. Okay? So that's the first thing you can do. The next, as I've said before, split those diagrams up. If you're trying to put too much information in one diagram, if it's getting really ridiculously big, split it up. You can remove things like, say, there's a database that all your services are talking to, or one particular service that all of them are talking to. Remove that, put a note in the diagram to say, I've removed it, and create another diagram that has just that service in it. If you actually even need a diagram, just put that service and then put all the services around it that are using it. Or put that information in a table. Does it need to be a diagram? So split them up. Then we're going to minimize the line crossings. So just moving things around can make a really big difference. And I'll show you how that makes a big difference in a minute with this one. And when lines do cross, you want to use a nice big line jump. So you want to use like a nice big arc, really obvious. Don't just use the little default ones that you get, because then they're not obvious. So we're using those. This one is quite a nuanced little thing, but if you can standardize where you put your labels, like say at the beginning of the arrow or in the middle of the arrow, it makes it so much easier for people to easily see which label goes with which line in your diagram. So definitely do that. And then last of all here, we can use angled lines, or what's called orthogonal, if I can say it. This makes the relationship a lot clearer, and I will show you what these are. These are normally a standard setting when you're using various software to draw things. But you can see on this side, I'm using these orthogonal lines. They've got these right angles in them, and it means that you can drag that part of the line and move bits around so that you can adjust where things are in the diagram. It makes it so much easier to make it much more legible. So if we look at the full one, I've actually managed to get it so there's no lines crossing just by moving things around here. I have put the labels generally at the beginning, but there's always an exception, like these two up here. I'll use my pointer. So this one here, it would have been more crowded at the bottom there, so I've moved that up. This one here is in the middle of the line because putting it up there would have just been a bit silly. But in general, I have put them towards the beginning of the arrow, and it just makes it much easier for people to just scan it and read it. Now, an interesting statement here, diagrams are free. And one of my friends, Neil Ford, likes to say that slides are free when you're making a presentation. So that's basically saying if you make a presentation, more slides is better. Don't cram everything into one slide. And so I say the same things about diagrams. More diagrams is better. Don't shove everything into one big diagram because it's just going to get too confusing. So create more diagrams. Split them up. Right, another anti-pattern here. We're going to talk a little bit more about colour. Now, this is a fun one. This is all about relying on colour to communicate. Now, you've got to wake up again now. Okay. I have simulated protanopia, which is a type of colour blindness here. One of these is yellow. Which one is it? Put your hands up if you think it's A, B, C, and D. In that case, it was D. I've now simulated a different type of colour blindness. This one is tritanopia, and I've moved them around. So, which one of these is yellow? Is it E, F, G, and H? Now, it's always interesting, this one. I get a much wider spread of people with this one, but also there are a lot of people who go, I'm not even going to vote. So, in this case, it was E. And you can have a look here, I've lined them up correctly. And so you can see, actually, it's not just don't use red and green, because there are an awful lot of different types of colour blindness. And here they are. So some people who have colour blindness or colour vision deficiency can see the colour partially, some can't see it at all. There are a very small number of people who cannot see colour at all, which is called chromatopsia or monochromacy. And so we might think, oh, there's only 4.5% of the world's population. I don't really need to worry about that. But it's actually 1 in 12 men and 1 in 200 women. And if you think about the tech industry at the moment, there's an awful lot more men. So you're actually more likely to run into someone in the tech industry who is colorblind. Now, maybe someday that will change. I hope it will. But at the moment, you are more likely to have someone who's colorblind in your audience, be that an in-person audience or be it in a team or in your company. And it's actually more than 350 million people worldwide. And if you think about that, it's quite a lot. That's more than the entire population of the USA and about half the population of Europe. It's a lot of people. And there's a few things we can do about this. If you are working in the web, if you're creating a UI, there are tools within the browser in the developer settings which you can use that will simulate these different types. And so you can actually look at it yourself. They're not perfect, but they're better than not using it. There are also ones that you can install into your browser, but I know a lot of people can't actually do that on their work laptop, so it is built into things like Chrome and Firefox. You just have to fiddle about in the developer tools to find them. And so if you've got a palette, this one I just pulled out of a picture I quite liked. I kind of pulled out some of the colours. You can then have a look at it with these different simulators. And you can go, okay, there's my palette. But when I look at it, these colours are really similar for some people. And what you're going to do about that? Easiest thing is just take one of those colours out. If you don't need those colours, just remove them. The other thing you can do is you can change the lightness or darkness of that colour, but then you're going to have to do that check again to make sure that it is different from everything else. Now, I've said use a colourblind simulator. You're probably thinking, I do not have time to do all this. If you do one thing with these simulators, have a look at it in monochrome. Because if you can't tell the difference in monochrome, somebody is going to have a problem with it. So that's the big thing. Do that check first. Nice and simple. The other thing we think is that when we use a tool like Visio, if you use Visio, I'm sorry, I tend to use Draw.io, which is free. You can use it in the browser. It's really useful if you're running workshops and things. If we use some standard colors from Draw.io, you'd think, oh, they must have thought about this. Nope, no, they didn't. If you simulate it, oh, I now can't tell the difference between those colors. So if we have our color deficiency friendly palette, we can do a check there. And yes, they look very different to our original colors, but they also look very different from each other. So if you're looking at a key, someone will be able to tell the difference. Do not trust that your corporate palette has had this thought put into it, because they usually haven't, even in this day and age. So you probably want to check your corporate palette if you're using that in your diagrams. So we want to be thinking about that. Whatever software you're using, you cannot trust it. So the big message here is don't rely on color alone. So if you can't do this, or you're thinking about, okay, I'm not just using color. Come on. Look, I've put a key in here. This is fine until we see it in grayscale. So as I said, this is the biggest litmus test for whether colors work. So one of the other things you can do, apart from actually fiddling with the colors, is to use pattern. Now, all you need to do here is make sure that this contrast is big enough for people to be able to see that, especially if people don't have like full sight. You can also use symbols. I've been using these throughout. I haven't used any color to differentiate between patterns and anti-patterns. I've just used the ticks and the crosses to show the difference between them. So here we have a few things. We can use patterns, we can use symbols, we can use labels. Labeling things in your diagram or in a graph works as well. Along with the color, you can throw the color out if you want to. We can choose the colors with the different saturation levels, as I said before. We can use that simulation tool. We can consider monitor and projector color calibration. So this projector, you're actually seeing different colors up there to what I'm seeing on there. So when I share these slides afterwards, you'll be able to see the difference. But when you actually make sure that the colors are can be differentiated, that will mean even if they look different on a screen, just like today, they will still look actually different. Now, I had, it's interesting, at another conference I did this talk at, they actually had 2 different projectors because it was quite a big room, and the colors were different on the 2 different projectors. So it just illustrated that point really nicely. We then can look at the grayscale. That's your big litmus test. Right, another pattern now. This one I call written in legend. Basically using a key or a legend, as I was saying before. So don't rely on your audience having specific knowledge. You may think, oh yes, all my developers know about this technology, but they may not. You may think, oh, everybody knows what these letters, this abbreviation stands for. No, they don't. They all think it stands for something different. So don't rely on your audience having specific knowledge. We can use a key and legend to make sure that people understand. But this is going to be a big balancing act, because you're going to have some people who are going, oh, I know this. Why are you going on about this? And we can think about this as kind of these ramps and steps. So we want to provide this ramp for the people who need it to get up to speed. But if you can say, oh, just use the steps if you want to, you can skip this bit. It kind of gives that balance. And so you're not annoying some people and teaching them to suck eggs, whatever that phrase actually really means. I don't know why you would want to do that. But you are kind of getting that balance, giving people the information they need without boring them. And so even if you've got a diagram such as this one, this is a domain story. If you have not seen domain storytelling, I can recommend going and have a look at that. Really, really useful collaborative tool. But you might think, oh, I've chosen these icons. People know what they mean. Don't assume that people will see the same thing in that symbol as you do, especially if people are from different cultures or like different ages, things like that. People will see things differently. So include a key, tell people what things mean. These numbers, you might think, oh, it's all obvious that that's the order. But some people might think, oh, it's priority. You never know. So tell people what these things actually mean. What we were trying to do is not leave things open to interpretation, because you do not want to give a diagram to a group of people and for, like, say you've got a diagram and several teams are going to be working on it. You do not want one team interpreting it in one way and another team interpreting it another way, because they come back and things do not work. So back to UML again. Everybody loves UML. Everyone understands UML, don't they? No, they don't. They never did. So we want to be including a key. But I've also told you to try not to clutter up your diagram. We don't want to kind of annoy people. There's a couple of things you can do here. You can either just include the little bit that you need. So this bit here is the only bit you really need to include there. You can also, if you're creating a wiki or a web page of some sort, you can hide things. That might open in a new tab. It might kind of just show the diagram for people and they can open and close it, show the key. So there's different ways that you can help people to understand. Even C4, this is supposed to be really easy to understand. Anyone should be able to read this diagram because it's quite simple. It's got all the information you need on it, but Simon Brown, who created the model, said use a key. Always use a key, even if, like, maybe you've got 6 diagrams on the page, put the key just once on the page if that's what you want to do. But give people that information so that they don't misinterpret what you're saying. It can be really, really expensive if people don't understand what you've put into your diagram. So what we're doing here is that we're limiting our assumptions of what people will think of our diagram. And we want to limit people's assumptions all the way through when we're creating software. So when you're at the sort of gathering requirements and things like that, you are going to be writing down any assumptions that you and your team are making, and you need to go back to stakeholders and say, right, we've assumed this, this, and this. We need you to sign off on them. So you're doing that already in your kind of your software, your project management. You want to make sure that you are limiting your assumptions of what people think when you are creating your diagrams as well. Now, sorry, you're going to have to think about this anti-pattern. Thinking hats on. So this is multiple letter acronym HELP, or MLAH. Big thing here, if you take nothing else away from today, only use defined acronyms. Will make everybody's life so much easier. So when you are speaking, you should be really thinking about, I need to use the acronym. So throughout this, I've been using AKA, also known as. And so if you say both of those things, people get the opportunity to learn and put them together. And so next time they hear either the acronym or the long version, they will understand it. But if you don't give people the opportunity to learn and put them together by saying them together, then they won't understand either one. You can also, when you're writing things, define them together. So depending on how long your piece of writing is, like if you're writing a blog post or something fairly short, you can just define it once towards the first time you use it. If you're writing something a lot bigger, maybe it's your knowledge base, maybe you're writing some kind of white paper presentation, you might need to define it more than once, or put it in something like a glossary. If it's in a diagram, put it in the key. If you're trying to save space in your diagram, make sure it's still in the key somewhere. So, thinking hats on. What does DRY stand for? Shout it out, I can't hear. Don't repeat yourself. Very good. Right. What does DFD stand for? Data flow diagram, well done. We saw some earlier. SPA. Yep, single page application. And BLT. Yes, bacon, lettuce, and tomato. Or is it business leadership team? Basic language translator? Bulk loading tool? Be like that. You get my point. People could be reading different things into an acronym, even if it's something like, yes, that's obvious. It's definitely bacon, lettuce, and tomato. It's not obvious. People can even be from, you could come from the same community, go to the same schools, and still think that these things are different, have different meanings. It's really easy to fall into the trap of thinking that other people have the same ideas as you because you've got really good ideas in your own head. Well, I hope you do anyway, or at least think they're good. You have this understanding, and yet we kind of forget that other people haven't had the same life experiences as us, because even if you've got an identical twin, they haven't had the same life experiences as you. And so we need to remember that one tiny little thing could really, really screw up a project, cost millions of pounds. One tiny little misunderstanding, very, very easy. So next time you use an acronym, I want you to think SIDI, which stands for state it, define it. No, I am being silly there. I'm not trying to create another acronym, but I did just follow it, so that's all right. Right, another pattern now. This one I call a push in the right direction, also known as, AKA, match the diagram flow to expectations. Now, this is quite an interesting one, because all diagrams have some kind of flow of information in them, be they a behavioral diagram or a structural diagram. And so when a diagram like this one is created without thinking about how someone's going to read it, it becomes really difficult to even work out where to start looking at this diagram. Have you worked out where this diagram starts from yet? It's down here in the bottom right, of course. So when we're looking at a diagram in English, English goes left to right, top to bottom. So what we can do is we can create that diagram so that people will be able to easily read it. So now we've got the start over here. There we go. So the customer's there. We've got requests going left to right, and we've got the responses going right to left. And because I'm following that pattern throughout, it's really easy for people to see how to read the diagram. It's also made much nicer because it fits onto the slide as well. So that's another thing that I talk about in the book, is thinking, where is this going to be shown? How many people have printed off a diagram on an A4 sheet of paper in the last 5 years? 2 people. Whoa, that's amazing. In the last year? Whoa. Anyway, 1. So we don't put diagrams on paper anymore. We look at diagrams on screen, which is the other way around. So think about that when you're creating your diagrams. How are people going to view them? When you're using something like a sequence diagram, these are much easier to get right, because as long as you get whatever these items are at the top, services, day store, whatever they are, if you get them in the right order, you can get a nice flow in there. If these were in a different order, this would go all over the place, probably cross over other lines. So just think about how you're going to order them, get that nice flow. We've got that left to right, right to left, really easy for people to understand. So the big thing here is that you're going to consider how someone's going to read your diagram. Now, when you're creating the diagram, you've created it, you know where it starts from. Try showing it to someone else. Say, where does this diagram start? If it takes them more than about 5 seconds to work that out, you probably need to rejig it a bit. If you have a diagram that someone else created, or you don't have the original, and you're thinking, I don't have time to recreate this diagram, you can use some other things in there. You can have like a big sort of "you are here" sort of hand like you have on a map. You can use numbering. If stuff jumps all over the place, just put a 1, 2, 3, 4, 5, 6, like that. So people can actually use it. So even if you can't edit the diagram, you can do something to help people read it. Right, another pattern. Show them the pirate ship, also known as enthrall your audience with the context. Now, this is actually named after a chapter in Gregor Hoppe's book, The Software Architect Elevator. So anyone who is involved in software architecture, I recommend having a look at that. Another good book. But he likes to talk about these as Lego, or as he calls them, Legos. I think they do that in America. And so he says, when you look at the cover of a box of Legos, you don't see a picture of the individual bricks inside. Instead, you see a picture of an exciting, fully assembled model positioned in a lifelike pirate's bay with cliffs and sharks. Now, we're not creating diagrams for children. At least some of you might think you're creating diagrams for children, but we're not in general. But this still can help us. So when we're thinking, right, this is what we want to talk about in this meeting. So let's just jump in there and start here. We're at the second level of data flow diagram. We want to talk about this flow here. But what we really need to do is we need to start from the beginning. We need to make sure that people understand where we're going. And then we can jump into where we need to talk about. And so we can order our diagrams as we look at them like this. But really, that's not the beginning. Remember, I talked about the context being at the highest level. Maybe we need to start from the context. Maybe we need to go into more detail and go through this. And when you're talking to one group of people, you might need to spend a lot of time at this level and this level because they're new to this project. Other people, you might go, okay, yes, we talk about this, then you go straight to the next bit, and how long you spend at each level will vary depending on who you're talking to. But don't make the mistake of starting too late in the story, because if people don't understand something, you're going to get lots of questions or you're going to get misunderstandings. So one thing you can do is have a look at all of your diagrams and documentation and kind of put them in order and see if you've got any narrative gaps in there which you can fill so that you don't get those misunderstandings or really annoying questions that you can't answer easily without producing a diagram. So there's a little bit of homework for you. Sorry. Right. We are going to go for one more. There we go. So this one is a pattern which I call strike a balance. And this is a nice kind of little icing on the cake one. Now, humans actually really quite like balance and symmetry. There's a good quote here by, I'm not going to try and pronounce her name, I'll just get it wrong. But balance is an innate, fundamental human expectation. So if you can give somebody something balanced, they're going to like it more. And if you're trying to convince someone of something, then you want them to like what you're showing them. So this is perfectly fine C4 diagram. There's nothing wrong with it. It's easy to understand. But what about if we just jig it around and balance it? Now, I don't know if it's because it looks a little bit more like a Space Invader, that people like it more. I think it's just because it's balanced. And I've even managed to make it nice and balanced with the database shapes as well. It doesn't have to be, but if just the general balance is better. But do not sacrifice the clarity balancing it. That clarity is more important than balance, but you can use balance to enhance the clarity once you've got things nice and clear. Make people a little bit more happy. Now, as I said, these are just a few of the patterns and anti-patterns which are in part 1 of my book. You can all access that now if you want. But check out the book website, which is also on the bookmark that you've got, because there's a few freebies on there and it shows you all the diagrams that are in the book as well. So, told you I would put this up again. I really do appreciate feedback because it does help me improve, and I'm sure it's all going to get passed on to me as well. So that would be really useful. And so I'll say thank you for coming and exploring a core skill, because these adjacent topics really are useful to you, and you have made that decision to look at these adjacent topics. So thank you very much. And if you do have any questions, even if we don't have time, come and find me. So thank you.
Hey everyone, it's good to be here at Agile on the Beach, my 6th year, second time speaking. It's colder than previous years. First time I actually had to wear something over my t-shirt. So today I'm going to be talking about how we can get better at explaining counterintuitive ideas in software delivery. And I hope by the end of this talk, I'll get better at pronouncing counterintuitive. But it's a bit of a tongue twister. My name is Hibri. I help teams deliver software fast, and I want them to enjoy doing so and be happy. I'm a principal engineer at ClearBank. I help build the platform so that the devs can do all of that. My feedback code is right there, so if you want to take a picture of that or scan it, I'll put one up at the end as well. So, software delivery is hard. It's really complex. That's why we're here. It's hard enough that it justifies 2 days and a track dedicated to it, right? If it was easy, we wouldn't be here. We would be out there actually doing it. It's hard because it's not just copying files from one computer to another. You need to make decisions. You need to make decisions, like which file goes to that computer. Is a file good enough? We need to trust the things like Jenkins, the things that do the CI/CD, that they do the job properly, right? If that breaks, like, people shout at the platform team or the team that looks after the delivery. There's so many moving parts to make it work. Like, when I look at this, like, I'm not sure if the CNCF landscape, I can't tell the difference at this point. Like, putting all of these tools into a software delivery, like, it's just mind-blowing. I find it hard to deal with, increases our cognitive load. And it's just not the tooling, right? If it was just a tooling problem, we would have solved it a long time ago with Jenkins and cruise control. We now have to keep building new things like Argo CD, and I don't know what's the latest right now thing with ChatGPT and AI. So yeah, how we organize ourselves influences our ways of software delivery. And on top of that, you got to keep up with all these tools. You got imposter syndrome, fear of things breaking. Like, the platform team does deal with a lot of things, emotions. Like, when things break, they got to fix it. Lots of people shout at them. And yeah, got to. Oh, by the way, you also have to read the whole Accelerate book to get everything right. So yeah, it's all very complex, right? And on top of it, you have to navigate all the organization silos. Like, just people get siloed very easily. I've seen, like, even when teams are self-empowered, they seem to be self-empowered to get siloed. So it's hard navigating all of this. And most of us got into this so that, we can build cool things and, show our users. I got into coding by building screensavers. Like, you could build a screensaver, show it to someone, like, oh, look, the ball bounces up and down. So life was simple back then, before CI/CD. Is it a wicked problem? So these two guys Horst Rittel and Melvin Weber class problems as wicked and tame problems, right? So they say wicked problems are ill-defined. They have strong moral and political professional issues. They're highly stakeholder dependent. Sound familiar? There's often little consensus about what the problem is, like what are we actually trying to fix. These problems don't keep still. You know, once you solve them, they just don't go away. They just evolve into another kind of a monster. They're complex. They interact in a dynamic social context. And if you solve it, oh, there's a new problem to solve. And you know, they're often a symptom of a problem somewhere else. So how is software delivery a wicked problem? So if you look within your organization, everyone's probably got a view of how it should work. It's hard to get consensus. The ops team look at it in one way, the testers look at it in another way. You can't also see it as like binary, like, you know, it's not good or bad. How much test coverage is good? 100%? 30%? It depends. There are no one-off solutions like, oh, once you built your first pipeline, your platform, is it done? No. Just have to keep on evolving, managing it. And you can't take what worked in one organizational context and put it into the current context. I've fallen into that trap. You can't just, the Spotify model doesn't work anywhere else. And then, yeah, it's a symptom of another problem, like, you know, how your HR department set the salary bands and how the pipeline, their hiring pipeline works has an impact on your software delivery pipeline. You know, if you don't get skilled people, you can't build all of this. So to solve wicked problems, we need to change people's behavior. It involves breaking down silos by, you know, changing the relationships between individuals and teams and in between teams. Yeah, it involves change the nature of the relationships, not just the relationships like, no, do people just naturally talk to each other, or are they just sending tickets over the wall? Is it like antagonistic? You know, is the other team a subcontractor of another consultancy? You know, they've got different rules. You got to see different perspectives. Testers have a different perspective. Ops people have a different perspective. And it's not like that anyone is wrong. All those perspectives are valid, you know. And then, you know, you have to see the whole, get everyone's perspective, solve wicked problems. So we have solutions to these problems, and they are wrapped in these like heuristics and mantras that we keep repeating. If it hurts, do it more often. Slack time improves flow. Releasing more often improves quality. And a lot of us who've been in the industry long enough, like, we know how these things work intuitively, right? But it's hard to explain these things to non-technical stakeholders, people who are coming new to the industry. But also, in a dynamic, complex system, things change rapidly. And you suddenly see that, you know what, these heuristics just stop working. If we don't understand what goes behind them, it'll be hard to manage the wicked problem. So today I'm going to pick one of these, and we're going to see how to explain the concept and what's behind it. And I'm also going to break all the visual communication rules from the previous talk. So, yeah, last year I was listening to a podcast, and Nicole Postgren from Accelerate and Dora Frame said, The simplest thing you can do to improve quality is to deploy more frequently. Now that's counterintuitive. Yeah, how does it work? You know, if I tell it to a non-technical stakeholder, like, why would you deploy something that's broken more frequently? Shouldn't we test it till the end of the universe to make sure it doesn't have any more bugs? Right? If you know it has bugs, why would you do it more frequently? Yeah, that's counterintuitive. So in software delivery, we talk a lot about feedback loops. Software delivery is all about mastering your feedback loops. We know this, but how often do we actually model them? How often do you actually draw them and see, oh, how is this thing connected to the next thing, and how does it all hold together? So we need better models to understand and explain these ideas. And when I try to explain things, I end up looking like this. So hopefully it won't happen today, but I'll try my best. So if there was one thing you take out of this session, is how to model your software delivery system and sort of any system you're working with. We are really good at modeling the thing we're building, but we are not good at modeling how we build the thing. We're like, you know, we do user journey, story maps for the thing we are building, but how about the story maps and user journeys for, hey, you know, how do you have our retrospectives, or how does the team work? So yeah, that's also important to model. So let's get started. We're gonna tell a story by visualizing feedback loops. I'm going to use causal loop diagrams, and I'll explain what they are in a bit. Important bit, I'm going to tell this from my perspective, and I'm going to draw a generic model. The model you draw would be different. So obligatory George box quote, all models are wrong and some models are useful. So don't take my model and brand it Hibri's model, just like Spotify model, and implement it elsewhere. Cool. So why do we use causal loop diagrams? Causal loop diagrams have three basic elements. A box, a connection line, and a feedback loop. The connection line indicates the direction of influence. So here, A influences B. Don't worry about the quantity. They don't need to, you don't need to make sure they are of the same metric. It's more about the influence. So here A influences B, and then B influences A. The line indicates the nature of the relationship. So I've got a plus sign there. So an increase in A increases B. Well, if B increases, A increases. So that closes your loop. You can also have an inverse relationship. So reduction in A could increase B, and so on. The causal loop diagrams are one of the easiest ways to get into systems thinking. They're very intuitive. There are other models, other mapping techniques like Wardley mapping, rich pictures, stocks and flow diagrams. What's important is that each of those mapping modeling techniques gives a different perspective on your system. So it's always good to use multiple modeling mapping techniques to see different sides of your system. But we'll keep this simple today. So where do we start? We start with one variable. So because we're talking about software delivery, this is where our problem starts, getting something released. If we didn't give anything to our users, we don't have anything to worry about. So we start with the size of release. Why do you pick the size of a release? You could have these discussions with the people you're building the model with. In a release, there are a number of changes. Some of these changes will work in production. Some of these changes won't work in production. And we won't know what happens until we actually release it to production. So then we look at what that variable contributes to and other things that contribute to it. Right? So in this instance, like the size of release increases the number of failed changes in a release, the probability of failed changes in a release. Another way of looking at it is like, you get a box of chocolates. You like some flavors. I don't like the tangy ones. I give them to my wife. Raspberry, can't get on board with raspberry flavors. So the bigger the box of chocolates, the more likely the flavors that you don't like. So all we try to do in our software delivery lifecycle is to reduce the probability of the things that we don't like, your bugs, things that could blow up production. So let's see, where are I? Yeah, so when there are failed changes in a release, we're not talking about the successful changes. Something breaks, increases change failure rate. So we've established a simple relationship, like an increase in the size of the release increases the likelihood of failed changes in a release, therefore increases your change failure rate, right? So that's a simple kind of model, but we haven't closed the loop yet. So we need to go a bit further. Right, what happens when things break? Yes. And what do you need to fix it?
Time.
Very good. Yeah, while things are broken, you need to roll back. That also takes time. And or you need to roll forward by fixing the bugs and doing a new release. It all takes time, right? And this time is toil. It's time not spent building valuable things like new features. So in lean terms, it's waste. So the less time we spend fixing broken release, the better it is. So while we are fixing a broken release, what's happening? We're adding a delay to the next release. There's no way I can figure out like how to get two releases to exist on the same server at the same time. If you could figure out like a Schrodinger's production environment, it might work. So while we are fixing the current release and taking more time, what are the devs doing?
They're not building code.
Yeah, they're still coding. They're still typing, right? The double lines on the arrow indicate like a delayed response in causal loop diagrams, like something that's going to happen later down the line. It's not immediate. Yeah, the devs are still adding new things. They're still in their sprint. The release is broken, but they're still adding new features to their sprint. What happens then? The size of your next release has just gotten a lot bigger. What happens when a release gets bigger? More chocolates that I don't like, right? So the longer we spend fixing a release, the bigger that box gets, and it increases your probability of failed changes in the future release. So we're always thinking about the current release, like let's fix it, let's get it out, but no one's told the devs to stop typing. So by using a causal loop model, let me just kind of go back to that. Like we built a simple model. We've closed the loop. We've established a relationship with the current release and how it impacts the future release. This is our system engine. Like we can see now how our software delivery system works, and all these variables, they are the core variables that we have to deal with in our software delivery system, right? So now we can identify patterns, right? The first pattern is the reinforcing loop. I call this R1. So if you have a more complex diagram, you'll see a lot more loops. So the pattern here is like, why is it a reinforcing loop? So each variable increases the next one, and then it just gets bigger and bigger and bigger and bigger. It doesn't get worse over time. Till something else happens and everything either blows up, or there's other intervening factors that try to moderate the system. It also shows things that are in our control and the things that happen as a result of our actions. Like, we can't control the change failure rate. That's influenced by the size of a release. We could put an arbitrary limit on the time to restore service, but that depends on each incident. You can't say, I fix it in 2 minutes. Oh, what happens if you don't fix it in 2 minutes? We can't control this. We can control the number of new changes. Yeah, so it shows like where we can control the system. And so what we're doing here is like, we're seeing the system as is. We haven't changed anything yet. I haven't gone off and said, hey, throw away Jenkins and use Argo CD. I haven't intervened. I'm accepting the system as is. And when you do this, it's important to like test your model with a few recent releases. Just make sure like, your model matches reality. If not, add new variables, change the relationship. So it's important to tell the story of what's actually happening. So, even though this works, don't take this and use it on Monday. So, things are getting worse. There's a vicious cycle. Not all reinforcing loops are vicious cycle. It depends on what's happening. So, obviously we have to change things, right? We can't accept the system as is. So, to break the cycle, we need to reduce the influence of one thing on the next. So we have to like pick the things. Like as soon as like we start reducing the size of release, that will reduce the number of failed changes in release, and then that starts making the cycle less vicious. So let's start with a couple of like obvious interventions that we see, right? The first thing is like pretty obvious. Let's take more time to test everything before it's released, right? Again, what's that doing? What happens when you take more time to test a release? Yes, you find more bugs, but that's also, it's completely valid. You will find bugs, and then that reduces the number of failed changes release. So you're reducing that. Then, yes. So while the testers are testing, what are the devs doing? They're still typing, right? So we haven't really reduced the delay to the next release. And it temporarily fixes the problem. It's a Band-Aid, but you haven't changed the system. So if you have a culture of continuous flow, like if the devs are like stop the line, let's go fix everything, this works. So now we see the relationship between culture problem. The culture problem is reflected in your causal loop diagram. Right? Next thing, every December, just like a Christmas party, release freeze. What happens when you do a release freeze? So the longer the release freeze, the longer the delay to the next release is. So release freeze work only if you send the developers on holiday, when you send them on training or do something else, and have a complete code freeze. Like if you have release freeze and the devs are still typing, just tell the devs to go home. everything would be easy. Yeah, they just increase the batch size of the next release. So, yeah, but that's a cultural problem to solve. Let's look at other things that add to delays between releases. Let's take manual deployments, right? Manual deployments, yeah, they're okay. Okay, they work when they work, but when things don't work, they make things really bad. Like if you have a bad release and you're trying to do a manual deployment on top of it, it's like just ends up making things even more worse. It reduces toil, errors. Oh, now you got to deal with bugs in your release and errors in your manual deployment. Yeah, let's say end-to-end testing take more time, even if it's automated. When you do end-to-end testing, there's more fragility. It takes more time to find the fragile test. Let's fix it. Still more time, but the devs are still typing. So we looked at common interventions. They don't create lasting change. Taking more time to test things just makes things worse. So how do we make lasting change? Let's go look at an iceberg. So Donald Meadows describes where to intervene in a system using the iceberg model. So in our causal loop diagrams, what we see are events, like the visible part of it. That's the stuff above the waterline. An iceberg has more things that we can't see below the waterline. Modeling a system using causal loop diagrams helps us see what's below the waterline. So let's walk our model through from top to bottom. So events. Events tell us what just happened. Right? Hey, come in the morning, a release is broken, there are bugs. We can walk through recent release and see what events happen. Like, what's the reality? Like, this is stuff above the waterline that we see. So, and again, the model you draw will be different. But events are just the visible part of patterns of behavior. Once you add a time element and see events across a time dimension, you see patterns of behavior. How is one event connected to the other? So this is in a recent system I worked in, like after every sprint, custom issues, they go up. And after a couple of days, they die down. And then like clockwork, after every sprint release, they're doing a lot of manual testing. So we saw that pattern. So this we saw this in the Jira customer support cases in these graphs. So that's you see those patterns of emerging. So it helps us understand what will happen, what has happened before, by just connecting events over time. So patterns of behavior are influenced by the structure of the system. How is one event connected to the other? That's your system. So by modeling, we've seen this is your system. How the size of release contributes to the number of failed changes in a release. So this reflects your software delivery system. It doesn't matter what technologies, how you're organized, which team does it, right? All that matters is you got changes, they need to go to production, something will break, takes time to restore service. You could discard all of that stuff away, architecture diagrams, right? Because this is the behavior of the system. And the structure of the system is influenced by the mental models of people in the system, right? Because it's how we react to these events that defines what's the next event. So causal loop diagramming and system diagramming helps us see and visualize the mental models that drive the system. So in our example, we see that the mental model of optimizing developer productivity causes the overall system to suffer. And we can see that, if we have the other mental model of, if a team owns the end-to-end delivery, you get a different behavior of the system. And now we can, we know where the leverage points are. We can test our interventions. We can ask questions from our model. Okay, what if we introduce WIP limits? What's the impact on the system? So, if you put WIP limits, that puts a limit on the number of new changes. So that doesn't keep on increasing. So that now you're starting to reduce the number of new changes. That then starts to reduce this. And then things start getting better. So it's about finding finding the intervention that reduces the impact of these variables, and then that influences something else. So if we didn't connect one thing to another, we wouldn't be able to see what's the impact of our intervention. So that's any change you do anywhere else doesn't change the system. So that's where you get the highest leverage to improve your software delivery lifecycle. So always WIP limits are my go-to tool. Want to improve something, put WIP limits in. More on asking questions you could ask questions about incentives. I've worked in places where developers' bonuses were tied to how many stories they finish in a sprint. So that's an incentive that drives a number of new changes. So we're now going to the cultural things, not just the technical stuff. And if you have everyone has a mental model of start, finishing, stop, starting, that works towards WIP limits. So we now have a better understanding of what drives our system, and why deploying more frequently improves software quality, right? Deploying more frequently reduces the delay to the next release, reducing the number of new changes, reducing the size of a future release. That again reduces the number of failed changes in a release, and so on. So we see how things are connected. What's even more powerful, it's fine for me to do this by myself, but if we do this collaboratively, we bring everyone else's mental models out. Right? Everyone has a different mental model in their head, and this is one of the things that causes wicked problems. We hold different mental models in the head, and there is conflict. We have different ideas, different perspectives. So by modeling collaboratively, we're able to resolve those conflicts. And collaborative modeling, by seeing the diff between people's different mental models, gives us more leverage in the system, because now we know what people are thinking. So counterintuitive ideas, our mental model, shape our system. They shape the system structure, the patterns of behavior, and finally, what's actually happening. So this is all in our head. So this is why it's really important. It's how do these things work? Because we might solve the problem, but if I kind of go back to my model, anything could change here to make the system go back to its previous state, right? So, and again, we can also see how different mental models make different kind of events happen. Releasing once a month keeps us safe. You can test the impact of all of that. So it's if someone in management says let's go back to our old ways, this releasing frequently thing is too risky, we can go back to a model and say like, okay, this is what happens if we go back to these behaviors. We can start experimenting with the impact. So this leads us to non-linear strategy, because wicked problems, solutions to wicked problems, don't fit neatly in a Gantt chart. We can expand our model and see like, so it's pretty rare that you'd come up with something clean that's self-contained within your own team, right? Our software delivery system doesn't exist in isolation, and the Accelerate book does a good job of explaining all the different factors that impact our software delivery performance. Like, you know, is there a learning culture in the organization? That impacts, can people learn automated deployment? Is there funding for new courses? Is there funding for a new skill? Is there slack time to invest in new learning? Attitudes to collaboration. Are people ticket-driven, or is there psychological safety that, you know, if there's something wrong, that we can go and talk to someone and get it fixed? So, you know, all of these things have an impact on your system. But you can expand, but up to a point. You need to draw boundaries. Like, I can't bring my home life into this. I still have to keep things in focus. Yeah, so you can expand up to a point. And when we started on this journey, you'll see that, you know, we accept the system as is. Like, the system has a certain wisdom. So, you know, that's why it's important to, you know, model the system as it is before jumping in to change things. It allows us to observe, ask questions. Most importantly, like, you know, the system exists because it works, right? We've all worked with, you know, big banks and large enterprises. Like, we think like, you know, this shouldn't work. Everything should collapse. This is really awful. It's dysfunctional, but they survive. Because, you know, the system works. And sometimes, you know, the system pushes back. So if we go off and change things without understanding the system, we can't make meaningful change. So it's important to understand why things work as they are by modeling with systems thinking, and find the real leverage points that will give you lasting change. Yeah, and, you know, strategy isn't static. You know, you got your model, you can tweak things, you can see the impact of things, you can add things to it as time goes on. So, you know, it helps us coexist with a complex dynamic system. Yeah, so we have to understand the dynamics. It's just, things are not static, things are moving. And in our modeling, we should figure out a way to model that movement over time. And, you know, iterating, continuously improving our models collaboratively, which means, you know, more people get involved itself is a better strategy, because, you know, now by modeling collaboratively, you influence their mental models. So, you know, that could be like your simplest strategy to deal with a problem. Let's just model things together. Love this quote from Diana's book, Models are Conversations. Like, the model I showed is a conversation with myself. But, you know, if you talk to someone else in your team, in your company, you'll get a different model. So it's important to establish healthy and impactful modeling process. It doesn't matter, you know, which tool you use. Yeah, and because everything's really complex, we've got to like figure out how to dance with the system. Like, we can't just, you know, a lot of us here are consultants. We go in thinking like, oh, look, I can pull strings here and there and change things. But, you know, after a while, we burn out, get frustrated. Like, I'm not going to work for this client anymore. Yeah, so we have to learn to coexist. And before I end, I'll leave you with a Dirk Gently quote. Who's heard of Dirk Gently? The holistic detective, yeah. he has a holistic approach. He just waits for things to happen and just like believes in the fundamental interconnected of things, like, you know, what his cat had for breakfast has an impact on the murder investigation he's doing right now. So yeah. Before I end, always like giving book recommendations. I did start reading Thinking Systems at first, but it didn't make sense to me at all. There's a really good Open University 8-week course. If you're in the UK, it's free. It teaches you all about causal loop, diagramming, systems thinking. It's free. And then I read The Grammar of Systems. This is by Patrick Hostad. It's really good. Helps you like make sense of all the different systems thinking archetypes, patterns you'll see. And then, O'Reilly, Learning Systems Thinking. And these two books kind of very deep, but I keep coming back to this. So thank you. And before I go to questions and my feedback. Thank you. Hope that made sense. Yeah.
5 minutes for questions.
Yeah.
I have a question.
Yeah. Well, okay. I'll pull this up.
Is there a mic? No? I had the best fucking time. That was excellent. Thank you.
Thank you.
I'm very fallible. Like, so I've been really black and white, and I will be like, okay, I am so sure that this will lead to this. And then I'll be really surprised. Like, that wasn't what it was at all.
Yeah.
We just have to accept that we have to, like,
Yeah.
the model once we learn more? Or...
Yeah, you have to always change your model as you learn more, because, you know, like, again, you know, just like your system, no model is going to stay static. Yeah. So it's important, like, you know, for this to reflect reality, so it can actually tell a story, like, you know, to real events. You know, these aren't just abstract things. You know, we should be able to tie these to, like, you know, this is just a starting point of a huge topic called system dynamics. Like, there are complex modeling techniques where they feed these variables into computers and model the thing. Donald Meadows contributed a book called Limits to Growth, where they model the economy of the planet, and it's like the prediction they did 30 years ago are true. So, you know, these are variables, like, we can measure things. We do tend to measure things in isolation, but we don't connect the measurements into a much more dynamic model. That's kind of like the next stage of causal loop modeling and system dynamics, like getting data and, you know, putting them in graphs, seeing the patterns over time. Yeah, it has to match reality.
Can I ask another question?
Yeah, anyone else? Anyone else? Yeah.
When you're mapping a team and their behaviors like this, can you tell the team that you're doing this?
It depends on psychological safety. Like, this is kind of the dilemma. If you go to team and say, like, oh, I'm going to do systems thinking, and then you kind of have lost them. Just focus on telling stories. Like, I've used just simple Post-it notes to go through through a blameless postmortem. Okay, this thing happened, and then this thing happened after that. No drama. And then later on, I can change that into causal loop model and iterate. It's just, sometimes, you know, this took me several goes. Like, you know, you're questioning, are these things right? Are the words right? You kind of have to get all of that correct.
Does the team know that behavior has to change?
If they see it, if they see the impact of their behavior, then you're going to their aha moment. It's like, oh, the change comes from them because they see things instead of me telling them, like, you know, this is the thing you have to do. Because, you know, we end up in silos. Usually software delivery system is spread across many silos. Like everyone's trying to do their best job, right? What this modeling does is like it removes the blame from the silo and the individual to like, let's just focus on the events. Like, let's just see what happens. You blame the system, not the individual. So this is a system that we can blame. Yeah.
Have you found? So can you tell us about an assumption that you made that was wrong in the past? That you were like, oh, I thought it was this that was influencing this, but like, or
Yeah. Yeah. So no, actually, I can't remember. Sorry. I did make some assumptions when I was doing this, but as I was trying to connect it, it's like, oh, that doesn't make sense. I have to change. I have to change that. I published a blog post on it. Like, this model is different from the diagrams I have in my blog post, and also how I add the plus or minus signs. Like, I'm also telling a story, so I have to like figure out like, is this really clear? I'm pretty sure someone else, if I work with someone else in here, we'll be able to come up with a better model. Yeah, and by doing that, like, it challenges my own assumptions.
Thank you.
Thank you. Yeah.
That was great. Do you think you could build one of these for what was on in your house?
Yeah, like, can, like, family is a system. Like, I like don't, my 2-year-old has a tantrum. Like, I think about like, oh, how do I react to the tantrum? Do I match the anger, or do I stay calm? The more, if I'm angry, she gets angry, and then we get stuck in that vicious cycle. So it's like, oh, how do I break the cycle? I've read that there are therapists that use this. Yeah. Oh, thank you. Hope you enjoyed that.